Welcome to the 2024 edition of the Engine Performance Expo. I'm Joe Costello along with Lake Speed Jr. and we are about to embark on a journey, high performance, engine technology, machining, machinists, some of the greats of the industry are all right here, Lake.
Oh yeah, you know, it's like the Chinese New Year doesn't come on the Roman calendar. This is like the New Year for the engine building world. This is it, man. The Engine Performance Expo is an annual event, we can call it now, right?
Yes.
And after all these years, this is the fifth one in 4 years.
That's amazing that we've done this 5 times, or we've done it 4 and this is the 5th, regardless. And people are beginning to rely upon it, right? It's the start of the year. We go to the expo.
Yeah, and the thing is, it takes a whole year to put this together because we go all over the place. Over the next 2 days and the 14 hours of live stream we're gonna do, we will crisscross the country from here to Seattle and back and all kinds of places. And we're gonna do everything from visiting the legends of the industry to doing things like machining a block.
Yes.
This block has significance. This isn't just any old block. So Joe, tell us a little bit, because this year, it's personal.
This year it's personal. That's exactly right. And I want everybody to know out there that I'm freaked out a little bit. Being involved with this group of just celebrity engine builders, right? The highest level of the highest level has been an amazing learning experience for me. But when this guy said, hey Joe, don't you have an old Pontiac engine in your garage that you want to do? It's like, yeah, we'd like to bring it back to life and showcase some technology. I thought, wow, that's amazing.
Yeah.
And so Gary Stinnett decided to do the engine. We shipped it out to him. We dyno tested the thing. It was great. But then he revealed that the block.
Don't go give it away yet.
Okay, well.
No spoilers.
Okay, the point is this. We've moved forward. But where did it all start? How did this thing start? Racing is about high performance and it's about fun, but really it's about relationships and family.
Absolutely.
And it started that way for me with my dad at Moroso Motorsports Park, Palm Beach International Raceway in South Florida, way back in 1992. A local television production company wanted to follow some local bracket racers, dads and sons, racing together to see what it was all about.
Yeah.
And they followed me. And so this was the very beginning of Project Pontiac.
Oh.
Check it out.
Whoever I'm racing, I kind of look at them, you know, get a mental set. That's who I want to be. Each round, you got to run someone different. Like him, for instance.
I just know I have to do it just a certain job, you know. So I'm only on the track for 9 seconds.
Last year was really his first competition, and it's evolved to this in 1 year.
They just called us for first round time runs.
I find that I miss racing myself a lot. I've given it up so that my son can race, but every time we come here, I get the bug.
You're doing things together. This is what all parents and kids, I think, really dream about, is being able to work together.
The first runs I made were hectic runs. You're like, let go of the button. Shift. Off, drive. Okay, scoreboard, let up. Helmet off. It's a hectic thing at first, then you get used to it. It was a lot of fun.
He beat me by 15,000.
15,000 to a second.
Separate sticks from beans. I was rooting for him so bad. I was rooting, screaming. So great.
Well, Joe, looks like we have a problem.
Man, that is so cool. I mean, I feel the emotion right now, you know, because obviously my dad and I have been able to go race together. To see you and your dad to have that moment at the racetrack, winning, dude, that's what this is all about, man.
Well, it really is, but you don't know in that moment. Like, I wish I could go back to that moment and get out of the car and tackle my dad and give him a big hug. He's still with us, fortunately, and that's what we're trying to do now. The idea, it's so hard to win any kind of race, any kind of series, at any point,
Right.
that a TV production crew for local PBS, whatever, they came out, they followed us, and I won the race. I can't even believe it to this day. And boy, I look, you know, what happened? What happened? I was young, I was thin, a little awkward, don't get me wrong, 19 years old right there, I think, but that's where it started. And that spark ignited through my broadcast career and working at the National Hot Rod Association and now doing Engine Performance Expo and working with you guys at Total Seal. And now we're bringing it back. And
Exactly. Resurrection Project Pontiac. One, your car's pretty freaking cool, man. That's a good looking car.
thank you. Purchased brand new in 1978, JM Pontiac, Hollywood, Florida. That is a one-owner car. So it is a family heirloom. It's been in the garage for over 20 years, just kind of like not working out, but this is the resurrection. And we're bringing it back, and thank you to everyone who's been helping out. And we're on this journey now. And as tends to happen with many journeys, this one is getting out of control, and it is already off track. But we're bringing it back. And it is just so exciting. And the people that have been following Project Pontiac on my WFO radio podcast live stream, they're more interested in this, like personal stuff. I don't normally talk about me. I'm always talking to someone else, interview someone else. And so it's been a very special thing so far.
Well, what I love about this is it's that put up or shut up nature of what we're talking about. Are we going to be here for the 5th time yapping about stuff? Where's the proof in the pudding? It's great to have the big names and celebrities and everything, but what does that mean to you? Can you realize and actualize the things we talk about here on the Expo? Can it actually translate to you, the viewer? Can you put it into place? And we're putting it in place for you. So we're saying, hey, you're just like the people that watch. Can we take this technology and put it into play? I mean, obviously the great thing is with Gary, yeah, the engine ran, but the block was broken.
Yes.
There's a lesson there, by the way.
Multiple.
We can really rabbit trail on that one just for a second, that just because an engine runs doesn't mean everything's great. You know, you call the guy who got a C in medical school, doctor. You know, it's like, so you can go better than just what works. We want to reach for the best. If you want to try for perfection, for ideal scenarios, you got to do a little bit more. Obviously, the engine was running.
Well, we did the dyno test, sent it to Gary, did the dyno test. The whole plan, we were just going to ring it, hone it.
Yeah.
As it was. And then discover it made 603 horsepower, which I thought was a good number after sitting for 20 years.
Yeah.
And for the Pontiac people out there, you have to remember at the time that engine was built, there was no aftermarket block option. There was no Edelbrock aluminum cylinder head. There was literally the Doug Nash Warrior intake was available.
That's it.
And that's pretty much it. And so to make over 600 with pretty much all stuck, we have a cast crank, guys.
Yeah.
Done by Nunzi, by the way. Ground and chromed
Nice.
and all kinds of good stuff. But now everything is available. There are choices and options and things to do. And people are making a lot of horsepower with Pontiacs. Pontiacs have come back into flavor. You can go bigger than 468 cubic inches now, something you couldn't do back then, with all the technology that we've been showcasing on the show. So it's exciting, it's interesting, it's an all-star cast of people that are helping me, which I'm genuinely struggling dealing with that, but don't worry, I will to try to get this thing on the track, and with a defined goal of running NHRA Super Street at the NHRA divisional level. This is not just to build a car, this is to go compete with.
Right.
And since I'm an NHRA track announcer and part of their crew on NHRA on Fox, I think it will be better for me to experience what the drivers that I'm talking about experience, the pressure and the intensity of competition, even at the NHRA divisional level. So that is the goal, to get Project Pontiac on track, NHRA Southeastern Division 2 racing in 2025.
All right, so next year, you're going to hit the racetrack with it.
In theory,
So
that's
that
the
gives
plan.
us this year to get that engine together. So we started off, we were back there at the Rottler F69 because that block was basically brand new.
Yes.
And there's a lot of work that was going to be being done to that block today and tomorrow. So right now, you've got Jolie.
Jolie Wood's on it.
Right,
She's on
from
it. Dave
Dominator's daughter. Yep. She's back there working with Dave Bullock on the F69, and they are going to deck it. They're going to do a line bore, and because of the cam on it, they're basically going to do a cam line bore as well. So they got a lot of block work to do on the F69. We'll come back and check with them later today to see how they're doing, because lifter bores and stuff, they all had to be worked on a little bit.
The casting is much better, but everything has got to go through a process to make it perfect, and that's what we're going to try to do.
Got to get the right geometry. So that's what they're working on. And speaking of getting the block work right and father-son projects, you know, last year we had Dennis Borum up here and we were talking about my dad's project, where we took my dad's old engine and pulled it out and freshened it up and put it back in the car and went to the racetrack, and we'll show more of that later today and tomorrow. But, you know, we had 2 engines, not just one. And so I played around with the second engine.
Of course.
And we tried a little bit more, and I pushed a little bit too hard. So watch this video and we'll show you what we did. Have you ever hurt just one cylinder? I mean, that's such a pain in the butt, right? Because you hurt one, what are your options? I mean, you don't really want to have to go 5 over and order brand new pistons if you only hurt one cylinder. So that's what we're going to try to do, because we scuffed one cylinder here pretty bad. So what we're going to try to do is we're going to try to see if we can't clean this up in less than 5 thousandths. That way we can actually reuse the other pistons, replace the one piston that's been scuffed. Then what we're going to do is use line-to-line skirt coating on all the pistons to bring back our piston to wall clearance. That way we're saving the money of not having to buy new pistons, not having to hopefully wait as long, because hopefully they can get 1 done faster than they can get 8 done. But the idea is, let's try to save as much material in the block as possible. So if we only have to go maybe a couple of thousandths to save this one hole, then we can go a couple of thousandths over on all the others, use the line-to-line skirt coating to make up that couple of thousandths, then we're back good again. So let's see. So the first step in this process is we've got aluminum in the cylinder wall. So to make it where we're not pushing that aluminum in with the hone, so it has to go further and further and further, we're going to use an old trick. We're going to use like Drano liquid plumber type products, along with a little bit of Scotch-Brite and some elbow grease, and we're going to work in here and see if we can't get that aluminum out of the cylinder. That way when we go put it in the hone, we're not moving all that aluminum around trying to clean it up. We're just going to be cleaning up the iron. So hopefully that's going to save us a little bit, because if we can only go 1 thousandths or 2 over, man, we're going to be in good shape. It's going to be pretty nice. So let's get started. Fortunately, we have our USB microscope that lets us look in, and we can use the hatch view crosshatch angle program. Now here's the neat thing. We can go in there and turn the crosshatch angle off, because we don't need that. And then we can actually see right here is a big piece of aluminum. You can see down at the bottom where it's iron and it's darker color. This is nice and shiny, that's the aluminum. So let's see with our liquid plumber and our Scotch-Brite if we can get that aluminum out and clean this bore up a little bit easier. First step, gotta get the old good liquid plumber. Now the key thing to be smart here, you definitely want to put on some gloves because you don't want to burn yourself. Regular lye is actually better than liquid plumber, but liquid plumber is easier to get. But if you can get some lye, that's the way to go. So what we're gonna do is put our gloves on here. There is definitely aluminum visible in the bore right now. We're gonna pour some of this down the hole here. This is pretty liquid, so what we're gonna do is we're gonna put some of this directly on the Scotch-Brite pad. And then we're gonna apply a little bit of elbow grease here and see if we can't get that aluminum out of the bore. Looks like it was actually worse at the bottom of the bore than the top of the bore. Okay, so we've been using some elbow grease, and we've actually seen really good progress on how much of the aluminum is actually gone from the cylinder. I want to show you right here. You can probably see there's a couple little shiny silver spots down there at the very bottom of the bore. What we're going to do now is we're going to use the microscope, and we're going to go down there and we're going to look around to make sure, see how big that area is. That way we can make sure when we put it in the home that there's no aluminum left in the bore. So far, made some progress. Let's see what the microscope tells us. So it looks like there were some rust pits on this block previously. Looks like the aluminum has found one of those rust pits and embedded itself in there. So maybe a little more elbow grease and we can clean that baby up, but it definitely found a little hole in there. Fortunately, it's towards the very bottom of the bore, but that's also where this problem looks like where it got started too. Maybe because of those rust pits. Man, check that out. That, you gotta love it when a plan comes together.
There.
Yeah.
You found him.
Yeah.
I don't know which one that is, but that's definitely what you were working on.
Mm-hmm.
And it's dark. It's not shiny.
Yep.
So that's a good sign.
Okay, so that was super cool. You know, I learned this trick from my dad because as a carter racing 2 cycles, piston scuffing was something happening at the racetrack all the time. So they would have to hand hone the track. And so somehow, many years ago, someone figured out you could use muriatic acid or lye or something to help clean up the aluminum so you could clean it back up and hone it at the racetrack and carry on and not scuff it again. Because if you leave any aluminum in there, guess what? It's gonna grab the piston again. That's not a good thing. So here we did, we got it. A little bit of Scotch-Brite, a little bit of liquid plumber, and now the aluminum's gone. So now we gotta put it in the hone and get it honed back right, and let's see how much it takes to clean it up. Okay, so thanks to the guys at Wagler, Embry, all the guys at CNC Blockworks, they let us borrow the hone, and we were able to get it cleaned up. 3 thousandths over, got it all cleaned up, and then Kenny at Tennessee Abrasives got us these really cool Scotch-Brite abrasives. So we could have honed it like we did before, but we didn't because we wanted to use the Scotch-Brites. And it is a beautiful trace. It knocks all those peaks down. It's super smooth and flat on top. Still got the valleys underneath. I think it's actually better than before, so I'm kind of actually glad we scuffed it and hurt it, because now we're gonna be able to go get the pistons, get the 3 new pistons coming, and then we're gonna be able to put the line-to-line coating. We're gonna put 5 thousandths clearance, skirt coating clearance on all the pistons. Then it will self-fit itself, so it might actually be better than it was before, because that line-to-line will let it fit in a little bit better. So we were able to go 3 thou over, save 5 pistons, line to line, put it together. Stay tuned, because when we go to the dyno, I have an expectation. I'm not gonna tell you what it is right now, but I have a number in my mind. We're gonna try to make it, so stay tuned. Are double-digit horsepower gains just from honing possible? You better believe it's possible. In fact, we can show you how to do it. All you gotta do is attend one of the Wagler Total Seal hands-on honing classes. We did 2 last year, and they were both sold out, phenomenal successes. And the key is we walk you through every step of the process, not just of how to hone, but why you need to hone differently than you did in the past. And we actually get into the details of piston ring metallurgy and the coatings on those piston rings and how that affects piston ring seal, because that's how the power gains are made. It's not just from the hone, it's not just from the ring, it's how the rings and the hone and the oil all interact together to create ring seal. Better ring seal equals more horsepower, and we're gonna show you how to do it if you attend one of these hands-on honing classes. Now, one of the key things we do is that we begin in the classroom. Like I just said, we go through and explain the coatings, the metallurgy, the why behind the new honing process. But we don't just stop with the educational piece in the classroom. We move beyond that. We get into showing you how to use the profilometer, how to use the software, the right tools to measure the finish you're creating. Because if you can't create the correct finish, you're not going to get the correct results. So what we want to do is not only tell you the why behind the method, we're going to give you the ability to measure to make sure that you're creating that. Then the final step, the thing that's the most valuable, is getting out there, getting your hands on the hone, and going through the different processes, using the correct roughing abrasives, getting within a few tenths of size, being able to use that software to see exactly how close to size you need to come for your application to get the hone right. That's right, there's not a single recipe. Each application is going to have its own unique characteristics. So this process will show you how to dial in the honing process in order to create the correct finish for each application. That way you get the maximum performance for your application. And we do that by being there at the hone, using different roughing abrasives, measuring it, going to different finishing abrasives, different speeds, different loads, using a brush, not using a brush. We go through all of that and we do it all in one day. So the great opportunity is to come in, whether you're experienced at honing or brand new to honing. Whether you honed 1,000 blocks or have never honed a single block, you can come here, spend one day, and you're gonna see the entire picture from the beginning to the end, the why behind the what of modern honing, and I guarantee you, you'll leave knowing more than you showed up, and you'll be able to make more horsepower because of it.
Performance Expo Lake. I love seeing you get your hands dirty. Getting in there.
But I had my gloves on so I didn't burn them, my caustic acids.
Yeah, you were working the muscles though. I mean, that matters.
And before we go too far, Mark Malburg from Digital Metrology joining us here in the studio. Mark, welcome back.
Hey, it's great to be here. This is fun.
And excited, and I want to let everybody know, if you're out there watching on YouTube Live, in the chat section, we can see you. Good morning to everybody out there. If you have questions throughout the day and you want to engage with us or our guest, feel free to put it up in the chat and share the show and invite your friends, as we're going to learn a lot today. And we just did, and we will in the future. Something that happened last year, these honing classes, yes. Lake. Amazing to see how many people who have been doing any one thing as their career or profession for a long time. There's always something new to learn, and I think that was the experience.
Well, Mark, you were just saying a second ago about your experience at PRI.
Right, so at PRI we did kind of a miniature version of this honing class that we've been doing together, and the comments blew me away. There are people that have been involved honing for 30, 40 years, and they said they learned more in 30 minutes with us than they've learned over the 40-year span. Now, I think there's a little exaggeration going on, but the point is that we don't take time to step back and learn. We're too busy doing. And I think you get that as well, right? The density of information that we can pack into a day.
Well, to me, it's the hands-on honing class connects all the dots. It takes you from the why to the what. So you can't be very focused on the process. That, I use this grit abrasive.
Right.
I go to this many strokes or this load or this sizing.
Yeah.
But why are you doing that?
Right, right. And we're coupling that with actually helping people see what's going on.
See, that little video we were showing before, right? And this is one of these. Keep me on rails here, guys, because I could go off the tracks on this one.
We've got you kind of surrounded, right, Joe?
Yeah, you do. You got me boxed in here. This little piece right here, this USB microscope, absolute game changer. Right? You just saw in the video how we were using that to inspect the scuff to make sure we got all the aluminum out of it.
Right.
Okay, that's just one example of what this thing can do. And you've been using this longer than I have, so you kind of brought it to us. So thank you, Mark, for doing that.
I'm there for you, buddy.
So I appreciate it. So talk a little bit about how this changes how we see what we've been doing.
Yeah, and I think that's been the case with honing across the board, is we've been honing until things feel right and we've got the right size, but we really haven't applied any craftsmanship to it. It's push a button, get a number of strokes, and move on. And now we're seeing inside, and we're able to control things better that we can see better. And whether it's crosshatch or material integrity or scuffs or whatever, having eyes in the bore, along with some of this knowledge we're connecting to engine performance, has been huge.
Well, okay, so hang on, because this is about to get deep. So, because Mark is a genius on this kind of stuff. You know, you can look at a bore, and you can look at it and say, oh, you know, it looks kind of dull, or it looks bright.
Yeah.
Now, a lot of that is based on the angle, right? Because the light that we see is the light that's reflected.
Yes, so your eye is terrible at measuring height.
That's awesome. It's not just bad depth perception, okay?
No, depth perception of a surface, your eye is like terrible. So look at the back of aluminum foil versus the front. It's shiny and dull. Guess what? It's the same roughness. The roughness of the back and the front is the same. But the little microscopic slopes are different. One side is kind of like sand and the other side is kind of like plow marks. And those plow marks are smooth to your eye. Well, getting that kind of knowledge of looking at a surface that's dull or shiny, your brain says rough or smooth. No, we've got to go inside. We've got to have the tools. We've got to have that honing class, the experience to start turning the knobs and seeing what changes and measuring it, not guessing.
Oh, so that's what it's all about. That's why that hands-on honing class, to me, is so valuable for anyone that's doing machine work or engine building, for that matter, right? Because you can have it honed. That's great. If you don't have to hone, somebody else is going to do it. But you can check that work. You can see what's going on. And it's not just about what it is coming out of the machine. That used engine, before you send it back to be machined, it has a story. It will talk to you if you have the tools that allow you to listen.
Absolutely, and we'll get that experience of what are those shapes, what matters. What I found just this last year has been super exciting in this world is people have never seen their surfaces before.
Right.
They push a button, the machine goes up and down, and they build an engine. And now they're saying, oh, the shape is different from this bore to this bore, this engine to this engine. Let's get better control.
Right. So,
well, I was going to say it's about having the right tools for the right job at the right time. And as much as we've seen technology advance just in the high performance aspect, it's also advancing in the tools to do the job. And I think that's what, when you discovered this, or Mark brought it forth, that opened up this whole new world. And obviously you're very excited about it. Let's talk about when these honing classes are happening. I know there's a lot of people out there that are interested. Seeing some people in the chat section already wanting to know about, you know, where to get the trick, Scotch-Brite, and different stuff. But the whole class, give us the schedule as best as you know it.
Okay, so there's going to be 4 hands-on honing classes coming up in 2024. That's 4 for 24.
Hey, works.
Yeah, so the first one will be March 16th at EFI University at Ben Strader's place. That's going to be, so he'll have that available on his site, EFI 101, in the next week or so. But that'd be March 16th, that's the first one. The second one will be back here in June here at Straub Technologies, like we did one last year here. And that's the same weekend as the Bristol NHRA race.
Thunder Valley Nationals. So just plan to come to the Thunder Valley Nationals and extend your trip a couple of days on the front side.
Yes, on the front side. So we'll do it on the Thursday ahead of the race. So the race is Friday, Saturday, Sunday. So if you're a sportsman racer, whatever you want to come in, get some experience. So Thursday before that one. And then the last 2 are going to be in the fall. We'll get those dates locked in later, but we'll have one at Rottler, and then the other one at UNOH in Lima, Ohio.
Nice.
Yes, we did one toward the end of this past year at UNOH. Fantastic facility. It's a good central location in the Midwest. It's at northwestern Ohio. And as an oil guy, it's a there's some history there too. I won't get into that now. I'll take
A lot of great
day.
racers come from, I've heard Lima, Ohio.
Lima, lima, potato. I don't know. I don't speak English.
I'm a Lima guy, so all right.
Bottom line, though, those classes are coming up this year. If you're interested, obviously there's more information. You can reach out for the TBD events, but I would plan to hit one this year.
Absolutely. This is going to be fantastic. Stay tuned. We'll have all the information on the Engine Performance Expo website as well as Total Seal. So, speaking of all that, the next video happens to be from Jeremy Wagler talking about some stuff that Mark has some familiarity with, because Mark used to work for Cummins.
Yes.
And this is a Cummins engine, and Jeremy's going to talk to us about some of the Valvetrain problems they've seen with some of the newer diesel engines.
Wasn't my fault.
All right, Engine Performance Expo viewers, we got a real treat for you. We're here, Wagler competition, Odin, Indiana, is that right?
Yep, out in the middle of nowhere, Indiana.
That's true. There's a lot of corn right here.
Yeah, out in the middle of the country though.
But there's also a lot of diesel tech here. Big horsepower, a lot of diesel tech, a lot of grassroots, get it done, figure it out, fix it. And that's what you've got right here is, hey, people go do things, problems crop up, but as any good farm boy does, you find a way to fix it.
Yep.
And I think you guys have this right here.
That's where it all starts. You start getting the phone calls of what's going on, either performance or stock application. And in this example, it's stock. But
yeah, this isn't looking too good because it's missing part of this.
Several lobes.
Yeah. This should be much longer than this.
That's the length it's supposed to be.
Yeah. So what happened here?
Long story short, the new Cummins engine 2019 plus, Cummins has always been a flat tappet. So
absolutely.
Flat tappet cams, flat tappet's been gone for hundreds of thousands of miles. For some reason, they changed it up a little bit in 2019. They put a roller cam in it. Whether it was for noise, emissions, we don't know the whole story, but wasn't very long after they released them, we started getting calls of a tappet noise. Pulled the valve cover, and the valve cover doesn't have, under the valve cover, there's no way to adjust the lash.
Okay, so that's different from in the past, right?
So factory forever on a 24 valve Cummins, you always had an adjuster, so you could adjust the lash. The lash was right on the valve cover, the specs were, and you could adjust the lash.
Because those were solid flat tappets, they were not hydraulic.
Nope. And
all right, that's good to know.
Like I said, they would last for hundreds of thousands of miles, even between adjusting the lash. So these started coming in, the 2019 pluses, and making types
a little bit of noise.
Rocker arm noises.
I can see why. That is ugly.
Yep. And basically, they went to a hydraulic lifter, so you can see show the camera.
You can see that wheel right there. The pitting on that wheel pretty much matches up pretty well with the pitting on that camshaft. Now, what's interesting here is I see a little locating. That looks pretty puny, to be honest, by the way.
Tiny, and it does not fit. So the block is machined with a radius, and this is like a straight flat.
Right.
So basically, you can take, when there's no oil pressure on it, you can rotate it. So
it's not a hard key. No, it's a radius.
It's a radius.
Oh, wow. Okay, so this is supposed to be like a semi-key, but they've got this radius, so there's actually slock in there.
And then basically what we're hearing through the driver's side fender well, you can listen. You customers' complaint is it's making a ticking noise with low miles. So going back to the dealers, a lot of the dealers.
Whoa.
Yeah, this guy.
Wait. You probably couldn't see this, so I'm going to show it to you here real quick. Not only is this lifter kind of like walking around, you can there's actually slop, because that axle actually is free floating.
It's floating and it's loose in the body as well.
Oh my gosh.
Yeah. So like I said, design, I feel like it's a design flaw. There might be other reasons for this, is it cost, is it whatever. But needless to say, the oil pressure, oil is a really thin oil.
Yep.
The 0W30s and there's several different dealers.
Not the traditional 1540.
Normally it was always a 1540.
Right.
But anyway.
But for emissions and fuel economy, they've gone to lower viscosity oils. And so the fuel economy and emissions is maybe one of the reasons why they went away from the flat tappet and went to the roller.
But it's causing us grief on the backside. So long story short, they lose prime at an idle.
Okay.
There's a lot of leakage around the body because we've been checking the blocks and they're not checking.
You can see there's a lot of wear on the body.
Yeah,
It's significant.
So some of them will go in and they're just sloppy, and that oil pressure gun drill right through the block is a half, like it's cutting right through half of it. So a lot of leakage. So then it's not keeping the tappets
filled up.
Yep. And then basically it starts dancing. So you can take this and just rotate it on the camshaft. So
and then it becomes a little hammer, and it just failure is imminent at that point.
And like I said, was it expense? Why wasn't it made with a radius? We don't know. But a few years ago, we made a kit that basically you take this section, you take a new lifter from Cummins, you pop the little hairpin clip out, you remove the, I call it the guts of the hydraulic system, you put this plunger in,
makes it solid.
We had Manton build us some nice push rods. Basically, we had to change the design because, as you can see, Cummins went from, they used to be a ball so the cup would retain oil.
The cup was in the push rod.
And then
now
they went
the cup's
to a
in the
ball,
rocker.
And the cup is upside down,
right.
And you can see the extreme wear on that piece as well.
Yeah, let's see this to the camera. You can probably get an idea of this. It is not pretty in that cup. What's going on?
So we went back to a traditional heavy-duty push rod.
Oh, that is a beautiful looking
cup.
piece.
Yep,
right
nice
there.
cup, nice bowl.
That ball that goes into the lifter, and this cup.
So that was our first. That's our first kit we designed. Basically, doing away with the hydraulic guts, going back to a conventional adjust your rocker lash to your desired, and we're done. Well, that's good for the street use and for most everyone. But then we're getting guys wanting to race them as well. So higher spring pressures, stage 2 cams, different cam designs. We decided we would go ahead and talk to Jessel and had Jessel build us a really nice one, pinned shaft, nice roller.
That looks like a NASCAR lifter.
Yeah, it took us a little bit to get the design of the radius on but look at the difference.
Oh yeah, we're going to show this to the camera right now. So there's the ball, right, for that versus that. That is night and day difference. No wonder this holds it so much truer.
It does.
In Strader.
Yep, and we're not relying on oil pressure to the hydraulic section, so engine life will be better as well.
Yep.
We went ahead and had them drill through and oil the roller.
Yep.
It still has oil to the center. It's going up and catching the push rods and everything.
And it's edge radius too. I mean, that's just everything about this lifter is showing me this is a Jessel piece.
Well, yes,
right. This looks like a quality Jessel piece.
They are more expensive than the OE. Which,
you get what you pay for.
Yeah, this thing is I'm sure. Yeah. I'm sure it's pennies on the dollar on machine time on this guy. But you have two options. We're creating this to go with the Mopar lifter, and then if you don't want to go that route, we have this guy that goes and does away with everything, run a new camshaft. We have two different levels.
So then you can take this, right, take that camshaft, couple it with this lifter, you've got the push rod, you've got the rocker conversion kit, so you can actually make a real race valve train.
Yep. And then you can put your spring pressure up to where you want it, because it's a good quality roller, good camshaft, and that way you're not floating valves on your race truck. So it's working. Yep, it's working. Unlike the old factory. And you ask why it's short for, basically, whenever we see them eating the lobes, this one's not even the worst. We've seen them where it dug all the way across. That material goes right in the rod bearings, seizes up the rod bearings. This one chucked the rod right out the side, so you got a half of a camshaft, a junk block, a junk crank, a junk everything. But we're seeing this low mileage under 100,000. So anywhere from 40,000 to 100,000 is where we're starting to hear guys come in with complaints, and we're selling these kits to.
That's collateral damage that's way more expensive than just getting the parts to prevent potential collateral damage.
Yep. We are doing one more step. It won't be for everyone, but we're producing a flat tappet and going back to a flat tappet camshaft.
Got it.
Will you need that? Not really. Some guys like the flat tappet because it's lived forever. It's been in their farm truck forever, so that's why we're doing that. It's a new, bigger stem taking the place of this guy. So those are getting finished up as we speak. So they'll be out, but for the other kits, we have everything in stock.
That's awesome. So find the problem, create the solution.
2019 plus Cummins in your pickups.
There you go.
Pickup trucks. Yep.
That's what we're here for. Engine Performance Expo. Stay tuned.
A big part of the Engine Performance Expo are some live editions of the hit podcast, Hidden Horsepower, presented by Total Seal Piston Rings. And we have got a great guest right now, Brian Tooley of Brian Tooley Racing. An amazing career in, let's call it, airflow and getting the power to those cylinders. Welcome to the show. How are you?
Thank you. Great to be here.
So before we got started, just some rapid fire history of Brian's career and instant inspiration, Lake.
Absolutely. So you have a very interesting path where it's kind of wound back and forth. So you started off doing cylinder head and airflow stuff.
40 cylinder heads, yep. Bought a flow bench in '93 when I lost my job as a maintenance mechanic. I was 29 years old and had never been in another cylinder head porting shop. Didn't know anyone who ported heads, but I'd been doing it, as a hobbyist, for years. And so bought a flow bench and started that business. It was actually hired into Holley product development for a few years in the 90s.
Okay.
And helped develop some different stuff there. I'm the reason Holley made cylinder heads in the 90s, by the way.
Really?
Yeah. And then, went back into self-employment. Total Engine Airflow was the business name.
Can we pause right there, just because at the end of our Hidden Horsepower episodes, we always ask for advice for the next generation, and hopefully young people who are aspiring will watch this and be inspired to do what they want to do. You were a mechanic. You lost your job.
Maintenance mechanic.
Maintenance
in a factory.
mechanic. Okay, so explain what the daily grind of that was. You weren't as happy as you are now. What were you doing?
Well, my background was actually electronics. I worked in Missile Control Center on a ballistic missile submarine. So computers and electronics was my passion. But then when I got out, I got the opportunity to become a multi-craft maintenance mechanic at a factory, because they were like, hey, we'll teach you how to, TIG weld and stick weld and MIG weld and run mills and lace. And I was like, this sounds cool, so I took that job and learned all those skills, and then all of which helped later on in life, so. But if I had to give anyone advice, I think for what to do, work ethic, work hard and bring the work ethic. If you don't have super strong work ethic, don't even try to be self-employed.
Exactly. Yeah, don't step across that line.
Yeah, just go work for somebody else.
Well, taking a chance, like you bet on yourself. You invested in a piece of equipment.
Yeah. Bought the flow bench and met Rick Smith in 1996. That's the founder of Trick Flow.
Okay.
So Rick started Trick Flow in the 80s. Sold it to Summit Racing in '93, and he tried to hire me in '96, and they didn't hire me because I didn't have CNC experience. And then Rick left around 1999, and then the manager of Trick Flow always kept tabs on me, and we 2001 we bought a 5-axis simultaneous CNC machine, Bob Hudgens set up, and that went real well. I was porting heads for Tony Bischoff, who I know was on this show, and back then, and Proline Racing and all kinds of people, Texas Speed, and Summit Racing certainly got their attention, Trick Flow, and they were behind the game. So in 2004, when I sold Total Engine Airflow to Summit Trick Flow, they were the only domestic cylinder head manufacturer in the U.S. who did not CNC port their own cylinder heads. The only one.
Wow.
They were last to market for CNC cylinder head porting.
So they didn't hire you because you didn't have CNC experience. Then you ended up, they bought you because of your CNC experience.
Yes, expertise.
Well, that's a valuable lesson right there. The ability to evolve, change, acquire new knowledge, learn new things.
Well, that's the second part of this, right? You got to have work ethic, and you have to continue to learn. You always keep learning.
Yeah. And a little bit of grace of God thrown in there. Goes
a whole lot of that.
Catching a break here and there never hurts.
Meeting Bob Hudgens, that's an interesting story that I'll probably save for after this segment. But meeting him in Florida at his facility, and him showing me Complete Port. That was in 2000. He just developed Complete Port. And he said, hey, this takes CNC porting from about, from digitized data to toolpath, it takes it from about 40 hours down to about 8.
Wow.
Which was in 2000, 2001, that was revolutionary, right? And of course, the really cool thing was, you didn't have to know a whole lot about, CAD CAM, et cetera, because the program was simple enough that you could go from digitized data, create a surface, create a tool path, and port ahead. So I bought a 5-axis CNC and had never turned a CNC on. And within weeks we were porting heads.
Because of that.
And so, but back then that was a big deal because, in 2000, 2001, no one could sell you a turnkey porting
Time out,
package.
because I think this is a big deal, because I think I've heard it from several people that making that jump to CNC seems like it's like a foreign language. It's a river too wide to cross.
Yeah.
Because, oh my God, I don't know. Things like tool paths. Yeah, I can have a ferro arm. I can get digital data that this is what it is. But how do I turn that into a tool path? I'm not fluent in CAD CAM. I'm not a master CAM guru.
Right.
How do I make this thing work so that I get what I want? When you're saying that there's things that bridge that gap.
Yeah, Complete Port, who eventually sold to Mastercam.
Okay.
So if you use Mastercam today, you're using Complete Port technology from 20-some years ago, which is interesting to me,
So it's not as maybe daunting as people might think it is, making that change.
Right, yeah. The thing about all of us men is we all put our pants on one leg at a time, and if another man can figure it out, then you can probably figure it out too, right?
Ooh, there's the line from this one already. Every year there's a line, right? I'm wearing the t-shirt under this that was, WJ's from the first year, which is, you can't tune it up if you blew it up.
I like that.
Yeah, it was a good one.
Don't blow it up.
Yeah.
Yeah.
What about these days? Obviously, you've the technology that we're working with has evolved. The engines have evolved, and you have kept on the cutting edge with much of what's out there.
Well, I'm all about bang for the buck when it comes to horsepower, right? And in the early 2000s, when I could port a pair of LS heads and pick up 50 horsepower, that was good bang for the buck. Well, by the time I sold TEA to Summit Racing 2004, 2005, LS3 heads came out, LS7 heads came out. So the factory stuff just got better and better. And I felt like that was coming when I saw my first LS head in 1997, because I was just like, whoa, this thing's serious, right? And so, selling the business made sense to me, because I was just like, the gain from porting heads is just getting smaller and smaller. Well, I think the thing that happened at that same time was the gains from camshafts got bigger and bigger, because the heads got better and better,
Right.
And so, somebody was just asking me about our new Godzilla cam that we're launching. Slide the stock cam out, slide this cam in, don't even change valve springs. It's 120 horsepower.
Unreal.
It's unbelievable, and it's all, but look at the cylinder head. The cylinder head looks like a Gen 5 Chevy head, canted valve. It looks like a NASCAR head from just 10 years ago.
Well, I think back to Project Pontiac, that's a perfect example. You were mentioning back in the day when you were racing with your dad and you're running, all you had was the factory head.
That's it.
And so that was your limitation. So of course, the guys back in the day, the Keith Wilsons and all those kind of guys, they became famous. Why? Because they had to work on the heads. And everyone was messing with heads and porting and grinding and the trick of the head, type deal. But then CNC came along and just basically blew that out of the water.
Made it much easier, for sure. Yeah, because you could do a really killer port one time and duplicate it thousands of times. And
the factory heads started catching up to that.
The factory heads started catching up, absolutely.
Like I said, it's that NASCAR background that GM learned from being in NASCAR.
Absolutely.
And the LS heads look a whole lot like RO7 type head.
Yeah, yep, exactly. And so, so quit Summit Racing Trick Flow in 2010. My wife was, homesick, wanted to move closer to home.
Okay.
So moved back to Kentucky, and I had a 2-year non-compete, and I got my real estate license and did some day trading and stupid stuff, and I was still building engines and porting heads, and Trick Flow actually changed spring vendors, and I saw an opportunity to sell the springs that we had developed 5-6 years earlier. We sold a spring for 5 years without a single failure, and when they changed spring vendors, they lost 50,000 to cold bind height. So I was just like, okay, this is not going to end well, right? So I called that spring vendor and got set up and started selling valve springs out of my basement, and it's really funny because people were like, well, what was your goal when you started this business? I'm like, my goal was to not have to go get a real job. That was my goal. I was trying to make $50,000 a year net profit out of my basement. And so, but that we quickly exceeded that. And so it's interesting. I just moved out of the basement 10 years ago this month.
Really?
10 years ago this month.
I've been to your place. It's nice.
Well, it's much bigger now. It's 3 times the size.
3 times the size.
It's because it was 15,000 square feet when you were there. It's 45,000 now.
Wow.
Yeah. Yeah.
So that's Springs. You got going
Who
on.
are your customers? Who's your target client? Who's coming to you for your high performance knowledge and parts?
So, really anyone with the 97 newer Corvette, 98 newer Camaro, 99 newer truck, CTSV, anything with a LSLT, which is lots of vehicles, right? Street strip guys that daily drive their trucks. I daily drive a Ram T-Rex, for example, and you don't know what that is. That's a truck with a Hellcat engine in it, right? I mean, it's just a phenomenal truck. I can't believe they even make it, So as some of this production factory stuff's gotten more powerful, guys want to step up their older vehicles for power. And so they're putting superchargers and cam kits and ported heads and all that stuff. So really, it's anyone from the guy that's just daily driving his truck all the way up to some of these class racers. We don't really focus a lot on class racing. We leave that to Tony Bischoff and those guys, right? Yeah. So we like just supplying parts to the masses. The guys that obviously we've done Chevy LSLT for a long time. We just launched our Hemi cams a few months ago. Launched in the Godzilla cam now. So all of this late model pushrod performance is what we're all about.
That's awesome.
Yeah.
And that's the backbone of the industry. Let's face it, like you mentioned class racing within the NHRA, something that I love, but very specialized just to be able to be there and very expensive. This, call it a culture, a hobby, whatever we want to call it, the backbone is the person that wants to put a cam in their car to feel a little more power. As simple as that, and you make it easy.
Yeah. You have to have well-engineered products that work together. A guy can just go home. He doesn't even have to have a height mic to set the spring kit up. He can just bolt the parts in, and it just works and runs and lasts.
Because you've done all the work for him on that side. Yeah.
Exactly.
You've done the Spintron work and this and that, so it's a system, not different parts.
Yes, yeah, exactly. We brought cam development in-house in 2018 with the Spintron, and fortunately through people like Billy Godbold, who got to spend some time with him, and we bought the same software that Comp used, and so that started our path to lobe development, and then brought cam grinding in-house last year. And so it's been a really interesting path. We've become in a position I thought I would never ever in my life be in. It's really hard to believe, but we're manufacturing all of our cast aluminum products in-house, all of our intake manifolds, all of our valve covers. We're coming to market with our own cylinder head, of course, because mine,
background,
it's natural thing. And
you're doing engines now too, right?
Building engines. Yeah, we have 2 Swiss turn machines, spitting out retainers, and we do powder coating in-house, and the cam polishing, the isotropic polishing. Yeah.
Nice.
Yeah, and and it's funny because I was talking to Billy right before I came in here, and I'm really riding on the coattails of all the pioneers, right? Because Billy pioneered the isotropic rim finishing for the camshafts that they call MSE. So when that vendor contacted us, said, "Would you like to buy this equipment?" I said, "Yes, I would."
Yes.
Yeah, that's, sure. Yeah, it sounds great. So that can't be understated. If you're in the position to watch mistakes happen, because sometimes you see vendors make mistakes, what you feel like are mistakes. And if you can observe those mistakes and say, I think I would do this differently this way, which is ironically what Billy and I was just talking about. And so we do things differently with the way we do cam cores and the heat treat and all that sort of stuff. But it's really interesting to be able to get the best cam cores, the best heat treat, the best cam grinding, the best cam finishing, develop the best cam lobes. It's really quite unbelievable. If somebody would have told me 5 years ago you would have the best of all of this stuff, I'd be like, there's no way. You can't get from here to there in 5 years. It's impossible. But here we are.
But you did it.
Well, I want to talk about LT stuff for a minute because I think that's a super interesting platform, right?
Love LT.
Nothing against the LS crowd or the Hemis or anything else,
Right.
but let's talk about LT direct injection engines. 'Cause I'm going to think back here. This has probably been 6 years or so ago. Me and Ben Strader bought one of them
Okay.
to do some work. We were working with Oak Ridge. By the way, if you don't know, we're in Piney Flats, Tennessee. That's East Tennessee. So we're about an hour and a half-ish from Oak Ridge, which is where they did the uranium development part of the Manhattan Project. So anyone who watched Oppenheimer this past summer, well, guess what? Oak Ridge is part of the Manhattan Project. It's still one of the largest government research labs. There's over 1,000 PhD scientists at Oak Ridge National Lab. So we were doing some work with them when I was still at Driven.
I remember.
With direct injection, because that's also have the National Transportation Research Lab is at Oak Ridge. And so they were looking at abnormal combustion with direct injection. So we bought one of these engines, and wow, for an out-of-the-box factory engine,
Yeah.
I mean, bang for your buck. Talk to me about it.
I mean, so GPI, we sell spring kits to GPI, Guatney Performance Innovations, and they called me one day and said, we just made 740, 750 horsepower with our stock short block LT1. And at that time, I was just like, that's like 2 horsepower per cubic inch, hydraulic roller, pump gas, stock rockers. I'm like, man, that sounds like a lot, right? And so, I bought a 2019 Camaro, and we pulled the engine out, we put it on the engine dyno, and we actually bought a set of their CID heads, and we were doing our camshaft development. Of course, we bought everyone else's camshafts, and and we get to working on this thing, and we ended up at 740 horsepower, naturally aspirated pump E85, 230 intake duration camshaft. It's just unbelievable. And we had our Trinity intake on it, which is a port injected intake, but we had the injectors in it, but they weren't operational, right? Because we're running on the DI.
Okay.
And so we took the intake off, we took the direct injectors out, we plugged the holes, we put our intake back on and turned on the port injectors, and that engine lost 60 horsepower.
Whoa. It lost 60 going to port.
Yes, sir.
Whoa.
And so as soon as I saw that, because I'm a big latent heat of evaporation guy, right? And I'm like, it didn't do what I expected.
Right.
And so I said, okay, that has to be an airflow thing. What was the difference in airflow? And the difference in airflow was 8%.
Because
it lost
fuel.
8% putting the fuel in the port, clogging the port up. And then we did the same thing on M1. The engine made 785 horsepower on M1. When we switched to port, it made 700.
Yeah.
85 horsepower difference.
Yeah.
Between port
Bigger
and
difference with
DI.
methanol because you put more fuel through it.
Right.
All right, so that goes back. So last year at the Engine Performance Expo, we had a video with Ron Shaver and talking about the evolution of mechanical fuel injection. So we're going way back, right? The old school, constant flow injection. Dan Gurney is like literally the most underrated guy ever. Gurney was the guy that came up with the idea of aiming the injector at the back of the valve, as opposed to having the big one just trying to atomize the fuel, clogging up the port.
Clogging up the port,
He's like, just spray it at a stream at the back of the valve, and let the valve scatter it out and atomize it. And it was all about that volume. You got all this air you're trying to push through the port. If you have a bunch of fuel in the way, every fuel molecule is displacing an
air molecule.
And engines have to have both, and the limit is the air.
And the airflow difference on the M1 was 12%.
12%.
12%. Yeah, that's how much more the M1 clogged up the port. So very, very interesting. And people say, oh, that's all BS. There's some tuners out there that are just like, well, you're tuning this bunk. And at one point we ran the engine on like 25% DI, 75% port, 50-50, then 75-25 the other way. And the math exactly carried through the whole time. Every time you went to more DI, you had more airflow, you made more power. And so I think it's the best pushrod engine ever made. I'm a horsepower per cubic inch guy. I'm an efficiency guy. And in terms of that, I remember 20 years ago when we were working pretty hard to make 2 horsepower per cubic inch out of race engines, and to have a stock short block fly cut just the intake side of the piston, right? That's a stock short block. Fly cut the intake side of the piston, didn't even take the pistons out of the block. Aftermarket heads, a streetable cam intake and that kind of power, just unbelievable. Never thought I'd see the day, ever.
That's awesome.
Very cool time to be a gearhead, for sure.
So how challenging is it to try to run it and set it up to run on both DI and port? Obviously, you just need to run it on DI, but what's that like, trying to use the computer system and all that?
Well, I've got really smart guys that work for me. So James Short is our calibration engineer. Actually, because of the Gen 5 engine is the reason we hired James Short.
Okay.
Because it was kicking our butt. We weren't
trying to,
we weren't tuners, and I mean, when it was just air fuel ratio spark, we could muddle our way through it. We were trying to run a factory computer, so now you have to program the torque tables.
Right.
And so the sophistication of the tuning is far more with the direct injected engine, unfortunately. And so we actually hired him, and so he's a whiz at electronics, computers, tuning, all that stuff, and he's just like, oh yeah, just do this, and made it look easy. So that was easy. And we sell a kit, to add on port injection to direct injected engine.
Okay.
Yeah, and as others do too.
Yeah. Sure.
So it's not too bad.
So then people are also going beyond just the NA version. They're putting superchargers on them.
Absolutely. Yeah.
How much change do you have to make for that?
Well, it's not a lot. I mean, obviously you have to have the fuel, so a lot of different ways to get more fuel to it.
Is that typically adding the port on top of it? Because I know that's one of the limitations with DI is you typically run out of injector.
Absolutely. Yeah, and by 785 horsepower, we were on M1, we were completely out of fuel.
Yeah.
We had LT4 pump, LT4 injectors, 100 PSI on the low side, and I think our fuel pressure was 3,500 psi at the rail,
right? And
still wasn't enough. So so you run out of fuel pretty quickly with boosted applications, and you definitely need the port, the port injection on top of that to make the power. Yeah, but guys will tell you, guys that have tuned these LS3, LS7 boosted applications forever, they'll do the same basic blower boost level on a DI engine, and it's 100 horsepower more to the tires.
Oh, wow. Okay.
And they'll tell you that. Yeah. So I'd bought in 2018. I'd bought a 2019 ZR1, which was direct injected and port injected.
Yes.
From the factory.
Right.
So that was kind of a cool engine. We eventually made 1,100 of the tires with it.
Okay, I was about to say. So where are the numbers that people are getting out of these DI engines now?
Yeah. I mean, there's no telling on the high side. I couldn't even tell you where the high side is at this point. And a lot of the guys that are setting records with those engines right now, unfortunately, are 100% port because they're running aftermarket ECUs, and the ECU doesn't support the direct injection, which is a shame because you're leaving power on the table. For sure. But yeah, what a wonderful engine.
It's pretty neat.
So on that note, I like to think we need to seed the fields of the future. And when the LS came out, there was that whole wave of everybody going to the junkyards and just junkyard LS, right? Get a turbocharger, throw it on, you're making 800 horsepower for a while.
Yep.
If you were going to recommend a platform for this next wave of people that are going to do something with an engine and have a little fun, maybe they haven't done anything. They don't have anything. What's the platform that they should go hunt for?
In my opinion, the 2014 and present 5.3 L83 that's in all the trucks.
Okay.
Because you look at all the 5.3s that's in every vehicle imaginable now, every one of those came out of a 99 to 13 truck, right? The 2014 to present trucks with the 5.3s, that is such a disregarded engine because people are scared of direct injection, but it takes the same low side fuel system to power a direct injected engine as it does a port injected engine. It's exactly the same fuel system, right? Because all the high pressure fuel system is in the engine. You don't have to worry about it, right? And so like a Gen 4 5.3 with aftermarket trick flow heads, big 233 intake duration camshaft on our dyno, that engine was 500 horsepower or something, right? Very low. And our L83 with just a 220 intake duration cam, factory ported heads, that engine made 569 horsepower.
Okay.
Now to put that in perspective, an LS3 with a stage 4 cam, that same 233 duration cam, it makes 570 on our dyno, right? So you're making LS3 6.2 liter power out of this direct injected 5.3, and it makes very good torque because of the DI and the fact you're using such a small cam, and we're using BVT.
Oh yeah.
So we have 8 degrees total advance in this cam, and then retard it, as the RPMs come up. So you're getting a low end torque with all that advance. You get top end horsepower. It's just a great package, and it is the most slept on, great little engine out there.
I think we have something to play with this year.
Well, exactly.
That's an Engine Performance Expo project I've ever heard one.
Yeah.
Well, and that's what it needs to be. It needs to be, I don't want to say simple or basic, but attainable and obvious. Not everybody can just open up the Summit catalog and order everything, or go directly to you and get a high performance engine. They've got to start off with something, and there's fun factor too. The idea that you pulled something out of a truck in a junkyard and put it into your vehicle, and now it's your creation, that I think is the core of this whole hobby. And so that's the next wave, perhaps.
Yeah, and what we want to do is we want to offer a computer harness package, camshaft package. You just buy the camshaft package, the computer wiring harness, bolt it on an engine, bolt it in a car. It's tuned, it works, it runs, it makes power. That's what we want to do. One of the next steps.
Yeah, I think simplicity is also a big factor in the modern era.
Awesome, yeah.
They want to do it, and they want it to work.
Right, because when you get down to it, the level of tuning is so complex compared to what it used to be. It's very complex.
Like I said, way more than just fuel, air, spark.
Absolutely. Yeah. And so when you simplify that by having it pre-tuned for the customer, that greatly makes things easier for them, because customers don't always know everything they need to know, right? We've had customers in Nebraska buy a cam kit and then call us up and say, "You mean to tell me I have to tune this thing?" And it's just like, yeah, you just assume that they know that, and then and they're like, "Well, the closest tuning shop is 4 hours from me." That's an all-day trip just to go get this thing tuned, and you're just. So anyway, we hope to do a package like that.
Okay.
So talk about Godzilla for a minute. Before we get run out of time, right?
Yeah.
Godzilla. Ford guys out there need some love too, right?
Oh, yeah. I love the Godzilla, love the big bore, big displacement. And I got to tell you a story. 2 years ago, we're at PRI, and the whole weekend, people had come to us Friday, Saturday, Sunday, or Thursday, Friday, Saturday. Are you making Godzilla parts? You making Godzilla intake? You making? No, we're not making. We don't have time. We're not making. The last hour of the last day on Saturday, Brian Wolf comes to the booth, and I know who he was, and he said, "Will you make me a Godzilla intake?" And I said, "Yes, sir. Yes, sir, we will."
The right person.
So then that kind of opened the door to doing the camshaft stuff. He saw what we had going on, and so so we did some camshaft stuff for him, and it was better than what he was getting from another place. And now that camshaft, 222 intake duration, over 100 horsepower, and you don't even have to change the stock springs.
That's huge right there.
It's unbelievable, right? Unbelievable.
You slide one out, slide the other one in, and off you go.
Yeah, yep. And that L8T, direct injected engine, is really not far behind. We're doing a build-up series with Power Auto Media right now, and going just from the stock cam in it to our stage 2 cam that's only 210 intake duration. We're already at 50 horsepower gain. And that's a low lift cam. It's under 550 lift. So very something you could drive for a long time and not have problems with.
Right. Yeah, that's key.
Yeah, because the stock cams are that much lift. The LT1, L86, all those. What a time to be alive. But yeah, the Ford guys. So we had the Godzilla intake. Now we're coming out with a Ford intake, longer runner.
Okay.
For the truck guys, that's going to be a bolt-on truck intake. Really excited about that. Because it's going to have the torque that the truck guys need.
Right.
All right, before we run out of time, we got our advice for the next generation out of the way at the beginning, which I think is great. You got to have a work ethic, but we're trying to inspire the next generation to get in and involved. And there's a lot of folks with machine shops and high performance shops that are, I don't want to say aging out, but they're wondering where is the group coming behind. So talk directly to those people a little bit, and why is this industry something that, number one, I believe you said, kept you from having a real job, right? A real job, working for the man or whatever. But speak to those folks for a moment.
Well, I guess that's a big question. there's so many smart guys out there. I've got a very smart engineer that I hired from Holly last year, electronics guy, but also is doing we just bought the same software that the OEs use for computer engine modeling, so we had that software. He's running that. And, he is just tickled to death because he wanted to do that his entire life, do engine modeling on software. And so, the technology out there is just unbelievable. And so I would encourage them to definitely embrace technology and work hard at the technology, software, all of that, because that is absolutely the future. Us car guys tend to be very mechanical guys. We're swapping hard parts. We now spintron test and dyno test our camshafts in the software, right? And then when that's done, we grind the hard parts and put them in the spintron and dyno and make sure it tells us what the software did. Right. It's a verification process, and adopting that technology and having young people who can, do all the work that it takes to input all the variables into that software. That's a daunting task. I mean, it's literally, 2 months worth of work just to get all those variables and inputs.
Where can people find out more? Brian, Tooley Racing, check out all these parts and pieces and information that we just talked about.
Yes, sir. Yep. Yeah, BrianTooleyRacing.com, and
awesome.
We're on the website, and they can call in. We have 8 sales guys that answer phones all day, and they're great.
And they're not in a basement.
Not in the basement anymore. Not in the basement anymore.
Yeah.
So talking about Godzilla.
Yeah.
This next video is actually Ben Strader and myself talking about some manifolds for the Godzilla engine. Runner length.
Kind of an interesting subject, right?
Yeah, it's one of those things to talk about, and okay, everybody knows what the rules are. The longer the intake runner length, the more torque it makes. The shorter it is, the more power it makes at higher RPM. And
let's talk a little bit about why that happens, because tuning the intake runner lengths is a really important part of the engine development work. Everything in the engine kind of needs to be set up as a system. So if you have an intake manifold that was really designed for a low RPM truck engine, and you pair that with a camshaft and a header that was made for a high RPM racing engine, you're gonna kind of get a turd, So to make the engine work really well, we want to develop it in such a way that all those parts are complementary to each other, right? So we always talk about the engine being a series of dependent events. The manifold length depends on the rest of the engine being also suited for the RPM range that you want to use. But what's really going on is there's a resonant wave. There's literally a powerful pulse of air traveling back and forth the intake runner, and we're trying to harness that positive pressure while the intake valve is open. So what we're really doing is we're playing a game cycle to cycle. So imagine this column of air that's coming into our engine, and the intake valve closes, and so now that column of air kind of crashes into it and bounces back the other way. So when it gets all the way back to the plenum, or in our case with individual throttle bodies, when it gets back to the world, that's our plenum, right? That pulse changes directions. It turns around and goes back the other way. Now that pulse is traveling at roughly the speed of sound. So that means that because we know that, we can sort of mathematically predict how long it will take it to go from there and come back. So if it gets all the way back and the valve is still closed, it doesn't really help us a whole lot. And so what we want is to not only get it back in the right time, but at the right point in the valve motion in our cycle.
So you get a little supercharging action.
That's right. And so we typically target somewhere near bottom dead center where the valve is pretty far open, but we're no longer reliant on the piston to help us bring air in.
There you go.
So we want that high pressure column of air kind of cramming it in there. So as you can imagine, when the engine's stock, they use a factory intake manifold like this, and the length of the runner is really long, because since the engine RPM is low, the physical amount of time from when the valve closes to when it goes around and opens again is pretty long. But our pulse there is moving it pretty fast, like the speed of sound, so we got to stretch it out. We got to have a really long runner so it goes all the way over there and it gets back at the right time. So as we make that runner shorter, for example, and I'm just using rough numbers, for example, the stock manifold here, this is a 2020 to 2022 Ford Godzilla 7.3
huge, look at that.
Yep, she's big. They call her Godzilla. The length of the runner from the deck surface of the head there, so we're not including the port here, is roughly 18 inches on the stock one. Now, they make a ton of torque down low, and they peak torque pretty early, down there around 35 to 3,800 RPM, right? So now when we move to an intake manifold that has lower or shorter runner lengths, what happens is the amount of time that it takes for that column of air to go out and come back gets shorter.
Yep.
So what happens is now, typically that hurts the torque down there at low RPM.
Yep.
Because my pulse came back and the valve wasn't open, or it was open at the wrong amount, right? Yep. So in order to make those short ones work, we really need more engine speed, because it's going to go there and it's going to get back, and so that we need that valve open again, so we got to wind that engine up pretty high. Now, that's exactly what we saw when we tested these new individual throttle bodies.
Right.
These are beautiful. These things are brought into the States by Brian Wolf at Willis Racing up in Michigan. He gets them from a guy named Roger Higgins at Innovate Machine or Innovate Racing Products out of Australia, and they're absolutely brilliant. The machine work is perfect. They are just, everything works so beautifully. And he provided us with trumpets of various lengths. So we have the longest ones on there now, we got a medium length one here, and then we got a really short one here.
Yep.
So the difference is from the factory intake, the longest ones give us about 9.5 inches relative that same plane, right? The shortest ones there are only about 6.5 inches.
Right.
And so exactly what we expected. We ran
6, 9, 18.
That's right. So and then in the middle, what we have is kind of like 7.5, 6.5 to 8. Yep. So we know what the exactly. We know what the ultra long ones do. We know what the shortest ones do, and it's exactly what we thought. The shortest ones, they hurt the torque down low by a pretty significant amount, but it really paid off up high. So if I was going to build this engine and say have more lift and duration of the camshaft, maybe ported cylinder heads, and I was shorter headers, and I want to turn this thing say 7,500 or higher RPM, I would really want that short runner, because it's going to pay off big time at high RPM. On a completely stock engine like this, that's probably not my first choice.
Right.
So instead what we're going to do is use the longest one, and we're going to see how that compares to the factory manifold. I got a feeling it's going to be pretty good.
Just fire it up and find out.
Almost as good as the factory down low, and then basically as good as the short ones up high.
You can't ask for better than that.
I know, that's pretty cool. Next time I want to see if I got any blow by. Yeah, look at that. It's pretty much equal at 6,000 with the yellow ones climbing, right? So it's gonna be better.
Right.
But I'm stopping there because it's a fair comparison to the factory. But it's almost as good as the factory manifold there. 71 to 56, so it's like 15 foot-pounds is all it gives up. I'll take that to get all that and have that cool factor.
Yeah, but the peak is almost the same.
No. See, the peak is here at 4,000 versus up here at 4,500, basically.
Yeah, but the total peak, the total number, is almost the same.
Absolutely.
I mean,
so it's 577 versus 5. They are exactly the same.
Yeah.
So it makes the same, just higher. I'm gonna do it again because it's cool.
Oh, hell yeah.
And I bet you it gets better. Let's see, we're 140. See if we get any blow by. Yeah.
What's the 2.7?
Cubic feet per minute of blow by, of just ring blow by.
Yeah.
So it's 1 horsepower different there from the last one.
Oh, that sucks.
Junk.
Godzilla. I love it. You know, as a kid, I actually really loved Godzilla movies.
Did you watch some?
Oh hell yes. I love some. Smog Monster, Mechagodzilla, all that. So that one kind of reminds me of Mechagodzilla with, that thing on top.
It's big and angry.
Yeah.
And I think what's cool about this engine is that it's really large in a small package. Like, it's basically a small block. That thing's only, I think, about 1 inch or 1.5 inches bigger than, say, like a Windsor.
Right.
But yet it's a really large displacement engine at 445 inches. So I think Godzilla was a cool name for it. I know some of the Nissan guys weren't real happy about Ford choosing that name for their engine project, but it sort of, it works, right? Because it is a large displacement engine, and it's very docile out of the box because it really was a heavy-duty truck engine, right? So it's cool. It'll sit there and idle at 750, 800 RPM. It takes really good throttle. So we're actually using the variable cam timing and everything. So it's fully stock engine. We got the Holley ECU running all that stuff. And so it was cool to have 100% stock configuration. Then we put like the really short runners on there, and then we came back and we put the really long runners on there. And frankly, no surprises, right? Like it did. Well, I guess there was a couple of surprises, and one was that the ITBs performed as good as they did. Yeah, I really thought that the factory manifold was going to stomp them at super low RPM, and frankly, it didn't.
No, it really didn't. I mean, it's like, okay, for what, about 1,000 RPM, it's a little better.
Yeah, now the short ones obviously hurt it pretty bad down low, but that's sort of, they would also trounce it at 7,500 RPM, so that really wasn't surprising. The long ones, though, I didn't really expect them to be as good as they are.
Right.
They're a little better from like 2,500 RPM to about 3,000 or 3,200. They're within the measurability range there. They're a little better. But after that, they only give up maybe 10 or 12 or 15 foot-pounds in a range of about 1,000 RPM. But after that, dude, they just sort of take off and run away from the factory manifold. And keep in mind, that's a stock camshaft, still using the variable cam timing, stock, Right. So you put some compression in this thing, you put a camshaft in this thing, it would be, Godzilla would be angry and like overwhelmingly awesome.
One, it looks super cool, by the way. I mean, it's so much cooler looking than the factory.
Like the black truck manifold.
Right. It's the same peak torque number, it just does it later. It's like almost, 37 horsepower better at 6,000 RPM.
And it would continue to get better if I let the RPMs go up.
Right.
I just wanted it to be a fair test. The stock engine's pretty much done by 6,000. So we're like, hey, let's just see what it does to 6,000. But you're right. It actually made the same torque as the stock manifold did. It just bumped it up about 500 or 600 RPM. Again, that's what we would expect from a shorter runner. What I didn't expect is for it to do so well below that. I knew it was going to be not as good as the factory one, but it's so close that I would gladly trade the performance from, whatever that is, 3,800 is the peak torque for the stock manifold.
Yeah.
It moved up about 500 or 600 RPM, and then it just trounces the factory one after that. It's super cool.
This is like a total no-brainer, right?
I know.
It looks cool, it runs good, and basically you bolt it on. I mean, you don't even have to go inside the engine. It's nuts.
Well, and I'll tell you what is the most surprising thing about these. So remember, I talked about the manifolds come from Innovate over there in Australia from Roger. Brian Wolf at Willis Racing Engines brings them into the country for us. And with ITBs, they can be a pain, to be honest. That traditionally, individual throttle bodies are kind of hard to sync up. They're hard to make them idle. They're hard to make them repeat. And I wasn't extremely excited about this. I kind of figured they would do good at wide open, but I was like, let's see if we'll even be able to get it to idle. And if you can make it idle, will it even take any throttle? Man, first of all, the machine work on these is magic. It's artwork. So congratulations to Roger and those guys that build them. They are flawless. But I did nothing. We took the Holley ECU program that we had for the stock manifold. We hooked these up. I did nothing. Hit the button and it fired up. It idled at 800 or 850 RPM. Like, it's absolutely simple to make them work. It comes back to idle. It doesn't stumble or stall. Takes throttle like,
crisp.
Oh man.
So crisp.
Yeah, like you typically get with ITVs. And so in this case, we got all of the good and none of the bad. I say it's an A+. So I'm going to be calling up Brian asking for a few more of these for some of our other projects. I'll tell you that.
Oh, heck yeah. Godzilla for the win! Runner length.
Kind of an interesting subject, right?
Yeah.
The Engine Performance Expo here in Piney Flats, Tennessee. And they are excited to be here in person, as am I, for our first roundtable discussion. Going around the corner from my right, we got Ben Herheim. Of course, Billy Godbold making his first appearance so far. Climbed out from under the table after that whole FSU debacle. Sorry, Billy. Got to throw a shot. Got to do it. Of course, Pim Vandenberg, Chris Straub, and Lake Speed Jr. These are my favorite, the roundtables, because we get to see and hear what everybody's thinking about the direction of the industry, where things are, where they're going, what's happening, and what is hot.
I agree. I love the roundtables, and this one's is really key. Like, we're just showing the eye in the sky shot. We were saying, 4 years ago, we couldn't even have more than 7 people in the building at a time when we were doing it, because that was during the middle of COVID and everything. And man, things have changed a lot. I mean, so part supply, all kinds of effects that came from COVID really did impact our industry quite a bit. So I felt like it was appropriate to start off this year, and let's have a kind of recap. Where are we now with everything that's changed in this world? What's the temperature?
On the retail side, we get a lot of guys that have been hot rodders for 30, 40 years and stuff, and they're asking, why can't I get this? Why can't I get that? I know one hot subject right now is flat tappet camshafts. You can't get flat tappet camshafts and stuff. So we're trying to explain to them, the cam grinders ordered on the tail end of the OE suppliers for decades. Mm-hmm. Well, GM, Ford, and Chrysler haven't made a flat tappet production engine in over 25 years. Well, when that market fades away, it's kind of like, some of us know what a rotary phone was, but when's the last time you saw a rotary phone? So Billy and I were talking the other day, and being where he's worked over the years and stuff, he's got a really good perspective on kind of how the industry's transitioned. So I'd like, Billy, just to tell the public out there kind of what's going on.
Well, yeah, I mean, Chris, you're right. When you set up for, I guess as long as I can remember, the F-150 was probably the biggest selling car in the U.S. And, they had, CWC, Textron was pouring all the cores for that. Even when they went into roller camshafts for GM, Chevy, with even Dodge, those were poured at CWC, the roller camshafts. That whole industry kind of got moved around to these assembled camshafts, different technology, and trying to get it's sort of like you build this aircraft carrier when you need a PT boat.
Right.
That we built this huge facility to serve cast iron, and now the market's tiny compared to what is. And we even talked about it, that you think that we'd get on the tail end of a pour for OE, but even things like the agriculture industry is much larger than performance. Even somebody making aircraft engines, that'd be larger than performance. So our industry is a spec.
Yes.
On a spec. And so that you take an industry that was built for hundreds of thousands, millions, and then you say, hey, I want 100 of these or 1,000 of these. How do you resize that same factory to do that? How do you build that business? I don't know, and I don't think anybody else really knows how to do it.
Well, and I think I was told at one time, we Engine Power Components that grinds a lot of camshafts that would be buying cores from CWC, and I don't think I'm misspoken on this, the performance industry represented less than 1% of their overall volume and stuff. So, and we have to look how things have changed. I mean, we have roller camshafts now. It's steel cores. The other thing is the labor part of stuff type deal. You can't get people to work. Ben, you're at Andrews Camshafts and trying to get people to work. Chicago area, highly populated. What's it like to hire people to work in the plant these days?
Sounds like it's going to be, it is difficult. It's going to be more difficult. We run 2 shifts. Luckily, we have a bunch of really good, dedicated people that keep showing up, but every time that we want to add equipment, we have to find more people to staff said equipment. It's difficult.
Right.
So you buy robots.
Okay. And then, Pim, what are you all seeing? Another complaint's pistons. Why are my pistons taking so long? Why do my pistons cost so much type deal? This is what the public,
you want to talk cost?
Well, and they're on the internet saying, there was a gentleman that just spoke the other day and posted, 5 years ago, I bought a set of forged pistons and they were $750 for my big block Chevrolet. Now they're $1,200. I mean, what are you all seeing in the piston?
Well, the cost of aluminum, for one, has changed, and the cost of forgings and the planning of forgings. For us, it's a real challenge we're going to have stock bore on hand. We buy them bar stock. We buy by diameter. If we get an order for, let's say, 4.5 inch, if we have the bar stock, great. If we don't, it's 6 to 8 months to make sure we scheduled that ahead of time.
Now, wait a minute, 6 to 8 months,
Yes.
not 6 to 8 weeks,
No.
not 6 to 8
We-
days,
Our bar
months.
stock, we plan way
Months.
ahead, and the investment on that is quite substantial. So we have literally several $1 million of bar stock on hand to be able to satisfy a spec of a market that all of a sudden says, hey, this is no longer a hot size. We're going to go with this because this is way cooler and it works way better. Billy is one of them. He goes like, I want this.
Right.
Well, I don't have bar stock for that.
Especially if it's bigger, that's a problem.
Yeah, it gets to be a challenge. So you have to plan that. And then, well, we fortunately in Mexico, with our plant in Mexico that makes all our forgings, we have a very, very loyal crew, very dedicated and qualified people that have been working there in the plant for, many have 20 plus years. And so that part for us is not a problem. What is a problem for us is making sure that we get our smaller orders pushed through a manufacturing plant. The same issue you have is when you have a low volume item come through, it's disruptive.
Mm-hmm.
Yeah, I personally would love to make one piston, one size for everybody. It doesn't work that way, especially when you get into customs. But it is a bit the reality of the future. I mean, you see more and more people wanting specific things, specific designs, specific attributes on a piston. Now we just got an order in for a set of pistons that have a 0.6 piston ring, the top one. We don't have
real piston ring, by the way.
Yeah. And you make a good piston ring for it. My tooling, at the moment, the smallest ring I've cut so far is 0.7. Now I go to another. What's the end? And how do you cut that without crashing the tool? Mm-hmm. So we're in that challenge.
Yeah.
So
it's a big deal.
It is.
Yeah, and then how do you measure it? Because you got to get a probe down in there that goes in.
And a lot of people. So here you have a good example where why is my cost so high? Yeah. Things like that change. You think about the tooling, but you're absolutely right. Probing the equipment to measure what you just did.
Yes.
To make sure. Somebody said this morning there's not enough testing done in our industry. But our industry moves so fast. It is sometimes so difficult to actually test something that you built. So when it comes to customs, you're building a piston based on the communication between our engineering guys, Daniel Shearhold, Tom, and guys like Billy.
Right.
And it's a Lake, Nick Klunder. Those guys get together and they build for us, okay, this might work, or this is gonna work. So it's really cool, but it's challenging, and yes, it'll impact the cost of the part, for sure.
And Billy, back to you on the camshaft stuff. In your previous life, you've been around cam grinding. Over the years, what was from going from flat tappets to roller camshafts? With the transition 20 years ago, how many flat tappets did you all grind at your previous employer compared to, when you stepped out on your own? And, I mean, what was that?
We'll just give a, back of an envelope, say that if comp would grind 400 cams in a day, maybe it'd be, 250, 150, or it'd be 200, something like that for a long time. The thing is that it's really hard. People don't realize how much of a system an engine is. Like we had some oil guys come to us and said, hey, we want you to make a flat tappet LS, and sure, okay, and they're like, well, how much is it? Well, it'll be $250,000. And they fall out of their chair, and you're like, well, yeah, we've got to make patterns for it. Then we have to test with the offset. We have to do all this stuff, and you have to have enough to make. And in a year, you give us $250,000. A year from now, you'll have all this flat tap and do all this test. And they just like I said, they fall out of their chair. It's hard to change people got this idea that when I was, we'll take it way back to when I was a 16-year-old Billy racing my Jeep, in mud drags. And I wanted to take my flat tappet cam out and put a solid roller camshaft in it. And I went to Bill Metzger at Laser Camshafts.
Okay.
And I'm like 16 years old. He's the only guy that'll talk to this crazy guy, because everybody else no, you're a kid. But it was going to be like $1,000 because I had to buy the billet camshaft, I had to buy the roller lifters, I had to buy different length push rods, I had to put new heads on it, studs on it, different roller rocker arms, different valve springs. I had to change the whole thing. So people got this idea that going from a flat tappet to a roller was this super expensive deal. Now, honestly, the valve spring and push rod and rocker arm, especially the valve spring and rocker arm, don't know whether it's a roller or a flat tappet. They just know how quickly you're moving the valve. So perhaps you could do a roller camshaft that uses some of the same pieces. So I don't know, and that's something we're going to have to be better at talking to our customers about. But changing technology over, the reason everybody just didn't go over to rollers is they were like, man, it's $1,000. I don't think it has to be. And then the whole thing to do a flat tappet right might be even more expensive because, my goodness, if you had to do a DLC lifter on a steel flat tappet camshaft, that's going to be more than $1,000. And man, and you talk to these people on the phone that do a flat tappet and have an infant failure, have one wipe a load. Well, that's going to happen a small percentage regardless. If you do everything right, you're going to have a certain failure rate with a flat tappet that there's not with a roller. And that when it fails, you need to take all the cam bearings out. You need to blow out all your oil passages and everything like that.
It's not a fun day.
If your time is worth a nickel, if you're a $5 an hour guy, you might put $1,000 worth of your time in pulling this motor out of the vehicle, tearing it down, cleaning everything out, putting new bearings, new gaskets, and putting it back together again from failing a camshaft as you would. Or do you just risk it, put another one in there, and maybe you got junk in your oil galleys and you kill another one,
Well, and that brings to the point, if you got Joe Senior and Joe Junior and they want to go circle track racing, okay? So they're on a budget. Both of them got decent jobs and stuff, but they're going to build their own engine and stuff, which hey, that's what this industry is built on, building your own power. But if they're going in that class and that flat tappet fails, and they're like, well, that was a fluke. Well, then they get another flat tappet, and it fails. So now we're 2 in a row. I've got some customers that have failed in the same engine 3. How's that taste for Joe Jr. wanting to go racing with Dad? Dad, we haven't even gone racing. All we're doing is building this engine over and over and over again. So go, transitioning from that flat tappet to a roller, the benefits of that, Billy, for long term and stuff.
Well, you could imagine if you were an engineer at GM or Ford in the mid 80s, and you're buying a camshaft and lifters, let's say for $30, and that's being generous, being really generous. And you go up to your boss and say, hey, I want to put a roller lifter and a roller camshaft, steel roller cam and a roller hydraulic roller lifters. Now let's just say that it's $130. That's the other was cheaper than this, and going to the roller was more expensive than $130. But let's just say that. Now you do it over a couple 100,000 vehicles, and you're already talking about millions of dollars they spent a year to go to roller camshafts. Why'd they do it? Well, to save money. Why'd they save money? Because they didn't have to worry about those failures. Because they're building hundreds of thousands, they statistically, whatever they did, they were going to have failures. I don't think people realize that when they're only building 1 or 2 or 10 engines, that there's going to be failures with flat tappets, no matter how good you are.
And they could reduce the amount of zinc and phosphorus
in
the oil.
That came about later.
They also let them have smaller catalysts. Well, platinum and palladium that are the catalyst is really expensive. So
and
the total cost involved in the end, it was cheaper for them to do that in the grand scheme.
After they found out, because then all the controls, because fuel injection stuff, so much came around, they'd never go back.
No.
But it's interesting. You talked about the one guy with the block too. One of the things that's interesting, working as a consultant, I'm very good friends with Norris Marshall and the guys over at Blueprint Engines. And when they started to do their own blocks, that they were able to index those lifter boards on their blocks, where you would get used blocks, seasons blocks, and these things will warp over time. And so you'll have a couple of blocks out there that unless you send it somebody like Keith Dorton, have him put new lifter boards in it, somebody to index that lifter board, you can wind up with a block that's going to eat every camshaft that goes in there.
Well, in your past history too, I remember years ago I said, well, what about zinc? And then you said, well, which formula is zinc, Chris? I think a lot of these people just think, oh, I'm just going to stick some additive in when I do this. Can you touch a little bit, because you've always said it really needs to be done at the refinery to get all of those anti-wear and stuff. Touch on that with the flat tappet stuff.
So there's two things. Back to Billy's point and Marshall's experience is that no amount of zinc can fix bad geometry.
100%.
It will fail. I don't care what you put in there. The second part is, there are more than one type of ZDP. So zinc's not just one thing. It's a family. And it's actually part of the blend process. And that if people that just go buy an engine and they get that bottle of ZDP and they just pour it in the valve cover and they fire it up, well, where's all that stuff? It's still the valve cover. It's not mixed in the oil. It's not at the camshaft. And as we both know from doing flat tappet spintron testing, that thing, even though it may not audibly make noise that it's dead until 20, 30 minutes later, it will live or die in the first 2 minutes.
Yeah. And the people don't understand when you're trying to brew your own home chemistry, that there's only so much surface finish, and every additive in there is trying to grab hold of the surface.
Yes.
So all of a sudden your detergents that are really important, if you can go a while between oil changes, they're grabbing hold of that surface and they're getting in the way of the zinc. So you really want a break-in oil that was formulated to let the zinc do its job.
Yeah. That is the truth.
Can I jump in with a question as, I'll call myself a novice. And seeing some of the questions out there as well, there are some series that by rule use the flat tappet cam as what at the time was a restrictive, cost restrictive measure. Should we encourage them to move beyond those rules?
Yes.
Should we say, hey guys,
Absolutely.
Stop with the flat tappet cam, it's counterproductive now, and it's time to just, I hate to say this word, but kill that old technology and move forward with this newer, now cheaper, easier, non-disruptive, more reliable technology of a roller cam, and stop with the flat tappet cam? Should we do that here today?
So Joe, to your point, because Ben and I have been working on this for about the last 18 months and stuff, we actually have a flat tappet series that we've been working with one of the founders. Ben developed the lobes to match the flat tappet lobes. We actually did 3 camshafts. We did a camshaft that we knew would work, a camshaft that would push the limits, and a camshaft that would absolutely destroy the Valvetrain. And Ben, after the results with Ben's lobes, we were within 4 horsepower of duplicating that power. But Ben, I'll let you touch on that as far as core availability and that type stuff.
Well, as far as the flat tappet cores go, what I have in inventory right now at our facility is less than 2 dozen. So what Chris and I devised, his idea, was to
your talent
mimic the same motion that the flat tappet cam had in this particular series. This series has a valve spring rule, so we were utilizing the crummy little spring that was made for the flat tappet with a roller cam. We were able to do near same motion, roller lifter. Roller lifter really wasn't much heavier than that flat tappet lifter, was it?
And it was a solid roller profile.
Solid roller profile. Yep. And it seems like it was pretty successful. The gentleman that tested it sure seemed excited when he called.
So now we've got something that may last 5, 6, 7, 8 years, and Joe Senior and Joe Junior can go. They don't have to replace push rods, don't have to replace valve springs, nothing.
And like I started with, they didn't really need a different valve spring. It doesn't need a different rocker.
Perfect.
It doesn't need that $1,000 that Bill Metzger was telling me to spend.
Right.
It just changes cam and lifter and then get rid of that headache.
Yeah.
So a signal to the rules makers out there to be helpful with this. Right now, people are struggling to keep up with those rules packages because they're, call it impractical. So maybe update the rule books in the near future as best as is possible.
Well, I think this is one example of a bigger picture where as technology continues to evolve, and I mean technology, I mean what the OEs are doing, back to the very beginning of the conversation, that our industry rides the coattails of what the OEs have been doing, right? That it's always been them that has been pushing forward, and then we kind of come in afterwards. As they push into new areas, be it full hybrid or full electric, hybrid, whatever else that comes along the line, we as an industry will have to respond, because our venerable old small blocks aren't going to be around anymore, and it's probably impractical just to rely on our manufacturers to be able to do everything at the cost they were before. Because now, if you still want that one, you can still get it, but now you're talking about maybe very small production, costs go way up. So to get the bang for the buck, we're going to have to think outside the box, and rules makers and people are going to have to think differently going forward. I can't see any other way of it being.
Excellent. Well, I think we have covered a lot of ground here in this first roundtable of Engine Performance Expo 2024. And I know that this group has the power to enact change out there, as there's a lot of there are people that watch this and they take this into consideration as they work on 2025 and beyond. Excellent work.
Thank you, sir.
Yeah.
Well, and what's coming up next is Jeremy Wagler, diesel guy, right? So we're talking about gasoline stuff. Well, they're facing a lot of these same things. There's a lot of change and evolution in the diesel market. So Jeremy's going to give us a little bit of talk about how that is going and how they approach it.
Hey, it's Ryan Thompson with Rottler Manufacturing. I'm here with Jeremy Wagler of Wagler Competition Products here in Odon, Indiana. Jeremy, you want to say hi for the folks?
Hey, good to see you guys.
Yep. Thanks for having us out. We've been hanging out all day. We're just doing a little shop tour, a little hanging out, getting to know you, seeing this awesome place that you've put together. You do a lot of stuff.
It's small, but we try to stay productive.
You got a lot of equipment here.
Yep.
So tell me a little bit, and for our viewers, I mean, how did you get into this? I mean, you told me a little bit, you started a repair shop?
Yeah, basically started off growing up on a dairy farm, so repairing stuff, farm equipment and stuff like that. And I always had a fascination to get a lawnmower and tear the engine apart, and never had any money to go buy parts, but we just clean everything, put it right back together. And then I got into little go-karts, so got into go-karts, playing with that, and then dirt bikes, and started a little S10 when I was in high school. We went to a vocational school. We got to build an engine our second year, so I built a small block 400, and then I put it down in an S10 and started drag racing back in 1999. I built it. 2000, I was a senior in high school, so went drag racing at the track that we actually purchased now. So one thing led to another, and guys locally needed stuff worked on, so at 19 I started my own repair facility. So I came out of high school and had a full-time job repairing trucks and cars, and did that for about 10-11 years, and always wanted to build parts. Like, as you're working on stuff, you see that, man, why'd they design it this way? Why wouldn't we make it work this way?
So for 10 years you were, and probably some of that background with your upbringing and probably not being able to get parts, you're seeing things
parts,
going, I could fix this, I could figure this out.
We worked on gas for the most part, and then in early 2000s the diesel Duramax started coming around, and the 7.3 Power Stroke, so a lot of the Amish crew trucks around here always needed repairs. So basically working with them, we installed a lot of Jasper engines, and so we wasn't building engines right then, we was just a repair facility. Got into more and more of that part, and then after 10-11 years of that, got burned out of repairs, so I turned the business over to Dad. Had a tow wrecker service and towing, turned it over to Dad. I went and worked for government for 3 or 4 years, and during that time I was able to gain enough cash flow to design my own cylinder head. With helps of Jeff Jones at One Way Performance, we designed a Duramax cylinder head, went to Brodex and got a Duramax cylinder head designed and repaired or built from brand new core box, thinking that was my first step back into business, and bought a Haas machine.
That's quite the step. We're gonna
just dove right
cylinder
in.
Head.
Yep. So long story short, started back Wagler Competition. Started it back in 2011-12 area. And we got cylinder heads going. We bought some Rottler equipment, done all the valve jobs on all the heads there. We had Centroid doing all the porting. So we basically had a small little operation going, and from there it's taken off. So that's been 12 years ago now.
12 years.
And it's been from anything from billet blocks, billet heads, doing all kinds of crazy builds for truck and tractor pullers and drag racers. So I enjoy it.
Certainly, you have to get to here.
Yep. We do OEM rebuilds also for guys, but we try to focus mainly on the higher performance stuff.
If I'm not mistaken, you kind of started with Duramax mostly.
Duramax is like our key because we
still
started off with
still is your cornerstone.
It is, yeah. Duramax has been the popular one, but we do a lot of Cummins builds and Ford builds and all three main ones. So.
Are you still the Duramax guy? Is that what you
I like them, yeah. I like them, but you've seen what we drove to lunch. We drove a Ford.
Ford, yeah, that's true.
so I get made fun of a little bit, but the Ford 6.7, nothing wrong with that. But I've always loved anything with diesel and high performance. So that's our key thing here. We do a lot of pro stock tractor parts, intercoolers, anything that guys have problems with. They bring them to us, and then we try to problem solve and make it stronger, better.
Talk to me a little bit about that. I mean, for your background and how did you, I mean, I know you've got people here, you guys are doing your own programming, you're designing parts.
Designing parts.
I mean, did you just pick that up?
We mainly,
napkins,
That's how it starts.
How'd you get through that?
That's how it starts. So on the connecting rod business, we basically bought out. We was using a company called R&R Connecting Rods out of Illinois, up close to Chicago. He sold out the steel division, and he called me one day and was like, "Hey, you're buying enough rods. Why don't you just take over the steel side? I'm moving to Florida. I'm going to build aluminum rods." So that's how it started off with these. But we've redesigned all these rods, basically. SolidWorks, Mastercam, we got some design guys in here. We plastic print them first for clearance fitting on engines.
And I saw upstairs you had a 3D scanner plate.
Yeah,
so you're scanning. I mean, you
3D
guys
scanner,
are full reverse engineer. This
out
is
here in the middle of the cornfields of
in the
Indiana.
middle of nowhere, but you're doing it.
Yes.
I mean, you're doing it.
So we bought a 3D scanner and scanning parts. We can scan a cylinder head and basically redesign that cylinder head right here in-house. So, but rods is, as you see out in the shop.
Yeah, they're beautiful work here. You got, I mean, this thing is.
Big old
I'm a machine tool guy. This is nice.
A lot of work goes.
A lot of work in here. You can see it, but it's a beautiful piece. I mean, and you showed us, taking that from a forging
to
and all the operating. You guys have done all your own fixturing. I mean, you really are working through every step of the way and trying to automate as much as you can.
And we try to keep, every year, we try to keep on growing in production as far as making them easier, better. Every year you can see growth every year.
Yeah.
So
and this
new technology.
Because we're talking about your design. You were showing me this because obviously the tongue and groove because you can't do a cracked rod.
Yeah, fractured rods in the factory. We went away from that when we bought R&R. He was just using a round dowel, and we seen it chafing back and forth.
Yeah, and for those of us that don't, I mean, maybe explain to our viewers here because you were saying you guys saw that a lot on the cap side. One of your failure modes, the wear things you would see is the cap shifting back and forth.
Caps that shift back and forth, and the best fix that we found was basically doing a tongue and groove deal. So it's a female and a male, and then it goes at an angle, so you can't rotate the cap. It only fits on one way, and it is tight. So like once it's on there, it's locked, you're torqued, and it can't like shift the cap back and forth any at all. A lot of times we would get them back in, and this surface you could actually see where the rod was twisting, and the cap would move. You'd see wear marks on the side. So now with this setup, it's staying perfect.
Awesome.
So, but single pass honing, we've gained a lot of knowledge on that. It's just there's so many different ways a guy can build rods. If we was building them for the OE, I'm sure we would have to change our design as far as machining. But for the production that we do, it works perfect, and we're having really good success out of it. Thank you.
I mean, that's a great example. And I know you shared this one here, these lifters.
Yeah.
I mean, I'll let you explain on this thing, but I lift this thing up and you hear it shake on the tolerances, how loose it was. And this is factory part.
So it's a factory, again, finding an OE issue. Customers started calling on the 2019 Cummins. Basically, they would hear a noise coming through the driver's side fender well, go to the dealer says there's nothing wrong with it. We originally pulled the valve cover, ready to adjust valves, the valve adjustment. They took the screw out of it, so there's no valve adjustment on the new Cummins. They're hydraulic. From there, we just bought a bunch of Cummins adjustable rocker arms from the 2009 or 18 and older, and we made a kit that drops in basically take I call them the guts of the hydraulic system. Take the guts out of the hydraulic, you put a solid plunger in here, put it all back together. We got Manton to make us some push rods, and it's back to adjustable, and you can set your lash at what you want. But basically, it's a terrible design flaw. Don't want to beat up the Cummins guys bad, but it's eating.
It's big manufacturing and tolerances. I mean, it's a different world.
But as you can see,
it's things that we all have to be aware of in this industry, especially when the applications matter. The applications you're building engines for that your customers are coming for you are not 350 horsepower diesel blocks.
No. And we're coming back to you guys for machining capabilities to be able to help us fix this. So basically, we went to Jessel. We designed a solid roller lifter now. So went to Jessel. One key thing that you can see between the factory has like a little straight edge right there, and that's rotating. So once it's losing hydraulic pressure, it's rotating back and forth, and as you can see on the camshaft, it just eats the lobes right off of it.
Yeah.
So that engine there is
20, 30 thousandths below.
80,000 miles is all that engine had on
80?
80,000. So, but again, that's kind of how our business started, and I like keeping it in that same groove. We're trying to find the flaws of engines that come out and fix them and try to keep building them better and better. So taking a 300 horse engine and making our highest horsepower engine right now is 4,000 horsepower.
Right, 4,000. Yeah, that's not. So that's where you end up going to things like this, right?
Much stronger
stuff. A lot more thought, a lot more care.
But we've broke a lot of parts in the process. So if you see vehicles out there with our decal on the front and you see a ball of fire at the end of the pulling track or whatever, it's trying to find the weak points, and you find them at the pulling track or at the drag strip. So try to keep on making them stronger every time.
That's what I mean. As a mechanical engineer, that's what I love to hear.
That's what you do.
Like, that's what you do. Go and break stuff. That's the fun part of the job.
Yep.
How long have you been in business doing this type of work?
Since 2011.
2011,
so,
really here.
So 12 years.
And you're scaling like crazy right now. I mean, you're looking at a lot of stuff.
It's booming.
What, for the people watching, what are some, maybe the biggest thing you've learned, or what do you look for when you're looking at finding work and deciding how to size the factory, deciding, who to hire? What do you, as a business owner, I mean, it's kind of like looking into the dark.
Yes,
but
you're juggling family life and work and how many hours do you want to put in, and does it really matter about the money, or is it all the customers that call and wanting parts? Like, do you keep growing your business to the point where those calls are all taken care of? Right now we're not. Like, there's days we can't get all the calls returned. So do I want to get bigger? That's questions you ask yourself every morning when you walk out
scaling
here.
when you can.
We're like 20 guys here in this facility, and I feel like that's enough for one guy to try to keep managed. Takes enough time to keep everything rolling.
Yeah, it does, certainly. And it's all you. I mean, like you said earlier today, you're like,
trying to,
you're still leading that whole charge, all 20 of them. So
I'm not doing a real great job
I don't know about that.
That's part of it.
That's just humility. Talk about the drag strip a little bit. So, I mean, this is pretty unique. I mean, you go to shops, guys are doing stuff to varying levels, but you've got a drag strip and a school situation going on?
Had the opportunity to buy that drag strip that we was talking about. I was racing back in 2000, early 2000s. It was a brand new, the track was built in 97, so it's a fairly new facility. It went through a couple owners. As you know, drag strips, they usually change every 5 years, so it's not a moneymaker. Basically, I bought it in hopes of being able to build a school and like an educational center, because I didn't go to college, but I always thought, man, if I could have went to a trade school for what I wanted. I didn't want to do all the
be focused
English
on
and
something
math and all that stuff.
You wanted to be hands-on. You wanted to do.
I was a hands-on guy, so my goal was, let's get a school started up there to where kids can go there and go right to work instead of going to college. Not saying that's for everybody, because you have to go get.
I went to college, and I tell people that there's recordings of me saying, don't go if you don't know what you want to do, because
you need to be specialized. You don't want your doctor to not go to college, so you want him to go to college.
You want him to be there. But
But that was my goal, so I bought the racetrack, and within a year, got to asking around, like, how can we get a school going? And sure enough, met a friend of mine, and he turned me on to a education training center, and we ran welding. Started with welding, so basically, any age from 18 and above could come in and do welding classes, and then they'd get a degree and go get a job. That led into CNC machining, so they was coming into this shop at the beginning. Training in here. It just kept growing and growing. Now we're doing CDL.
We
got 3 semis up there, full-time guys training A and B now. Doing welding, getting ready. That was MIG welding. Now we're getting ready to start TIG welding in August, so it's getting ready to take off TIG welding. And then CNC machine is actually placed up there at the school. We do nursing. You can go get your GED.
No way.
Yeah, so a high school student doesn't have to go.
Doesn't have to finish all the way. GED.
GED.
That's fantastic.
So we have it right there. This year we graduated 308, I believe, people in 2022. So it went from a little idea, and within 2 years, it's
2 years. Yeah, that's
2 years. It's went.
That's got to be huge. I mean, for the reward for that.
It is. Watching
and then
graduation.
For this community, I'm thinking the welding out here in the farmland. I mean,
coal mining.
Yeah, I mean, these are real skills that young people can learn. and actually help their community, help themselves have a fulfilling career. I mean,
it's pretty awesome to be able to see that, basically you're helping guys get off of either welfare or no job or things like that. There's guys that come in that are making $10, $12 an hour.
Right.
They take a course for 8 weeks, especially the CDL thing.
Yeah.
They can leave there making $70,000 to $80,000 a year. CDLs are much needed thing.
It's a life-changing thing.
It is.
Absolutely.
Yep.
I mean,
So
we need those.
During graduation,
those are real, honest jobs that we need desperately as a country.
But one thing that I have struggled with, everything struggles, is getting people to adapt to learn about CNC machining. So we have to do more promoting and show people and kids in school like what is CNC machining, because you talk about it, they don't grasp that this part was CNC machined.
Right.
So I need to do more advertising and basically information, getting the information to the young kids and the people out there that would love to do this. They just don't understand it.
Well, I mean, we're all guilty of it. In America, the society we live in, you buy something, it shows up from Amazon, that you're like, hey, there it is, they're done.
Don't even think about what it took to make that.
I didn't even realize until I went to engineering school, and you see it through working on things, you see it when you go to school, and the amount of stuff that goes into something, any one of these parts, and
it takes time,
sweating
energy,
the details and the understandings and the science and like you said, breaking a bunch of things and learning, constantly learning. You just don't grasp that until you go do it.
But that's one part of the school that was my main intentions, was getting someone in there to get CNC programming time. We got Mastercam up there. It's growing, but at a slow rate. The other stuff, the CDL things, I think it's an easier thing for people to see a job opportunity, because they're always, you go drive in any city, you see CDL drivers wanted everywhere. Who would have ever thought we'd buy a drag strip turned into school?
I think that's awesome. I mean,
we still have drag races, so we do have drag races.
Yeah, the gassers. The gassers were down here today,
weekend.
I think?
Yep, they're coming this weekend. So basically, with drag race, we have a pulling track. I built a pulling track, so truck and tractor pulling is within 1,000 feet from it, and then motocross racing is out there too. So we have motorcycle racing, dirt track.
This place is, you
can do it all if you want
Engines, machines, school.
I always tell my kids they're growing up with a lot more than what I ever.
You're doing it all right here and giving it back to your community. And
trying to make it a good place to go enjoy the motorsports. So
a lot of the EPE stuff, it's educational. Trying to get people to understand and see some of these things you don't see every day in the industry, and CNC manufacturing has become a big part. Obviously, Rottler's being a part of that. What would you say is the biggest challenge, or what was the biggest challenge for you? I know I saw a Bridgeport out here. Everybody learns on a Bridgeport. Today, you may or may not ever learn on a Bridgeport.
No,
I mean,
I think a
kind
lot
of get
of
dropped on a Haas VF2 or a Rottler EM69 ATC, and it's just go.
I think a lot of it comes down to is not being rushed into something. So like, you got to take the time to learn a little about machining, but anymore a lot about Mastercam and the programming side. So how are you going to fixture that part? That's a lot of the, that's almost as much as knowing how to machine. You got to know how to hold that part.
There's an old quote that I always loved, and it was, machining parts is easy, holding on to them is the hard.
It can be hard, especially when it's 5-axis and it's rotating. So
I think you're absolutely right.
And one thing you can't beat is experience.
Right.
So if you can find guys that have experience in the CNC world and get them trained up, like we're buying, we bought the scanner this year. We never dreamed that we would buy a 3D scanner to scan engine parts, to be able to machine engine parts. So it just keeps growing. Basic machining, or the want to, if you want to make something, get on a Bridgeport, start machining, and then
start making chips.
Get it,
I think finding that mentorship role. I mean, I had that when I started, and I had a couple of mentors with manufacturing, machining, and if I hadn't had that, I mean,
where would you be today?
Even I got a 4-year degree in mechanical engineering. You're not learning.
You're not going to learn that no.
And luckily, I took my first job, and it was special projects fabrication, and I had that mentorship where it's like, okay, we can go and make parts.
And even in the machining at colleges, and I'm not disgrading any of the colleges, but basically you still don't have that experience.
No.
The experience is so much more than just going to school and getting a degree. You can't go out and just say, I'm a machinist.
100%.
You're a beginner machinist, and that basically you're willing to learn. That's one of the things when I get kids coming out of college. We hire several of them. Vincennes University is a good college. They teach a good program, but they're not ready to go make all these custom parts.
No.
Baby steps.
You start. I always tell people, I've taught multiple people, my employees back at Rottler, and how to CNC machine, and it's a block with 4 holes, and that's center drill.
And it takes time, and I'm not the expert. We got guys out here that are really good at it.
Everybody starts there, but you step, and it's fun. It's very. I always thought it was rewarding. Obviously, you have to. Otherwise, you wouldn't be making all these things.
We keep on
advancing
and trying to, like you said, automation is a big thing right now. Getting cobots attached to the machines so you can keep parts going day and night.
They're the real deal here. He's talking. We showed up this morning. He goes, "Yeah, I'm getting a horizontal, and I want a cobot over here." I mean,
hopefully we can keep it growing. That's my goal.
Yeah, I was like, all right, this is a place we're going to be here all day. So.
Didn't imagine that pulling into a little shop out.
No, you got it real humble on the outside too, and you go,
signs,
and then you undersell it too. You're a good
yeah.
dude. You undersell it, and you walk in. I'm going, wait a minute. You say you want to go upstairs to the conference room? I'm like, no, I want to go look at the machine.
Get the machining side.
Yeah. So,
but like I said, we're still small, and we enjoy what we're doing. So that's the biggest part. So as long as we can keep doing that and making quality parts going out the door every day, I think we'll stay in business for a long time.
I hope you can, because we can help each other out and keep doing more of this. Well, we'll wrap it up. I mean, been an honor. Thank you so much. Thanks for doing this video. Check out Wagler Competition Products. I mean, Jeremy's doing a great job. I mean, he's got a lot of cool stuff, and sure we'll do another one. All right.
Diesel power, big part of Engine Performance Expo. Lake, we've assembled another panel. Of course, Chris Straub is always stealing the show when we're here. And I
makes life easier for us.
Keep going, Chris. But Kaase, Choate, welcome back. Chuck Lynch, welcome back. And we're going to delve into something that's kind of you have been involved with recently.
Oh yeah, so I mean, Jeremy Wagler does a great job with the diesel stuff, and Jeremy and Chuck are good buddies. And so this past fall, we went and visited. When I came and visited Kaase, we played a little bit of some diesel stuff there. We've still got to work on that. This projectile thing, he's got something there. It's kind of neat because you have a show. Talk about your show real quick.
Yeah, so it's called Diesel Masters, which is fitting, I guess, for this bit. But basically, it's a show that what generally customers had issue with. They send us a truck, and then we'll take something and we'll find out what the problem with it is and diagnose it, but then try to make it educational and fun at the same time, which it's kind of where Mythbusters meets Orange County Choppers, except nobody's throwing anything, and if they are, there's generally gunpowder behind it. Something like that.
Yeah. So we're working on something for that, on that idea.
And where do we see that?
And Chuck is, so you can definitely see that on our Choate Engineering Performance page on YouTube. You can go to our channel, and we've got a couple of episodes up now. And actually, Chuck is heavily involved in that, and there's some episodes with him blowing up some stuff too. So you can entertain yourself while educating as well.
There you go, another YouTube subscribe. I think I saw one of the pilot episodes. Frankly, I'm super excited that that's going well.
So anyway, working with Chuck on this to get ready, so make sure we can do it right when we come to blowing things up. We worked with Jeremy to do a test on some piston rings. So of course Jeremy's building all these crazy engines and taking a stock engine, a stock short block, changing out just like the rods and some other stuff, and it is kind of nuts. You guys have been telling me this for years, but it is insane to actually be there and watch them just add fuel and just watch the power just go, not little bits, it's just like jump, 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 just incredible chunks of power. So it was back in November, I think it was.
Right.
Yeah, we went and hooked up a JTEC blow-by meter, so it's a flow meter, so you can see how much air is going into the crankcase, like what's going past the piston rings. So we took the stock piston ring setup and ran it at different power levels, from like stock all the way to like 900 horsepower. Measured the blow-by. Then took the whole engine apart. All we did was swap the second ring and went from the standard, conventional gap second ring and put in a gapless second and put it back together. And it cut the blow-by in half. But it picked up like 40 horsepower at the 800 horsepower tune-up. And I fell out of my chair. One, again, when that thing makes 800 horsepower, it's making like 1,500 something.
Right, at 62 pulls, and it made up 1,600 foot-pounds, and right at the 1,000 horsepower mark.
Yeah.
And this is a street engine that's, calibration wise and whatnot, it can be street and meet emissions or whatever, or you can take it all the way to that extreme on that same build.
It is insane, Joe, to feel the ground shaking when you have 1,600 foot-pounds. The turbo sound is like, what the hell? It is incredible. I mean, it's not top fuel, but it's pretty damn close.
Well, but that's the difference, is that it's practical horsepower.
Right.
Top fuel, which I love and I live around, and it's amazing, and it brings in 30,000 people to watch 11 or 12,000 horsepower accelerate to 1,000 feet in less than 3.7 seconds. But it's pretty much one and done. What you guys are doing is it's working power. It's power you can apply. You can drive it. You can go to the grocery store. You can tow endless weight, and that's what's amazing. And in previous conversations, Kaase, like you've indicated that you feel like we're still on the early part of the learning curve of what's possible, as we're still finding weak links in the chain.
Yeah, there's a lot of things that are coming about that I've already seen patents that have been filed for. Very interesting. Some of the concepts is that the entire secret sauce to the diesel engine is the injection of the spray pattern and the relationship with the combustion bowl. Timing is everything, and it's we went from a fixed vane turbocharger to a variable geometry turbo, and that was a world of difference in throttle response. But one of the new patents that has, well, and I say it new, it's not necessarily new in the way that it's been filed for, but no one has moved on it yet, and that is a variable pitch or variable spray pattern injector, so that we can actually target the bowl in different crank angles and still maintain the relationship of the contact area between the injector spray pattern and the combustion bowl itself on the piston. So that in and of itself is going to create tremendous amounts of efficiency, because 750 degrees is what the your emissions starts to break down. At that point in time, it has to reach those temperatures. Being able to control the injection spray pattern, we can control heat. There's certain areas, the further we get outside of the combustion bowl, the hydrocarbons now start to creep in, because the heat is starting to dissipate a little bit. So there's a lot of technology that is still left undetermined. There's a lot left on the table.
That's it, because that's one thing we saw as we added fuel. We never changed the size of the injector.
Right.
So how do you add more fuel? You can only change pulse width, right? Pretty much, right? So when we got up there to that 1,000 horsepower tune-up, we were having to start the injection sooner, back to the timing.
That's right.
And what you could see with the JTEC blow-by meter was that blow-by went up.
Right.
Regardless if it was gapless or conventional gap, both of them went up. Now that delta was still the same, but blow-by increased. Well, why did blow-by increase? It's because we were putting fuel directly on the cylinder wall now. It's not going into the combustion bowl on the piston, it's going onto the cylinder wall, which is washing away the oil, which is losing the seal, which I talk about all the time. It's my favorite topic in the whole wide world, right? I know everyone's tired and bored of it, but I'm not tired and bored of it. And in fact, when you see things like this, it just reiterates how incredibly important it is. In the last roundtable, Billy was saying how engines are not a just collection of parts. They're a system. And its ring seal is a system. It's the ring, it's the hone, it's the piston, the fuel timing in this case is a huge contributor to that.
It would be the equivalent of saying if we were still running as far as changing our ignition timing with the aid of computers now, to going back to the old days with a distributor that we could set the timing at one place. We are able to change that. Now that's a whole nother world that we've not really tapped into yet, but that's the equivalent of it's just as important to be able to change the injection timing as it is to be able to change the spray pattern and its geometry and its shape. And when it happens, that's when you're fine tuning now, and we know that from other engines and different things that we do. Once we start, there's a whole nother table of like a whole nother timing table that's not even been tapped into.
Right.
So I think that's going to be a big change for us, and as things progress and technology increases, we'll be able to see the benefits of that.
Yeah, just to jump back a little bit, because we are midpoint in there. Okay, we used to have one big injection pulse, and that's your diesel engines that you could hear 3 blocks away, clack, 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 because, okay, they're compressing the air, one big pulse, boom. Now you take a look at what split shot injections, 7 injection pulses per compression stroke. So you get your warming pulse and all of these things that are happening, keep the piston velocity high, you know, so we're bringing all these injection pulses in, but they're all happening in the same hemisphere of the combustion chamber. And then now I'm moving, like, if you ever look at diesel pistons, you got that dish, that's the part that's moving around. So sometimes I'm spraying there where I want to be, sometimes I'm spraying against the wall and washing the cylinder wall down. But if you can get variation to where it's actually spraying that pattern, then now you've really achieved a lot. And again, that the whole timing table that's not being tapped right now. And you know, that's quite honestly to carry over into the direct injected gas work, because the engine parts and components are getting much, much closer. That's the problem that they had with direct injection years ago. Mitsubishi did a lot of testing, and NOx was the problem. It goes back, the emissions are high, NOx is an issue. So that would be an area that they could really fine tune and clean up.
Yeah.
So.
You know, and coming from the gas world, you know, I got into doing diesel camshafts probably, now I guess it's been 10, 11 years ago. But, you know, I had some pushback from the diesel world and stuff, and said, you know, what's that, you know, redneck from Tennessee? No, he comes from the gas world. Well, you know, they're both air pumps. The diesel's just in constant detonation, okay? They both need air and they both need fuel. And in looking at it, you know, to me, the valve events is what's the most important thing as far as the camshaft timing and stuff. So in developing the camshafts and stuff that I have for the Duramax, the Strokes, and the Cummins and stuff, and I'll take my Duramax camshaft for instance and stuff, it's smaller than the OEM camshaft, okay? It's smaller duration-wise, a little bit smaller lift, but it has a totally different valve event pattern and stuff. That camshaft in a bone stock Duramax is 70 horsepower and 180 foot-pound average. That's not peak gain, that's average as far as that goes. Then it spools the turbo 600 to 700 RPM quicker. It also gets better fuel mileage. And the diesel world to me is the perfect crate motor. If you're not changing the stroke, you know, I deal with big block Chevrolets, is it 396 inches or is it 750 inches, okay? In the diesel world, you're not really changing the RPM range. Generally, 95% of the time, I'm saying you're not even changing stroke. So it is the perfect crate motor. I have hot shot customers that have got hot shot, that build hot shot trucks for guys hauling freight. They use that Duramax camshaft. I also have customers that use that and pull trucks and drag strips and win lawn championships. Same camshaft, just more fuel, more boost.
Yeah, that's what's amazing about these engines is they're so overbuilt for what people use them for, you know?
Well, I've been telling you all along that diesel's better, but you won't listen.
I'm catching on, Kaase. I'm catching on. You know? So, anyway, we could go on all day about this because it is pretty freaking cool, but we're not done yet. So, next up, we have a video with Matt Hussey doing some sleeving on a diesel engine.
All right, hey, welcome back, guys. Ryan Thompson, Rottler Applications Engineer here, standing with Matt from MSH. We are playing around with a 6.4 Power Stroke, right?
Sure are.
Getting ready to do some sleeving, which is a topic that doesn't get covered. I don't think gets as much as it should. And you've got some good experience, and we're just telling me some very interesting things about different sleeves and what you look for, and specifically what we look for at this block.
Sure.
So I'll tell you what, before we get started, let's hit that start probing button so we can let this thing run, because get this guy going so we can get ahead for the work schedule of the day, right?
There we go.
That's the answer.
That's what's awesome about the FC.
Just like watching it, huh?
He gets to do the work.
Now we'll be distracted and we'll forget about the viewers, but that'll be all right. So, talk to me a little bit about the applications, you know, specifically on some of these diesels here, and, you know, non-boosted, boosted, things like wall thickness. I mean, you were telling me a bunch.
Yeah.
Rattled me off.
Well, one of the biggest things we were talking about, I like to touch base on, is with the Power Strokes, or any diesel as far as that goes, they're bad about cavitating. So, in the cylinder wall or between the cylinder walls where you can't really see, these things will start to cavitate. And as they start to cavitate, it gets thinner and thinner between the cylinders. So we take a sonic tester and we like to go in and check each cylinder, and I'll normally check it at A and B, C and D, all through the block. And I'm just trying to find the thinnest areas where there may be cavitation. Because if we're going to bore this block, we don't want to be boring the block and getting through a pinhole, because we have seen blocks literally with pinholes.
How thin have you seen wall thicknesses get
Well, we've
down
seen
to?
them go all the way through to where when you bore it, it'll go through into water. So that's kind of scary. And you thinking you're fixing it with a 10-20 over, and you don't realize that
you're making things
cavitation-
worse.
Yeah, it's pretty bad.
Severely worse.
So you see that with your sonic tester. And then I was showing you earlier, which I like to touch base on, is a lot of guys like to put traditional style sleeves in and leave a register at the bottom of the block. Been doing that way for years.
So I've always done 5.9s. You
Exactly,
leave that
exactly.
quarter-inch lip and come back
On
and
some
top
of
it.
these, or all these 6.0 and 6.4 platforms, the bottom of the cylinder is really, really thin. In some areas, it's even paper thin. So if you're putting in a sleeve that obviously we need to overbore to get the sleeve and the press fit correct, you can actually get it thin enough that when you go to press your sleeve in, it will break and bust the bottom of the block. So I like to use the either LA sleeve, power bore, anybody, you know, even mailing, they make a really good sleeve with a flange style top that allows you to counterbore up here, and when you press the sleeve in, it's being held up here. Yeah, not in the
when
bottom.
you've got deck thickness in there, and that's
Correct.
I mean, really
Correct.
makes a lot more
Correct.
sense.
That's right. And we're looking for certain, for me, I like to look at a minimum of a 200 thousandths cylinder wall thickness. That's just me, under boosted, as we were talking about with boost, nitrous, because these things love nitrous. They love it. And when you're building high cylinder pressures, you need that rigidity there to be able to help whenever you're, you know, racing this thing, towing this thing, whatever you're doing. You need that foundation that you can lose through cavitation. So that's one of the biggest things for me that I see is the cavitation in the blocks. So
I was always told to use, you know, a 64th inch, and we called it RT 321 inserts. They've got the sharp point so that you are getting up and giving that shoulder as much as you can. I would assume you'd do the same thing unless you had a big chamfer on those counterbore style sleeves.
Sure.
But with the, you know, what's your take on sleeve lockers and locking that in for that press fit?
Well, I like to use about a thou and a half press fit.
Okay.
And I use the green Loctite. I love the green Loctite.
Okay.
And then I've actually been using with our F69, we were talking about the circular interpolation. I like to even use that sometimes whenever I actually cut it in for my flange.
And I guess that'd be a real nice benefit about being up here. You aren't interpolating down low.
That's right. Very powerful. This machine's a very powerful machine.
But up here, yeah,
to do
you could
that.
come back and you could interpolate that, get a real nice flange.
Yep, and then you have them all even, which we're going to deck it anyway and clean it up, but still I like to put everything as close as I can in every cylinder. And using that circle interpolate and the green Loctite, that's my go-to. So that's one of my little things.
And when
I
you
love
do
to use.
sleeves, you know, I've done backyard jobs and stuff, and probably shouldn't do this, but you know, I'm probably not alone in this. I've done the, you know, well, one fluid's bad, you just put one sleeve in, and you know, stock application or whatever.
Sure.
What's your take on? You know, I've heard different ones from reman facilities and stuff. If you've got a block like this and one goes bad, are you going to run 8 sleeves down this thing? Would you run just the bank? Would you know?
Just whatever. I actually will run whatever's needed as long as everything else is healthy.
Good, yeah.
Yes. What you run into though is distortion.
That's
so you
the
have
trick
to be
with the sleeving.
you do have to be careful. We're big on obviously using our torque plates whenever we're doing the honing, and then whenever you press this in, it is going to distort over here. So before you start machining and trying to fix this here, let's get the sleeve and that area corrected.
Yeah.
Then we can correct from there.
Yeah.
So yeah, we can sleeve just one. I have sleeved all 8.
Made me feel better.
I have sleeved one bank, and I have
got a motor with just one sleeve in it. But that's how to your point. I'm like, you know that one's you're gonna push into that one.
Yeah.
Right. You're gonna push
store.
into the neighbor. So
yeah, you are.
And so doing that and cleaning that, removing that, and then also when you're removing all that material for a sleeve, you are introducing a lot of spring in these blocks. I mean, in any material, you take a lot of material out and metal out, you can relieve stress. So doing that first sleeve and then finishing that first sleeve, getting that thing corrected, getting that fixed out, and then coming back to your rest.
Huge. That's the way to do it.
That's the way you want to do it. Absolutely.
Oh yeah. But these are really good. Like I said, these are good engines. I love. This is my favorite platform.
6.4.
Yeah, the 6.4 is my favorite platform, and I love them. You know, and with this machine and the kind
Now, are
of
these
repairs.
CGI blocks yet at this point?
They're pretty much all.
Yeah.
Yeah, it is. It is.
Do you notice anything different with doing sleeves in CGI versus gray
Not a
cast?
whole lot. Not really. Not really. You're still going to get your distortion that you're going to get. What I have noticed, though, is all the naysayers out there that's talking about you don't need a torque plate when you're honing them. That's not true. That's not true at all.
Yeah.
Because,
Yeah.
I mean, I'd love to shoot a video one day where we can show just how much that changes when you actually test it before and then you test it after. I've seen as much as 1 thou to 1.5 thou of actual movement of that cylinder after you remove the torque plate. So it's pretty cool.
That's quite a lot. I mean, that's a lot in this industry.
And if you're running the ragged edge between, piston skirt to cylinder wall clearance, that could get you in trouble. Like, that could get you in trouble bad. Especially on an aluminum piston that's going to grow twice as much as a steel piston. Because the 2020 and up, Ford has released in their 6.7 steel pistons.
Okay.
The steel obviously isn't going to grow under the same temperature as more or as much as an aluminum piston is going to grow.
Right. Right.
You can run a tighter clearance. So, yeah.
With the, and your torque plate, when you press, do you press the sleeve in with the torque plate still installed?
No, I actually will press the sleeve in. I have to get the torque plate out of the way, and then I'll put it under our press and I'll press it in.
So one of the things, and Ed Keebler and I have had this discussion too with, we talk about roundness and straightness and you do a good job. And, for Rottler, for finishing, I don't know what you take for a finish pass. For me, it's always anything under 40 thousandths. If I'm putting a sleeve in, I'll rough. I take 100 thou, 120 at a time, get the material out, and I'll always finish. I like to honestly finish around between 20 and 40. Too light, cutter rubs. Too heavy, then you're affecting roundness and things are moving around. The staple Rottler number has always been at 40 thousandths on diameter, 20 aside. You're going to be under 1 thou in roundness and under 1 thou on straightness, and we've been doing that since the 80s. So we always try to make a machine of that. When I test anything, that's kind of always just been the benchmark number. It's that or better, right? With sleeving, do you see any challenges? Do you ever have any of those challenges with roundness, or how much are you checking? What are you looking for? Because, when we finish a block, we'll leave 5 in it, go hone it, and the hone's gonna get, if I get 1 thou here, I'm gonna go over to that, and I'll have 2/10, right?
Sure.
If I control it there. But with the sleeve, typically you're not honing back there before you press that thing in, you're boring it out.
Well, you're probably going to really hate what I've got to say, but I have actually changed the way that I do that.
Okay.
And I'll tell you why. I will take it over, and once I bore the block over for the sleeve, I will actually leave it before the press fit. I will leave myself 2 to 3 thousandths, and then take the block out, put it over in my hone. I will then set my dial bore gauge up to where whenever I hone the block, I hone it to get the press fit that I want to achieve for my sleeve. Then after that's done, I bring it all back. And a lot of guys says, well, that seems like a lot of work. And it is. It is a lot of work. But here's why I do that. One, when you finish the rough bore in the block, you leave a lot of peaks. Obviously, we're not plateauing here. We're finishing up with a lot of peaks.
Yeah, we have bore marks. I mean, you are running a helix down that
Correct.
thing. You're spinning a tool and advancing
Correct.
down.
So
You've got a helix.
So what I'm after, for me, if I can get rid of that through my machine by honing it down, getting rid of all the peaks and getting everything knocked down, when I put the sleeve in, I get a better surface touch finish between the sleeve and the block, which creates a better heat transfer, especially in the diesels as hot as they run. I need the heat and the cooling system to do its job to remove the heat from the block. So by doing that,
and it's all that sleeve, all the heat has to go through that sleeve into whatever material you've got right there.
That is correct.
And that's absolutely. And I don't hate that at all. I love that because you're like, that's got to be the best way. And probably again, I think I'm really becoming a fan of these counterbore sleeves because that's going to be a lot easier to hone. If you got a little lip down there at the bottom, you're going to not be too nice to your stones. So.
Yeah, and we've actually had situations. I tell everybody, you get a lot of experience from failure. I hate to say that, but it's true. When guys tell you that they've had a problem, don't do that. It's because they've had that problem and it's burned them. I've been there. I've actually done this before where I tried to put the register in the bottom, it cracked, and I didn't know it cracked. Yeah. And I can tell you firsthand, when a sleeve walks out of a block and goes into a crankshaft, it's not a good day. So for us, we were like, what do we need to do to prevent this from happening, to almost pretty much rule that completely 100% out? Flanges up top. I'm opting for the flange up top now on anything I do if I can get away with it and I have the material to put it in.
Yeah.
Sometimes you don't, but to each their own, right? But again, that's one of the biggest reasons. And some guys are going to go, no, I've been doing it since the 80s.
No, it works.
It works. But I'm doing everything I can to bring a better product, use my Rottler equipment, bring a better product to my customer, and I have a little peace of mind knowing that I'm not dealing with issues with scoring and if the cylinder's getting hot and that piston grows a little too much because the heat transfer isn't correct. That's going to come back on me, and I'm just trying to eliminate that.
Well, I like, and you hit on it earlier, you're putting 1.5 thou of press. That ain't much. Now, on something with that much surface area, that's a lot of contact area, especially if you have a plateaued finish and you have that opportunity.
Correct.
With
I'm plowing through the block with a bunch of RVK with the sleeve. When that's removed, I don't have to do that.
You're going to get a much better, it's there, and you're going to have, like I said, the contact's better. You're able to control that. And like you said, why, when you have a failure like that, why risk it again?
Sure.
With the price of these blocks, with the time, the energy, the effort that goes into these.
This stuff isn't cheap. It
isn't cheap, and
it's very expensive work.
Pretty complex, and they are a little tricky with some things.
Oh yeah.
A lot of pressure in those cylinders. So. Yeah. Absolutely. Well, let's see. Anything else? We've talked on a lot. My biggest thing, and I'd like to end this with, always just a quick little tip on sleeves. My biggest is always, beyond the fixturing and holding these things with the Rottler, these 4th axes, these.
Well, I've got a little tip.
Simple.
I've got a little tip. Don't be afraid of liquid nitrogen or dry ice. They're your best friend.
You know what? I'm a fan of that as well, and a lot of people go, I'm afraid, but doesn't that
nothing better than taking a sleeve and just go right in.
Put a welding glove in.
Yes. You put something 300 degrees below zero, and it seems to go in pretty nice and pretty easy. I see guys pounding them in with sledgehammers and.
I've done it with the aluminum and the dead blows, but I found that, and I do them personally, or when we do them for testing, you go to the welding supply store and for $60 for the Duar for the day to do 8 sleeves or whatever, and you can, get a delivery. But that would be my tip.
That'd be my tip of the day.
Don't be afraid of it. There's nothing. It's not doing any harm to this thing, and
not at all.
The stuff's not as dangerous as you think.
No, and it's your friend. It's your friend when it comes time to put sleeves in.
Well, hey, Matt, I really appreciate it. Learned a bunch about sleeving. Hope you guys did too. Check this guy out. And
check us out. MSH Machine Works.
You got it.
And we're back with another round table. Matt and Ryan out of the shop and into the studio, of course. Lake is back. We've got Dave Bullock from Wilkins Racing Engines. Got a great history with you. And Scott Rowe from Rottler spent a lot of time with me at the NHRA this year.
We did a bit. We did.
Little of some of those Total Seal Trackside Tech Talks. And had a lot of fun, educated a lot of racers about machining and ring seal, but now we guys are putting you to the test here in another round table. So we just saw them out in the shop and going to take that conversation a little bit further.
Absolutely. So a little bit of follow-up. So with that engine, obviously, what were the main things you guys were trying to fix there?
I think we was correcting the sleeves inside in the block, talking about installing sleeves and the importance of like a flange style sleeve instead of the traditional style.
Mm-hmm.
The material in that particular block is so thin that when you bore it to sleeve it, lots of times pressing it, or traditionally guys will pound them in like with a hammer or something, it'll bust the bottom of the block out. So we go with the top side flange. To me, it's just a better, it's a better fix and design, and does a lot better than taking a chance on breaking the bottom of a block.
You don't want to do that. He knows that.
I know.
I know all that too well.
And we was also touching base on. Well, we do it a little different too.
I mean, sleeving applications run all over the place and different applications, and the main was, and I was learning from you, and it was using that top flange, and you go, mentally we were talking, and I go, wow, that's a great idea, because normally you leave, a 1/4 inch ledge down there, and it's 80 or 100 thousandths thick, and that's it. And you, like I said, you pound them in, and we had a nice conversation about thinking about from the perspective of the sleeve, and if I'm the sleeve and I'm going in there, and how much contact area. It's something that Lake and Scott, with you guys, because you're always working in that hone world, and that's all we care about. It's surface finish, and we're thinking about heat transfer, and we're thinking about what that surface really looks like, and how it's interacting with these different pieces. And the conversation of what type of sleeve you use, how much contact you're having, and how do you install it. Like I said, pounding it down when you have a block that has a weak spot or is going to, crack on you. Can you do a top flange? Do you use liquid nitrogen?
Yep.
What's your install? Are you dry ice? Are you heating the block? There's all these different things. So putting some, real world experience, and then having a discussion about the science behind that.
And something that we took at my shop personally, we took a notebook out of Chuck Lynch's deal, because I got it from Chuck. Obviously, I'm a young machinist and I love what I do. We don't do the traditional pounding it in no more. We take it out of our Rottler F69, we go into our CNC hone, we hone it to press, then we press it in that way, because as me and Chuck was talking, you know, when you rough bore something, you leave so much rough area like on your RPK that your surface finish is just like the Rocky Mountain. When we bring that back down through honing and we press, we now have more surface area, so our heat transfer is going to be better. Even though guys will argue and say, well, I've been doing it that way for 50 years. I get that. But with ring technology, the type of material, with CGI blocks, it goes on and on. I want to know that I can bring the best quality and the best job that I can to my customer by doing it. Even if it takes a little longer in the shop, my price is going to reflect that as well. Because I got customers that's willing to pay me more because I'm giving them more, if that makes sense.
To me, that goes back to what we talked about earlier in the show. There's a difference between what works and what's better. I mean, there's stuff that will work, but there are ways that are better than just what works. And man, that's a great point about taking that hone or that board finish, which is incredibly
it's rough.
Yeah. There's nowhere near as much surface area to transfer the heat and all that. And I feel like this whole sleeving thing is just going to expand more and more. It's so hard to get blocks these days that now re-sleeving a block to make sure it's not too thin, because now when you get to, you can bore it more, but now you run into problems in terms of
support.
Yeah, so being able to come back in, if everything else is fine on that block, but man, I really need more support because I'm going to put more boost to it or whatever, the best option could be to sleeve it. And now you got to think about all these things.
I think there's another great point to touch on with that, like too, and you know, for Scott and I working out at Rottler with the application stuff, and that's anytime we have a customer or a project, we go, well, what's the application, right? That's why we do what we do.
Yep.
And with sleeving, it's not, I mean, it's thin, you know, what do you got, what's your material, you're replacing, but think about still the things, you know, I think the things you can do with sleeves, you have an opportunity that you can play with different materials of your sleeve, and that may be a benefit depending on your application. And you have something now that you can change that entire cylinder and the material properties behind it, that you're not going to get that with just a standard cast V8 block.
Yeah, but I'll add something even to what you're saying, which this is like I love Rottler to death, and I love their equipment. With David yesterday, he was showing me some tricks on the F69, which was just it was elementary to him, but it was really great for me, right? Because I'm just trying to soak this in like a sponge. But you know where else sleeving comes in handy? Is when we're blueprinting a block. We seen this yesterday. We're blueprinting a block, and we're probing and we're looking and we're seeing what the probe on the machine's telling us we're measuring versus what the blueprint says it should be, right? Well, we might not can clean that up on a 10 over. There's in some cases, some of these blocks are worn to the point that they're 20 or 30. Well, wouldn't it be nice to go back in, put a sleeve in, get our geometry put back where it needs to be from a blueprint standpoint? So now our piston side load, everything that's happening to this engine is where it was supposed to be to begin with. So sleeves have their place, in my opinion, more than just a damaged cylinder. That's the first thing we think, we'll sleeve it, we'll fix it. But what about when we're blueprinting blocks? And we don't have the material, so we have to go off of its probe now. And to me, that's a game changer at our shop, because that's what Rottler has allowed us to do that we otherwise, you know, we have an old F4 born bar. Well, we talked about that yesterday, me and Dave. Well, what do you do to trick it? Well, you put a filler gauge there and you offset that. And that's cool and dandy, and it's worked for years. But you can't beat the luxury of the CNC and what it can do for you in a timely manner. We talked about boring lifter bores. A 2-day job on the mill with a BHJ fixture versus a 3-hour, 4-hour job with Rottler. Come on, man. I mean, it's awesome, you know.
Well, that's the thing that I feel like is revolutionary. It's not a machine that's just making chips. It's a measuring tool as well.
That's right.
Exactly, yeah.
I mean, the luxury is that you can measure your block in the same machine that you're going to actually machine in. And I mean, we found out with Joe's block yesterday that there was some of the locations were at the limits of manufacturing tolerance, and we were able to correct them by going with oversized lifters, and today we're doing the cam tunnels, and so that allows us to correct that. And that's the thing. In the past, you didn't know that it was off. You were just following the existing holes, and now today with the technology, some Rottler equipment, in just a matter of minutes, you can go from measuring, make a decision, to correct it, and actually making chips all in one machine. And literally in minutes, you know where you're at.
And we talked about that too. The difference between that is it may be subtle changes, but if the geometry of the camshaft is off, your valve events are off.
Yep.
Well, when you correct those valve events, that may be 25 more horsepower against your competitor just from doing something different. And that may be irrelevant to some people, but there's a lot of people it's not.
Well, it goes back to what Billy was saying in the earlier roundtable. Norris Marshall, a perfect example, that when they were building engines that were just reman, they were taking existing blocks. They had a X number of failures, flat tappet camshafts they had to deal with. And they would do all these things to try to fix it. Once they started machining their own blocks from poured, zero. Eliminated it. Because now that variable, I know over all the years of NASCAR racing, how many times people just shrug their shoulders, oh, it's a ghost of the machine, that's a bad block, it's a bad whatever. And I guarantee you, it wasn't
right. It
wasn't bad. It was something in the measurement of it.
That's right. Mm-hmm. That's exactly right.
Yep.
Because, I mean, like in the past, I mean, every engine shop tried to make each engine the same. They used the same parts and the same preparation, but one was always better than the other, or one was not as good as all the rest. And like you said, they'd go, well, just bad block or bad heads or something like that. And it probably boiled down to something was out of place. Some of the locations were out and nobody picked up on it.
That's right. So that's the great ability. Today we have the ability to measure things that we could never measure before. And one of those things we can measure really easy now is blow-by using a blow-by meter.
Well, Lake, it's hard to have a dyno session with a ring guy.
Yeah, I know.
Without talking about blow-by.
My favorite topic, or actually it's like my least favorite topic. I hate blow-by. Blow-by is the enemy.
It's really like you did all this work to get stuff to happen in the cylinder and then you throw it all away.
Yeah. Because the other thing is, it makes your piston rings look bad if you have high blow-by.
Yeah, that's
true. But it also
True.
kills your oil. And I love oil.
That's double whammy.
It is. It hurts. So you got to measure blow-by. If you're going to do a dyno session, you got to be measuring blow-by.
So how do you measure it?
So what we've been doing it for a long time, it's a very affordable one, is to use one of these. This is from Dwyer. It's like $100. And it's a little analog. It's got a little ball thing right here. Right? Check it out. So, literally, just the engine's had blow-by, right? There's gas, air getting by the rings.
Yep.
So look.
It's like the right stuff. When you're getting ready to go out of outer space, you had to see how hard you can breathe in there.
But it's kind of cool. Think about this, all right? For scale, this is in CFM, right? So this is up to 10 CFM at the very top.
Yep.
Let's see if I can peg it real quick.
Oh, easily.
I'm John Glenn. Here you go.
I mean, those things work great. We've been using those for years and years.
Yep.
They're trouble-free. You literally just plumb it onto your valve cover and watch how high the ball goes. Like, really nothing to it. Now,
the only trick is it can get kind of smoky in there, so sometimes it's kind of hard to see the ball.
You get some oil vapor and stuff like that.
Yeah, it can happen.
So we got a little more modern approach now with the JTEC meter. So it's really the same thing. We got like a flow tube over here, just like your mass airflow sensor on your car you drive, and it just spits out a number over here. So now we can sort of plumb this thing up, hang it in our window right there, and rather than look at the ball and kind of go, it was about, what did you see? What did you see? You know, now it's just a number in CFM of blow-by. Take a brand new engine, you take a worn out engine, race engine, start making your database of how much blow-by there is. So this is 100% stock internally, Ford 7.3 liter Godzilla.
All right.
And we ran this thing and we saw what, about 3-ish?
Yeah, right, about 3 CFM, yeah.
Yeah, between 2.7 and maybe 3.2, depending on what RPM. And that's pretty darn good, actually.
Right, I thought it was excellent, actually.
I know a lot of guys with race engines that would love to have 3 CFM of blow-by. So, you know, that factory engine works real good. Now, of course, if we started doing other stuff with it, turbos, boost, nitrous, lots of RPM, those rings are pretty big and heavy, you know, we would obviously expect to see more. But we have some old school ways that are reliable, and we have some new school high-tech ways. However you measure it, as long as you're paying attention to it, you can start building a database and know what changes I made to the engine affected my blow-by in what ways.
So one of the things I want to do with the Engine Performance Expo LS engine is because we can run it NA and boosted.
Yeah, that's super
I really
cool.
want to see what it is NA, what it is boosted, and then see if there's anything we can do with the hone or anything else to bring down those blow-by numbers when it's on boost.
I mean, really, that's what we use those tools for. We got to measure it. You know, we say we got to measure it so we can manage it, and that way we can manipulate it. So,
exactly.
You know, I say we make some more runs and see what kind of numbers we get.
Exactly.
I'm on timeout.
Yes, sir. I'm good. Okay, we're back. So, you know, I gotta love hanging out with Ben, you know, and I get tools, as you guys both know.
Yeah.
If you hand me a tool to measure something, bad things are gonna ensue. Or good things, I don't know. It's good, bad, depending upon your perspective.
Yeah, relativity. Yeah.
Relativity, yes, yeah.
It's good in my world. Anytime, you know, he sees something, that's exciting, man.
Well, we've always talked about, you know, if you don't have a measurement, what do you have?
A guess.
Right. Those are the only two options in this digital. It's measured or it's guessed.
Yep.
1 or 0.
It's so interesting already. It seems like it's a recurring theme today that there's all these variations that people have just kind of shrugged off, this bad parts and stuff. And you know, at PRI, you led a wonderful talk and panel that I got to watch, talking about these sisters of surface finish. Because again, surface finish, it's a huge thing. And you may have been noticing that these are up on the table.
Yeah.
They've been hiding them in plain sight all day for a reason. So let's talk about surface finish and the realities of that. Surface finish by itself isn't the only thing that we need to really think about when we think about surfaces.
Yeah, there, you know, and you know, like many things, plagiarism may be the sincerest form of flattery from the ignorant. So I've plagiarized this man more times, you know, and I try to give Mark credit every time I do. But he came up with the idea. He talked about the two sisters, that there's form and finish. You know, that it's the contour and the roughness. You've got both the macro and the micro working together. And then I just brought one of the sisters that I deal with a lot, which is the metallurgy.
That's the ugly stepsister.
There are times when she can be a prom queen, and there's a time that she's a snuff queen. You know, and there's, you know,
But that's why I need guys like you
right,
to manage her.
Right. You know, and she can be made ugly. You can take a prom queen and make her real ugly with improper tooling. In manufacturing, there's a lot of different ways you can hurt a surface. You know, we talked about in our presentation at PRI, you know, about how to improve surface, you know, surface
metallurgy, not metrology, metallurgy, in ways that you can hurt it. You know, improving it might be things like shot peening, it might be nitriding, it might be rolling, ways to add compressive stresses. There's also ways to hurt the stepsister. You can grinder burn, you can have rust, you can have hydrogen embrittlement.
Yes.
You know, these things that we deal with my clients all the time is how do we improve surfaces, yet how do we not hurt surfaces?
Because you can very easily hurt that surface, like you mentioned, in the manufacturing process inadvertently.
Right.
And that's where you don't even know you did it because the top is still the same.
Or if you check it, you only hurt it so, like if you look at this, these mountains and valleys of any surface, you know, and I don't know how well the camera can pick it up, but these are just, this is like a topo map. Well, just because you hurt it, you may not only hurt it down just a few millionths into the surface. And when you check it, usually you look past there. So you go in here and you look way down here and like, well, I didn't hurt it. Well, yeah, all your hurt damage is right there at the surface level in the first few microns, the first few millionths of an inch.
And that hurt you're talking about, though, might be below that skin that we measure with a stylus for roughness.
Right.
It's just lurking.
Yeah, that was one of the slides I showed that showed, you know, hey, we're talking about something hurting that's, you know, half a thousandths deep.
Right.
But, you know, when you do a Rockwell C poke, it's going 4 thousandths into the surface, 3-4 thousandths deep.
Yeah, 4 thousandths.
Right. So you've blown through the damage area. And, you know, it was interesting because, I talked to somebody who's basically, they have F1 level metallurgist.
Right.
And they're looking at, and they had a camshaft, they saw some small cracks in it. And the metallurgist is like, well, this wasn't properly tempered. And I went, it wasn't properly tempered. Yes, it was heat treated, but not properly tempered. And they said it in a British accent, of course.
Makes it carry more weight.
Sounded much better than my little, now me and my redneck accent said, well, would you check someplace else on the camshaft that wasn't ground? And they're like, well, okay. And they did, and they come back. I said, well, was that properly tempered? My pinky up. And they went, well, oddly it was. And I said, perchance could you tell me how?
Perchance.
Could you tell me how this part of the camshaft was properly tempered and this part wasn't properly tempered?
In the same tempering oven.
Right, it's hung in a tempering oven. It's, I think it's 1 hour for each inch of thickness, that was tempered, so how did, perhaps, would we like to rethink this? And so you go back between the Bubba and and it's like, well, what happened is they heat treated, in the grinder, as it created the friction, it took that very top layer and got it hot. But as soon as the grinding wheel left, here comes this stream of coolant that quenched it. It was actually reheat treated unintentionally as part of the grind process. And that reheat treated part didn't get tempered. So that's how you get a temper different on one part of the cam. So the metallurgist was 100% correct. At that microscopic level, less than a millimeter by, like these squares are 1 millimeter by 1 millimeter. So 40 thousandths by 40 thousandths by 40 thousandths. That this little piece, it got brought up to a high enough temperature to transform, and then frozen and never got tempered. But globally, it was fine. It was just very locally, it had that issue.
Well, I think that's the key thing here is that you've seen this for a long time, and you even longer, that all these failures that we see at a macro level all began at a microscopic, really atomic level, is where it begins. That we really boil it down, that's what it is. So just from, perspective, Billy just said, Mark, explain what these little fun toys are, because these are my favorite. I know everything's my favorite, but these are like my most favorite.
New most favorite.
Yes.
Until we come up with something next year that's new.
Yeah, this is like one of my kids when they're in high school with the new girlfriend. This is my new most favorite girlfriend.
These are my new most favorite girlfriends. Sorry to my wife who's probably not watching. So these are actual real surfaces blown up. So we have 3D microscopy. It's a 3D microscope. It's like our stylus gauge, only
like this.
It's like this, only it's done with a lens. And
it's 3D versus 2D.
3D versus 2D. This is 1 millimeter. in terms of area. Take a pen and make a dot on your piece of paper. That's about the size we're looking at. Now, to show some roughness, we scaled everything up and then scaled the height like 20 times more, just so we can see the actual surface texture differences. The surfaces we're producing aren't quite as steep, but the features are all there.
Right.
So this makes them a little steeper, but it gives us the ability to play. These 6 samples in front of us, though, every one of those is in production right now in an engine somewhere.
Right.
These are all real surfaces. We have a standard plateau honed, we have a Nicosil honed, we've got a extremely plateaued. This height difference, if you notice, this one is much taller than the others. All of these samples have a 4mm base when we 3D printed them. So that's saying that there's 4mm of plastic. Everything else is surface texture. This plasma surface has some wicked deep pores compared to this plateaued surface and the valleys. So that thickness difference is really a texture difference.
Yeah.
So these are the kinds of texture variations we see in the world, and this is where there's no one size fits all. Billy and I were just talking on the way in about what does my engine want?
Well, we talked about, Ben came up with something just off the cuff, that he said it's product, not process.
Oh, yes.
Exactly.
Yes.
And that was like, that's trademark Ben Strader, but I'm going to steal that 100%. And within 1 year, that is a Billy statement, not a Ben statement, okay?
Probably so.
I'm stealing it. We played with it, we called it, we talked about a different one. It was the R one, recipe versus result.
Yes. So what is that resulting surface? But we can extend your and Ben's language even farther. We've got, a million different processes that could produce this.
Right.
You rough hone it and then 2 different grades of fine hone and a brush or whatever to get a geometry. We don't know what geometry you're going to want until you put it in an application with a ring, with lube, with a duty cycle. This shape may be great for one application, but we need a totally different shape somewhere else.
Right, because the width of the ring, the result, not the recipe.
Exactly, that's where I'm going.
Yeah, and we were having such fun out. If y'all had caught us out in the hall, we were laughing because here, me being a redneck geek, bring up Holy Grail.
You know where he's going with this, right?
Open up the Book of Armaments, chapter 6, page 263.
Yes.
Begin reading for me, brother.
It's like the holy hand grenade for those of you playing along.
The holy hand grenade, that they had a recipe, that the number that thou shalt count shall be 3.
Yes.
The number shall not be 2, except to count to 3. Shall not be 4, and 5's right out. And the whole thing is, you wind up having these religious ways of doing surface finish. It's a religious recipe.
Right.
Thou shalt do this.
Yes.
And think about it. Why did they need the Book of Armaments? Well, they didn't understand how a hand grenade worked.
Right.
Yes.
So you had to follow the recipe, and the recipe worked. Then you pass it on because that recipe works, but all of a sudden you start changing things.
Yes. Or things degrade.
Right.
So it's like, I'm going to do this many strokes with a base hone, get my size, and then add a plateau stone to it for this many strokes.
Yep.
Well, what happens when one of them loads up? That wasn't in my recipe. I don't account for that.
No.
What happens when the machine wears? I start introducing some wobble, some roundness. That's not in the recipe.
The block changes.
The block changes.
Yeah, there's more. There's different carbides in there.
Absolutely. Or the matrix of the stone changed and we didn't know it.
Yeah. Oh, yeah.
That recipe didn't control it.
Right.
But the result, we'll get it.
Right. And it's, and you can see that while these results, like this result and this result, looks dramatically different.
Yeah.
But honestly, you think about these deep grooves here.
Yes.
And these, voids here. They're both there to hold oil, and they both do a tremendous job of doing that.
Right.
So the result may be even more so, what do you really want the hone? It's not what's the hone, it's what do you want the hone to do and why.
Right. What's the function?
Right.
Yes.
Yep. I think back to earlier when Brian was on talking about with the DI engine and how much efficiency they lost by going to methanol on port injection versus DI was because, well, we're putting more fuel in the port. So it's like, what are we trying to do? What's the goal? Because I may need more void, more valley to hold more oil if I'm running a fuel that is going to be more liquid in form when it comes into the cylinder versus one that is already vaporized because it's a gas like hydrogen.
Exactly.
I don't need that. I need something different. Because all I need is just a little bit of lube. I don't need as much seal from that perspective because I don't have as much fuel working against my seal.
And you really have to think about things as a whole system too, because you go to this DI versus port injection stuff like that. I guarantee you, if we took one of Ron Shaver's or Andy Durham's 700, 800, 900 horsepower engines, they don't make any 700s, but take one of their 900 horsepower motors, it's not going to be 80 horsepower improved going to DI. Why? Because they've sized the port to have that fuel in there.
Right.
And now it's not such a big deal. But when you're limited with port size, like it would be with the LT, it was designed for a 400 or 500 horsepower motor. When you're trying to make 800 horsepower to that same architecture, every bit of cross-sectional area is like you're borrowing, and steal for it, and every fuel molecule takes up what you don't have.
Right.
You take we take Ron or Andy, they have that RY45.
Yes.
And that architecture will support 1,000 horsepower.
Easy.
So it's not hurting it to have some fuel in there.
Right.
So it's a real deal that can almost make your head spin. So if you thought recipe is DI makes more power, and then you went over here and you went, well, hold on, that didn't work over
My
here.
results are different than this guy's.
Yes.
Right.
Yeah. My mileage may vary.
Your mileage will vary, period. Let's just take it out there. But I think that's been a challenge. We're in a realm right now where it's kind of a cusp of knowledge about surfaces and materials, and the sisters working together. People are getting tools in their hands that can see these things, and they're asking the question, what should my surface be?
Right.
And honestly, a surface is part of a big system, and there is no recipe. And I'm going to pick on Total Seal.
Sure.
You guys have helped people get into the box really well with some guidance.
Yes.
Now we're improving beyond the resolution of your box.
Yes.
And to direct people where to go from there is tricky because every engine's different now.
Oh, so true. So true.
In the world of, let's say, cylinder bores, we've got RK, RPK, RVK. That gets us in a box. But there's a lot of performance variation in that box now that we're seeing that we can improve on.
Oh, perfect example. Think about this summer when you were out at Shaver's with Ron and Don, and we had looked at, okay, here's how we've been honing, which has been successful, which generates plenty of valley. But now we could take that same block and go over to Brad Lagman and have Brad hone it and change that valley even more.
Right.
Change that texture.
Yes.
And now we pick up 4 inches of vacuum.
Yeah.
We didn't change anything else in the engine. All we just changed was the surface texture.
Right. So we're getting better resolution now. We're resolving the surface and seeing real, legit changes.
Yes.
That's awesome. And I think, our first time I met Billy was on, camshafts and surface texture and geometry. And seeing and controlling a shape differently is huge. But there's not an easy number for this. We've got to get people using their eyeballs, right?
Well, one of the things is to start asking questions. The asking good questions. We talked about this, whether it's on wear or whether this is on ring seal or whatever. Like if you go to Oak Ridge, you talked about them earlier today, and they're going to measure wear resistance. They'll do a classic cross-cylinder wear test where they put 2 and they just rub them on each other. And the reason you take one rod and rub on this other rod, one rod spinning, one rod stationary, and they measure the mass change, and that's how they figure out the wear resistance.
Yep.
Because they can measure the mass extremely accurately. So, they use that to kind of tell by finding out, see what it actually does. The thing is that sometimes even when you've got 1,000 PhDs like you talked, you have to tell by finding out. You have to do some testing. Well, if you're trying to do something like what we did on camshafts, we looked at camshafts that had failed. We looked at camshafts that had gone a long time without failing. Ones that failed early, what did their surface contour look like?
Yes.
Ones that didn't. So you start measuring, you start getting, and the thing is that you realize that these engines can solve Schrodinger's equation really quickly compared to me. They know what's going on with their forces. They know what's happening. And so you ask it, what did you like? What did you not like? And the same thing with like we talked about there with the rings.
Yeah.
When you guys walk into a customer's place and they're going, what finish do I want? The right answer would be, well, show me your best engine and show me your best short block, show me your worst short block, and show me in between. And let's see what characterized these differently. Yeah. And then how do we move toward everything toward the best, and how do we see what it liked, and maybe it likes a little more of that.
Absolutely.
So when we talk about that though, and let's bring it back to kind of surface geometry and metallurgy, is what an engine likes isn't going to be boiled down to a number.
Right.
No.
You know, that number, that surface was tempered. Well, you got a number for hardness.
Yeah, it was 62 Rockwell.
But is it everywhere?
No.
And what is the distribution? Is it hard on the edges and soft in the middle? And everything we're dealing with right now that makes this difference doesn't reduce itself to a number like a diameter. We're in a realm where we're actually getting to be creative. We're getting a little craftsmanship in the game, but we have to understand it's not when this number is high, my parts are bad, and when this number is low, my parts are good. There's more to it to get that last 5% out of systems.
Well, back to the other sisters, because I think while this is amazing and wonderful and we love it and it's so critically important, these tools are amazing for measuring it.
Yep.
This is what there's way more of these out there than I think of these so far in shops, and you can measure a surface and have the right numbers. It can look correct.
Right.
But I've seen complete utter failure of that surface. This part's right. The numbers are good. Even the picture is good. But when you begin to look at it, you can now begin to see these, we'll call it microscopic deviations in form or geometry.
Defects of some sort. Yes.
So we have a whiteboard. So why don't we move over to the whiteboard?
Let's do it. My favorite part of the day.
Yeah, so I know you're the best at drawing these things.
by
so we're
far.
gonna let you do. I'll stand over here with Billy. We'll let you draw. So why don't you just kind of draw out quickly? Okay, we've got roughness.
Yes.
But then we've got waviness, and then we'll bring in Billy to talk about the actual
contour.
Contour. But I was thinking about the metallurgy.
Oh, sure.
We start really thinking about those potholes in Michigan in January. How do they form?
Yeah.
Right.
Absolutely. Go for it.
So the great analogy I had is when I was interested in road texture. I was driving down the road and I couldn't hear the radio. I thought, I'm going to start figuring out this road roughness thing. So road roughness in my mind was the aggregate and the concrete or whatever I'm driving on. And it's this fine stuff in the road until I Googled it. I was Googling road roughness because I'm a slimy salesman. I'm going to sell, analysis tools.
Yeah.
When I looked at road roughness, everything they were talking about was speed bumps. The suspension industry owns the word roughness in roads, and they call that stuff roughness. Wait a minute. That's roughness in one realm. This is roughness in another realm. Well, let's talk about a crankshaft. Crankshaft, you grind it.
Yep.
You may go in and tape lap it. The tape can flex along the way, by the way, and introduce waves. And when you pull one out of an engine, you see stripes. That's not roughness. I've had people say my worn out surface has stripes all over it. I got a roughness problem. No, you don't. You have a waviness problem. So the world of surfaces is a world of wavelengths. And we're going to call some of them roughness. We're going to call some of them waviness. Maybe there's some underlying geometry that we'll call. Now, in the standard language, we call this roughness, waviness, and form. Now, sometimes form is intentional. We want to put some relief in, and that's where you guys are kings of this. So I'll hand that to Billy when we talk about intentional form.
Right.
But this is a form error, if you will, a straightness problem. This gauge over here, the skidded roughness gauge, only sees this stuff.
Right. Let's make sure we focus on that for a second.
Yeah.
This thing's wonderful.
Roughness. It's
but
a roughness
it does
gauge.
this.
Yes.
It doesn't do this.
So if you see stripes on a part, you pull something out of an engine, you look at a bearing on a crankshaft, bearing on a camshaft. If you can see stripes that are 40 thousandths apart, that's waviness. You don't have a roughness problem. You've got to start looking deeper. By the way, waviness problems are why we have noise with gears. Waviness problems are why gaskets don't seal.
Yeah.
We spend a lot of time in roughness because it matters, especially to tribologists.
Yep.
But this is where some of our big failures live. So some systems can tolerate this. Crank bushing can bend and follow some form, but it can't bend for this. Think of our surface like a symphony. We've got high notes and low notes. We need to control the ones that matter to whatever you're working on. So that's our spectrum. We call this roughness, we call this waviness, and we would call this kind of form error. We can do intentional things with form to make things better, though. If you want to.
Yeah, I'll give it a shot.
Please, go for it.
I'll give a shot at it here. I'm going to try a little red one up here for
All right, it's going to get a little red now.
This is the roller wheel right here. And people look at a roller wheel, so the axle's up here. Here's just the face of it. So, and this thing actually is made with a little bit of crown on it. So it's a radius over here. Now when you take your camshaft surface, it's a mountain range. And what you would see is you put higher loads on these peaks here. That these loads, and what a failure is, failure by definition, is when the applied force is greater than the material strength.
Repeat that one more time, please.
Whenever the applied force onto any microscopic piece of steel or any other material is greater than its material strength,
Yes.
it by definition fails.
So what I think is interesting there is you come out of engineering school and you've done tensile tests and you've done compression tests and stuff, and people think of that macro. They think I'm going to load this with several tons. What you're saying is that applies micro.
Right, it applies down here at the atomic level. It is at the iron lattice level.
Yes.
When the applied force is greater than material strength, this lattice breaks, and then that crack propagates, and we'll get to there. So what people did goes, hey, look, these little peaks get more loaded in the valleys.
Yes.
We're going to polish this. Well, the problem is when they polished it, they wound up with something that wound up smoother, but kind of often wavy.
Yes.
Well, the problem with this is now when we apply this force, well, this guy over here is not seeing much. This isn't seeing much, but all of a sudden we put a lot of force here and here.
Yes.
On the tops of those waves. And this is where we wound up going, ooh, polishing, you can't fix something with polishing. And especially if you already had a bad contour to begin with, you get a worse contour. Now where the highest deal is this edge loading, because here on the edge of this track, here and here, you start putting things in tensile strength. You're actually trying, you've got force coming up here, force going down here.
Yes.
You're creating a shear plane, you're causing a lot of tensile there. That's why you see mostly edge failures on camshafts.
Well, let's pause there, because even if you had perfection, a perfectly square and flat surface into another perfectly flat surface.
Yep.
The stress contribution, or the stress concentration, does one of these things.
Yep.
Edges are going to load even in the world of perfection.
Oh, absolutely. And then you go in here, and this case depth is only so far deep.
Right.
And then all of a sudden this creates this crack in here, and then it comes out, and this throws a chunk out of it, just like a pothole on a road,
Right.
where you get a crack that starts subsurface, starts down in here,
Yes.
and then cracks and propagates around, then throws out and starts, what's called technically it's a spalling failure.
Yeah.
And that's what, not spalding like the ball, but spalling failure. And this spalling failure is what you see normally. These are the pits that you see come up. You'll see it on the nose of flat taps. If they're out of control, where they throw up and then crash down,
Yeah.
that bottom of that surface flexed, this put this part in tension at the bottom of the heat treat, crack there, and goes up from the bottom up.
But I think that's an interesting point when we start talking about geometry and form, is perfect isn't always perfect.
No.
We need to relieve those edges, because perfect is bad.
Right, so you look at what used to happen over time was that camshafts never were all that flat because the grinding wheels were relatively soft. And so when the grinding wheel was grinding the lobe, it would wear away and it create this convex shape on the lobe, which is actually very beneficial.
100%, yes.
When you went to CNCs with CBNs, they started to get really, really flat.
Yes.
And the problem is when you miss from flat, you wind up with what you call this bathtub shape. And what we found when we started doing investigations was if we ever had waviness, we failed here and here. If we ever had bathtub shapes, we failed here and here.
Exactly.
And it was a big exploration of what's going on. So instead, well, what do you do if you're failing there? Well, you grind it with that type of shape.
Yes.
Now the problem is when you have that type of shape against this type of shape, you know, enough is good, but too much, and then you start loading concentration here.
Yeah.
And if you
Goes
look at
other side,
if you look at like a GM camshaft, if you pull a you know, late 90s, early 2000s GM camshaft out of an LS type engine, Gen 3 engine, you'll see a stripe around the base circle. The track will be very, very narrow.
Crown on crown.
Well, why they have a crown on crown? If you don't load it, it doesn't spread out. And then the load is what spreads it out. So you look at the flank where it's more loaded, it spreads it out. When you know you've got the right geometry, in the highly loaded areas, it'll be narrower. You know, if you look at a camshaft lobe, and here, say that's a camshaft lobe, okay? And the
looks exactly
loaded,
like one, doesn't it?
yes,
Rick?
it does. Yeah.
So what you'd see is something that starts out kind of narrow, and then widens out, and then narrows out. And so the wear pattern should look kind of Coke bottle shaped, kind of like this. When it's really defined on the edges, it's not enough crown. When it's too narrow, it's low on the crown.
Well, I think what you're pointing out, Billy, is really interesting to many of the people in our audience, is they're not going to have an Adcoal machine or a skidless roughness gauge, and getting this idea of what does the shape tell me is going to be a big deal. Do I have tracks running down the edges? Well, what geometry causes that? How can I fix that in the process? Do I see stripes or not? Do I see an edge loaded or not? That being the forensic doctor looking at, you know, post-test is almost our better process control, because the tools to do this in process can be expensive for a lot of people.
Oh yeah.
Well, the other thing is, like, you can't go and mic this and see it either.
Exactly.
Because if you go in here, this crown, you know, it's, you know, on the order of like a 100-inch, 200-inch crown.
Yeah.
So you go in here, it's only half a thousandth drop on either side. So if you could possibly get over there and mic the very edge, then mic the center, then mic the edge, you might see it. But the problem is it's really hard to mic the very absolute edge.
Yeah.
So without something like a profilometer, and that's where you came in and helped us bring all this in.
Right.
But I guess there's just more to it. You know, and sometimes just knowing there's more to it is part of one of the big parts of the battle, right?
That's the whole point of having this segment.
Exactly.
Is, yeah, knowledge is power. Even knowing that it's there, to be able to even begin to say, okay, well, roughness is this. There is this thing called waviness, and there's form, and they are related, and that how they all factor in, so that now you have maybe a better calibrated eye for when you're looking at the used parts as they come out of the engine, because they're going to tell you this kind of story, so that you know what you're looking at, and you're not just having to speculate off of what somebody else may have said on the internet. You can actually look at it with a trained eye and say, okay, now I understand what I'm seeing.
And you know what the funny thing is about all of these issues that we've studied? If you get on the internet and you see a camshaft that's failed, they're going to say, oh, they bought some cheap steel out of Asia.
Right.
This has nothing to do with the steel of the setup. This doesn't have anything to do with, oh, the heat treat, oh, this. This is all about processing.
Yes.
You know, so you've got all of this going on, and then you go back to the whole deal of, you know, now what can we do with the heat treat afterwards? What can we do to hurt things? You know, somebody can go in there. Valve springs are notorious about this. I take out a box of failed springs and I see somebody's fingerprints and rust on them.
Yes.
Yeah.
Well, I know why it failed. It wasn't anything other than it rusted, because if you imagine this valve spring wire, you know, and say it's a 200 thousandths diameter wire. Well, all of the stress, and we're just going to play with, this is the ID, that's OD, the stress concentration's right in here. Just right on that ID. Well, they've gone in and done all this peening to drive this compressive stresses all into this setup. So they've gone in with little balls that came in here real fast and crushed down this surface. And
making it more dense.
And so what they did, if you imagine the iron lattice with all these little FEs.
That's not Fifi the French poodle.
No, this isn't Fifi, this is like iron. And what they do is when they hit it, they actually scooch these guys in toward each other and pack them in. And that's why...
Taking the iron atoms and just collapsing them
and
closer.
And if you ever heard somebody said, oh, how'd you test that? Well, I did an X-ray. I checked the hardness with the X-ray. Well, X-ray doesn't tell you how hard it is, not directly.
No.
It just tells you how close these iron atoms are to each other.
Yeah.
So that's what the diffraction of it is this. So you've got all of this stuff where you bounce it off, you compacted these iron closer together. Well, that's only about, just a few thousandths deep, maybe 10 thousandths if you're lucky. Well, you can go here, touch this, and if you've got the wrong pH, you can put an etch that goes down here below this. Then all of that's gone. And your safety net's gone, and it's going to break. People go, oh, well, you want me to just buy new rusted springs, to sell more springs. Dude, you're going to buy more springs.
Yes.
Did you have to buy a new cylinder head and piston and everything else because the spring rusted and then it ate a valve?
Yeah.
The spring's going to get bought. It's going to fail.
Right. Which is back to why rust protection is so incredibly important. That if today's world with oxygenated fuels, drag racing, that kind of stuff, you really have to be paying close attention. When you see rust on something, you have a problem that you really need to address because it can cause way more damage than you might think about.
And it's not just brush off the rust and I've got clean metal.
No,
because the damage is below what you're seeing.
Right, you've created that damage and you've gotten rid of anything that you've done positive to the surface, whether it's a connecting rod or whether it's a valve spring, it's gone.
Yes.
And if it's a crankshaft or a camshaft, that rust has gone in there and it's so big compared to all this that it's a monster.
And that's just talking about a spring.
Yes.
Which I know there's a lot of processing that goes into a spring because of how stressed it is.
Well, its mass is its own worst enemy. So people don't realize that probably more than 30% of the spring load isn't to control the valve, it's to control the coils of the spring. So people go, well, how much, I get a question at least once a week, how much spring load do I need? Well, I can't. If you had nitrogen springs and I knew everything about the cam, I could tell you. But really, the spring load, most of the spring load's there. That's why you see somebody with a little bitty spring that's got 600 pounds open and somebody with a 1/300 spring. Then you see a guy with a 1/650 spring that's got 750, 900 pounds open. Why does he have to have so much more overload? Well, it's to control the big, fat, heavy spring.
Wow.
The coils themselves, its own load is all it has to control that.
Yeah.
So as we kind of wrap up our surface module here, what I'm finding is interesting from my perspective is, I live in a geometry space, and you guys are living in a lubrication tribology space, material space. These are all married tightly. Almost every one of these things, though, doesn't reduce itself to look it up in a book.
No.
Where the books are there, but it's that experience, and it would be great to do a session like this of the Hall of Shame someday. Here's a part that got rusty and it destroyed it, or here's a part that we thought was perfect but the edge is loaded. And it's a case where to let people know that there's information hiding in that surface or in that engine that you're not going to be able to Google.
Right.
But don't be intimidated by it.
And the more you measure, the more measurements you take, the better you're going to get. You're going to increase your own tribal knowledge. You're going to understand your parts better. So measure, 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 measure.
Yeah, and I think I would probably, it says metrology right on my shirt, but I'm not going to go there. I would say explore. Because that, is this really measuring? I think it's exploring. And don't feel stupid. Feel like, an explorer. You're going somewhere no one has gone before. Nobody has looked at your part in the way you're looking at it. And be an explorer. Don't feel intimidated by it, right? There's a lot of weird settings in math and measuring systems. Don't be burdened by that. Dig in and look around.
Yep. So we talked about it. Measuring is super important and learning is super important, which is why we have another video coming up for you right now.
Okay, take one. This is Ed Keebler. I'm with Tony Bischoff and Darren Morgan at BES Racing Engines. This is going to be one of our segments for the EPE show coming up in January. So we just wanted to get these two guys and do a little discussions on head porting and some of the things that you guys do to make cylinder heads, perfect when they go out the door, right? They're perfect. Yes, exactly. So one of the things we did last year after EPE was we kind of talked to some of our viewers and asked them what they wanted to see in an educational video, and it was overwhelmingly skewed toward cylinder head stuff, either surfacing or guides or seats or porting or what have you. So we've got a list of questions here that a bunch of our viewers have turned in, and we're going to ask the two experts here some questions and get their answers. So one of the, we'll get started here and we'll get into this. So one of the first things that people ask is on seat rings, what kind of press do you all put in a cast iron head and an aluminum head? So when you're pressing in seat rings, what kind of interference fit do you all want for that?
Well, typically on cast iron, a good round number is 4,000 to 6,000 press. And if you go to aluminum, naturally we want to put 2 or 3 more on. So we go 6 to 10 typically on seat rings.
Okay.
That works pretty good for just about everything.
And it doesn't matter diameter-wise, right? Because we get customers asking, well, a smaller diameter, larger diameter.
We use that rule just about everywhere, but you could go a little bit less press on the, say, exhaust seat, but we don't, for the most part, we shoot for them numbers everywhere.
You shoot, okay. All right, all right. And what about when you're cutting for seat rings? There's always been this connotation out there, you know, you'll set up a stress riser where you've cut for the seat ring if you don't use a radius bit or a bit with a chamfer on it.
That is true.
What do you recommend, Darren?
Well, usually you're going to have on most of these cutters a 25 to 35 thousandths radius.
Okay.
And all the seat rings are radiused as well.
Right.
We go to painstaking efforts to make sure that radius is matched or bigger than the radius in the register itself at all times. That's all you really have to do. But yeah, it should have some radius there.
All right.
And yes, it will cause a stress riser. And then like really weak OEM cylinder heads, like let's say a CJ head, an iron. I mean, they don't have a lot of meat underneath there. So any stress riser is going to crack them right out.
Okay.
And also on something like that, that's a case where the press fit itself goes down to like 5, 6, no more than 6. I mean, we try to just get real close to that because, again, the stress in those weak heads can cause stress risers and crack them everywhere.
Crack them everywhere, especially if you get a guy that says, okay, 4 to 6 is good. I'll be safe and I'll go 8 to 10 in a cast iron head. And
yeah, you're playing with fire.
You're playing with fire.
You know, and the big thing you got to remember on factory heads, cast iron heads especially, the castings ain't very thick in the chamber. So some factory heads I won't even put a seat ring in because they crack too easy. So one thing I always try to remember is one, I don't go very big on the seat, so no more than 60 bigger than the valve. And a lot of times I won't put it but 200 deep because again, you go too deep, you get too close to the outside edge of your chamber, and then they bust that way too. So I can't say from a personal standpoint, most old cylinder heads anymore, restoration stuff, I recommend the customer, unless it has to have a seat put in it, I don't put seats in.
Don't put seats in.
I tell them to run lead additive because I've had too many unobtainium castings that crack, and then you're done. So,
right.
So on factory stuff, I try not to do seats. There's a few motors I know we can do it, and other ones I know we can't do it. There's a lot of Ford heads that you cannot put them in. So.
Okay, and then you just recommend lead additive.
Lead additive. You can run that once or twice, and then you're good for several thousand miles. And then you say you run it some lead additive every 10 tankfuls or 5 tankfuls or something. And that usually works okay.
Okay. Explain just a little bit for some of our viewers. Maybe they don't understand what the lead actually does.
The lead is lubricity.
Exactly. Yeah.
Yep. That keeps it from wearing out.
So I mean, you have two incompatible materials, steel and iron. The harder is always going to wear into the softer material. Well, the iron is much softer than steel. So without any lubricity there, it's just going to eat itself. It's just going to literally gall itself into the cylinder head.
Into the cylinder head. So that's the reason for the lead in the fuels at one time. We've taken all the lead out now. That's the reason that you have to put a hardened seat in, because the seat ends up being, the hardness of the seat is harder than the actual valve. Mm-hmm. And when you can't put seat rings in, then just add lead additive.
Yep.
Okay.
And that works good for restorations that don't get a lot of miles. Now, naturally, if you're going to put a couple 100,000 miles on it, you have to figure out how to put seats in it. But most people don't do that to their 1971 Cleveland or whatever. They're
Right,
working on, so.
right, right. Another question we had is when you get into what we call endurance motors, in other words, boat motors, okay? You know, these guys that with the twin or triple big blocks in them or what have you, and obviously very hard conditions or very rough conditions on a motor because you're at kind of full power the most of the whole time. Is there any differences when you're preparing a boat motor head or an endurance head? Just from a seat, installing seats or something like that, is there any difference there? Or?
Not really. I mean, you get particular in everything, but I do make sure we run higher grade exhaust valves. Definitely for sure higher temp exhaust valves in Canal, or they call them different stuff these days, but I try to put better exhaust valves in.
Okay. So
especially on the supercharged stuff. So.
And we'll run the seat width out to like 55.
Okay.
Yep.
We're on a something that has to make some power. You'll run them down to 30, 35,000.
Okay. And explain.
And they're going to get wider.
Yeah, that's right.
You know,
yeah, they're not going to get narrower.
It starts off as 30. It comes back as 50. So.
That's right. Explain to maybe some of the engine builders that are just getting into this business. What does seat width? What effect does that have on the valve itself, Darren?
On the valve itself?
Yes. Is it? I mean, you run a wider seat width on an exhaust valve versus an intake.
Its ability to dissipate heat in the combustion chamber.
Okay.
It goes up considerably, especially on an endurance application, supercharged application, something that's at constant throttle, like we were saying, a boat.
Yep.
Yeah. You need to have the higher grade valves because of the heat dissipation up through the guide and then into the seat area. So you need to give it that area.
So wider seats. If you were using a normal exhaust valve, what would your seat width be typically?
Well, say on a stock motor, sometimes you might make it 80 wide or something like that.
Okay.
The wider it is, the more heat it'll pull out of your valve.
Dissipates heat better.
The wider it is, the less it flows. So you want to, it depends on how long they're going to run it, stuff like that. Some of these boats, they might only put 200 hours on them, so sometimes still we don't go super wide on them. But it just depends on what the guy's planning on doing with
okay.
it. So.
All right. That's great information. Let's see. One of the other questions was, is it better to interlock seats in a head or not?
Yes, absolutely.
Interlock the seats.
Yeah. Of course, that's fraught with a lot of problems. One being let's say somebody has interlocked the seats to what we call max. In other words, they're not overlapped where one seat is into the next seat ring over.
Okay.
And this happens quite a bit when you install, the exhaust seat and then cut the intake seat into it, and then you'll see you're actually seating on part of the intake seat has exposed itself. And at that point, that's not proper. You need to put a smaller seat ring in there and get the intersect correct. But a lot of times what will happen is they've gone maxed where any increase in either seat ring is going to cause that problem. And at that point, you kind of have to make a judgment call. But sometimes we'll just have to weld the whole area up.
Really?
Yeah.
Okay. All right.
And some of the problems that he's talking about is created by people, head guys that like to get every bit of flow they can get, which makes power. That's why they do it. But sometimes you sacrifice durability with these big valves, especially in inline motors, because they're so close. Whereas a canted valve, you can get bigger seats because they separate them. But so when you pick valve sizes, you need to discuss or decide what kind of durability you're looking at. Some drag race motors, it don't make no difference. They're going to freshen them up every 30 runs anyway. But if they're wanting to get hundreds of runs or thousands of runs, then you got to run smaller valves so you can get away from that overlap so much.
So it's all about the application.
Absolutely, application.
Okay.
Application specific.
That should be that should be one of your first questions when a guy comes to you and says,
if you're class racing and somebody's beating your customer, you tell them you're going to get maintenance where we can make it better, but they have to realize that's going to create problems that's adds to more money and more maintenance.
Sure. Okay. All right. How about seat materials? You know, and again, I'm sure that's somewhat application specific also. But talk a little bit about seat materials that you all use in some of your applications.
I don't feel really qualified enough to answer that question, to tell you the truth.
If anybody
that's really a question for Claude at CHE, because he's the metallurgist.
He's the metallurgist?
He's the mad chemist that gives us all of our seat rings.
Okay.
But on the very basic level, copper versus iron versus hardened powdered metal.
Right.
Each has its individual use in case that you would use that.
Talk a little bit about that, would you, Darren?
Well, let's take, for instance, the powdered metal seats. I mean, those are only used in industrial applications. And very, very rarely will you see those in an aftermarket cylinder head. They're almost too hard. Well, they are too hard in many, many cases.
Okay.
Not always, but in many cases they are. And you also have to have the compatibility with the valve that you're going to be using. You wouldn't use a hardened powdered metal seat with a titanium valve because it'll completely destroy the titanium valve within 30, 40 runs. So we use bronze because, again, we go back to that the compatibility of the two metals, their hardnesses and lubricity. And basically that's what you're matching with all these different seats. But that's something that even I get on the phone, or they get on the phone too, and say, hey, Claude, what's the best seat for this application?
Okay.
You know, and before we were stuck with beryllium alloys.
Right.
You know, in pro stock and comp motors, that's all we had. But the metals today, I mean, some of the phosphorus bronze alloys he uses are far better than even those were.
Okay. All right. And you mentioned a little bit about titanium valves, and we're going to digress just a little bit because we'll get into some valve questions. But we talk about titanium, and it'll wear the titanium out. Are all titanium? Yeah, are all titanium valves now coated? Like DLC coated? No.
No, you have to request that.
Okay. All right. Do you all recommend that in a titanium valve?
It's situation dependent.
It's, like you said, on power outer stuff that you're going to eat a lot of stuff up, burn pistons, we never get them coated because it's very expensive, and when you have to grind a valve, you grind it off.
Right.
So endurance applications, there's no doubt the coated valve, the seats hold up better, the valves hold up better. They're almost phenomenal. So naturally aspirated combinations, that's not going to get a lot of valve jobs, and you want the seat to wear very well. I like the coating, but it is pretty pricey. But power outer stuff, I don't ever coat.
What is it now? $50 a valve?
You know, last time to do 8 of them is like $300. So yeah.
Okay.
Probably a little bit more than that. And that's constantly
And by
changing.
the way, titanium's compatible with nothing. No other metal. It's going to wear.
It's going to wear.
Yeah.
Yep.
And that's why you see all the NASCAR guys, they were the ones that got into the beryllium alloys and all those different copper, beryllium, aluminum, phosphorus, bronze alloys, trying to figure out a way to make those valves live a full race.
Okay.
So we owe all this stuff
to
started
the Cup guys?
Yeah.
Well, that's a good attaboy for the Cup guys. So we're talking a little bit now. We've got some questions on actual valve jobs. So it says, when cutting seats with a form tool, do you need to lap valves and seats afterwards? So
the answer to the question is, if you need to lap it afterwards, you didn't cut it right to begin with.
Okay.
So no, that you shouldn't have to lap a valve.
All right.
But people will go to extremes to try to hit some predefined concentricity and out of round. I mean, you can get away with 1.5. That's okay, and it's going to seat just fine. But nowadays, there's machines that we can get them down to 2/3/10.
Right.
But you can achieve, what I'm trying to get at is you can achieve good results on just about any machine. It's the time factor. How long does it take to achieve that result?
Okay.
So you just have to take your time. And also, it's not uncommon, and actually it's standard practice for me to do 2 valve jobs. And sometimes I'll have to do 3. Because what I'll do is I'll rough them out to 5/1000 high and then blend them in to get rid of a lot of the material that form cutter is cutting.
Okay.
Because if you're cutting too much material and your seat's not quite concentric, in other words, the back wall has more material, it'll try to push off of that area.
Sure.
And it destroys the concentricity.
Have the least resistance.
But if I can blend it all in and come back in and just touch it, it's right there.
Right there.
Yeah.
Okay. And you brought up a good point. you know, you get these guys, I know as an equipment manufacturer, we always tell customers a thousandths per inch is what?
Spec.
Yeah,
Yeah.
is spec. And are you comfortable with that? Are you comfortable with a thousandths per
Anything over
inch?
1 and I'm cringing.
You're cringing?
Yeah.
Okay, all right. So on a 2400, 2600 intake valve,
If it
you
was
want
1
to
and
see
a half, I would be.
You would be okay with that?
I would be okay with it.
But not happy?
No.
Okay, all right. So thousandths or less is what you're really looking
That's
for?
what you're always shooting for.
Okay, all right. Well,
That's
that
the
makes
target.
perfect sense, yeah.
And some heads,
Hard to do.
it's hard to do.
Let's see. So I guess to recap just a little bit, no need to lap valves. If you're lapping valves, all you're doing is really covering up poor machining.
Usually when I lap valves, I lap it to just the exhaust to see the seat because I have to blend up to it.
Okay.
That's my really only use for lapping valves.
So it's just to see where the seat's at.
Yeah.
All right.
And we vacuum check every single hole.
Sure.
So, I mean, you put that valve on there and you hit the vacuum, it should seal.
Right.
And if it doesn't, it's off.
Yeah.
It's just that simple.
Something else you have to remember, on a coated valve, you lap it one time, you just throw
Oh, yeah.
50 bucks away.
You ruined it,
just
didn't
ruined
you?
the valve.
Yeah.
It will take it right off, even though it'll run forever in the engine. You hit it with lapping compound, it's junk.
Yeah.
Not junk, just there's no
Yeah.
coating on it.
Yeah. Okay. All right. Let's see. Back cutting valves. Do you back cut both the intake and exhaust, or just one, or the other?
The exhaust is really not. It's just, we've done it back and forth. Have you ever seen a difference back cutting exhaust?
Well, I've seen it on the flow bench. You'll see how much it changes where it flows better. You might back cut it and it'll pick up flow at 300 and lose at 400 or something. It typically doesn't make a huge difference, but I mean, it's just what you play with on the flow bench, really. So.
And on the intake, it's mandatory.
It's mandatory.
Yeah.
Okay.
And the width and the angles that you use are situation dependent.
Okay.
It's
Well, those are
engine
some of the other
specific.
questions. So elaborate a little bit on those, because those are questions on the list here.
All you're trying to do with the back cuts is tune up the venturi section underneath the throat.
Okay.
Okay, so if you have an engine, a high-end engine that's got to turn 10, 11,000, you're pushing your throats out really, really big, and now you want as much back cut on the valve as you can. You want them wider. Now the problem is you made your valve too wide, or too heavy, so now you got to shrink those up. So you're constantly working with this size, area, weight relationship all the time in every single case. But basically what you want, and I always say the easiest 10 horsepower anybody will ever gain is just take a Manley 202 intake valve out of the box and back cut it equal width. 30 degrees back cut, 45 degree seat. And we did the test multiple times. It's always 8 to 10 horsepower.
No
it's just
kidding.
that simple.
That's
That's
just
how
by back
powerful it
cutting.
is. And what you're doing is you're tuning the flow curve up, down low. When the valve is close to the seat, all those back cuts form a venturi. If you don't have that, it's just a sharp ridge.
Okay.
And you'll see it immediately.
All right. Yeah, that makes perfect sense. So 8
And
to
on-
10 horsepower on a just kind of a stock motor with the 202 Manley valve in there. There's a 8 to 10 horsepower recommendation right there. So, and you cut it. I think I heard you say you cut it the same width as the intake, the seat itself.
For a 45 degree seat, yeah.
So if you have a
So
60
if it's
thousandths wide,
150 wide, make it shrink it up to where they're both the same width, whatever
okay,
that is.
whatever that is.
Yeah.
Okay.
And on 55 degree seats or 60 degree seats, we have 3 angles, 3 back cut angles.
3 back cut angles.
Yeah.
Okay. All right.
Because you're turning the air off of a 12 degree surface, you're trying to cut it 15 degrees.
Okay.
At a time.
At a time.
Yeah.
That's the most.
That's what you're trying to do.
Okay.
So you could mess with this angle and this angle and try to cut it 15 degrees at a time. That's basically what we're doing.
Okay. All right. And that brings up a point. When do you run? We've all used to the 45 degree seats, and then we went to 50 degree, and then you hear some 55s, and I heard you mention 60 degree intake seats. When? And I'm sure it's application specific.
Very.
but just kind of give an overview of when you would look at steeper seat angles.
General rule of thumb, the steeper the seat gets, the increase in wear of your valve goes and seats go way up quickly. So steeper seats are not used in anything else but drag racing
Okay.
Or maybe truck and tractor pulling. We don't even like to go really steep on those. But like unlimited comp stuff, yeah, they got 60-degree exhaust seats. Some of them have 58-degree intakes. But you know that you're going to freshen that engine up after 10 runs.
Okay.
So it's not a big deal. And that's about all they last.
All right. And you can get, and I hear people, well, you can't go too far because the valve sticks.
Yeah.
And you guys, I'm sure, being in the business that you're in, you have pushed those limits and figured out where they were at.
Yes.
So.
Something I'd like to add to the seat deal, to overly simplify it, there's two ways you got to look at it. The steeper the valve job, typically speaking, the more it helps at higher lifts, and it hurts your flow at lower lifts. Naturally, the seat width changes that too. So I always say, as a rule of thumb, if you ain't over 750 lift, there's no reason to go to 55.
Okay.
But I'll reiterate on something different after this, and say 55-degree seat, you need to go over 900 lift, or even like a 60-degree seat. But on the Engine Masters, we ran a 60-degree seat on our Engine Masters challenge, and it kind of wide, because that made that 0 to 100 lift, it was almost shut off. Now you run a different camshaft because we didn't want it to flow there.
Right.
Does that make sense? Does that make
Sure.
any sense to
Sure.
you? So we picked up a lot of low-end power by running a steeper seat. But we still had this high lift flow, so it made us a really broad torque curve. So that is a low endurance application, because it didn't last very long. But my point is where you want your cylinder head to flow at, that changes that a little bit, and that is application specific. But so it doesn't, that lift to steep valve angle rule doesn't apply to everything because of what I'm talking about there.
All right. You know, one of the things that I just keep hearing over and over and over is and I'll put myself way back, 40 some odd years ago. You're building your first street motor, or you want to go a little faster. The first thing you do is you put headers on it, and then you put a I'm really digging myself, a Holly carburetor on it,
They still
and then an aluminum intake manifold, and then you start getting into camshaft and cylinder heads and different things like that, and you start looking at magazines or getting on the internet or what have you, and this guy recommends these cylinder heads, and this guy recommends these pistons, and this guy recommends these valves, and you start buying this stuff thinking you're buying the best, when in reality it's probably furthest from the truth, because you're not buying what the application calls for. So you could have the best lower end motor on the street, but your cylinder heads suck, so you're not going anywhere.
Well, I mean, naturally you got to have the right combination
Right.
of parts.
But I mean, that's what I hear from you guys is it's so important to start at the ground level and ask all of these questions before you start investing money.
Where you want to make your power, how you want it to idle, that's the most important part. Getting the right cam for your RPM, right converter, right gear ratio, right intake manifold. It all needs, the difference in having a mediocre engine and a real good engine is critical to get the right parts.
The right combination.
And there's some false economy with that too. And a lot of people will think that they can buy an engine that makes lesser power for a lot less and then step it up later. And that doesn't work.
Doesn't work, does it?
It ends up costing more than if you just would have invested the money in the first place.
Way more.
Yep.
Way more.
Yeah.
Because you're throwing something that was good but not right away to just redo it all. Just decide what you want, and then have somebody that knows how to put the right parts together.
Yeah, it'd be like buying an engine block with a cast crank in it, because you're only going to make 400 horsepower, and then you put a set of heads and a cam and everything else on it.
Sells you a nitrous kit.
Yeah, and a nitrous kit, and suddenly, this crank's no good, the rods are no good, the pistons are no good. I got to start. And the block's no good, by the way.
Not strong
So yeah, it's okay. That makes perfect sense. Let's see if we can pick up here. You prefer thick seats for intake. When do you run some of the higher seat angles? We kind of talked about that. It said, do you run higher seat angles only on intake seats, which you guys have answered that.
On
No.
the head. It's proportional to lift more than anything
It's
else.
more about lift. Okay. All right. We get into a little bit of guide work now. It says guide clearances between valve, stem, and guide. What is there a naturally aspirated motor versus a power adder motor? They're different, and just as a rule of thumb, what do you guys look for as far as?
And this also it depends on some factors, like how much guide's sticking out into the exhaust stream.
Okay.
And how small how high is the gas speed over that guide, and the thickness of the stem, whether it's 5/16. So for a power adder application, you would run probably another thousandths more clearance on the exhaust guides.
That's a good rule of thumb. So
and if it goes from 5/16, maybe 1.2 bigger.
Okay.
More, just to give it enough room, the heat expansion and the heat alone is going to burn you all out of the tip of that guide.
Okay. Well,
So
yeah.
you just have to give it more room to get some lubricity.
Right. How about guide materials? The old cast iron guides versus the powdered metal guides versus the bronze guides.
They all have different specs.
Right. Right. Yeah, because the expansion,
and whether you're using a stainless or a hollow stem steel or a titanium valve, the specs change with that too.
Okay.
Depending what coatings on them. That's a pretty tough one.
And coatings.
To overly simplify
that's
it.
hard to give you a specific answer on
It
something
is.
like that.
But to overly simplify it, if you got a bunch of spring pressure with a big cam, I always like bronze guides because they're much less likely to stick.
Okay.
That makes sense.
Yep.
Where a cast iron guide is more prone for galding. But I find it, for the most part, in a street application, somebody wants to put some serious miles on it, the cast iron guides, cast guides will always outlast the bronze.
The bronze guides.
They do last longer, so I like them in street applications, unless they're going to run some kind of ridiculously big camshaft with a lot of spring pressure. So, and as far as clearances, I think you always looser on power adders, but for a good rule of thumb, this is a little, I think, on the loose side, but a thou and a half on the intakes. 1.5 to 2 on the exhaust, and if it's a power adder, you're going to go 2.5 maybe.
Okay.
That's kind of just a rule of thumb. So.
All right. We're speaking about guides. What about guide finish? How critical is the finish of the guide?
It gets more critical as the endurance of the engine goes up. So
Okay.
for endurance application, I mean, those guys in the NASCAR world, they'll sit there with a diamond honed and get those things to within 1/10 total taper, bell mouth, and the surface finish is. The last I heard, he was using a profilometer on the dang thing.
Wow.
So it's very important because they have to last 2 races with those things.
Yep.
And maybe 3
So
in practice.
So they're actually doing surface analysis of guides now.
And we have to put up with a lot of heat really fast. So our surface is going to be, it's not as critical as something like that.
Right.
The clearances is 100 times more critical than the surface finish.
Okay. All right.
Just a decent crosshatch with the 320 is more than enough.
Okay.
And the metal of the guide, what type of bronze alloy it is. And even there's guides out, we make guides out of beryllium. And they never wore. They were absolutely awesome, just too expensive at $250 a piece.
Wow.
And Claude has a seat or a guide material called Tough Net, which is a nickel bronze.
Okay.
And it's indestructible. You can literally stick it out 2 inches into the airstream and it doesn't phase it.
And it doesn't, you don't get the...
But machining them, it's going to take you all day to hone them.
It'll take you all day to hone them.
Yeah.
That brings up another point is, from a machining standpoint, a customer or one of our guys asked, reaming or honing?
Both.
Both. There's a place for both.
And for some applications, and when you have a production line, just ream them.
Right.
They just ream them.
We do struggle with that on bronze guides. I prefer to ream it because it's way faster. But you go through a lot of reamers, which are very expensive, and they wear and they get tight. So, like he says, we typically ream them, and then we finish them to size with the hone.
With the hone.
Hopefully it's a few strokes, but sometimes we got to take a thou or 2 out. But
This isn't the old days. We got precision carbide,
right?
Fluted.
Oh yeah.
That really cut. But as they wear, sometimes they'll put a little more little taper at the tip that you got to hone out.
You got to hone
like
out.
that.
Okay. All right. Let's see. Oh, should you use sealants Loctite when installing seats and guides in cast or aluminum heads?
I would say no. You shouldn't have to.
We don't.
Right.
We try to make sure there's no leaks before we put them in. So, we do usually lube them to put them in because to keep them from galding the material when we put them in. We usually heat the head. It's on aluminum. We heat the heads and then press them in that way.
That was going to be my next question is on aluminum head, it's pretty critical that you don't roll the material as you're installing the guide because that creates all kinds of issues.
We go in and make sure to deburr all that area and make sure the radius on the seat is sufficient to where when you put that in there and we have the stabilizer that will hold it in place.
Yep.
And that head is stabilized at 230, 240 degrees. So it doesn't take a lot to put them in.
Okay.
It shouldn't take a lot.
Right. Now, do you freeze your guides or your seats? No, you just heat the cylinder head up, and typically only on aluminum.
Yeah, they don't heat. You never heat the cast iron heads, do you?
Yeah, I didn't know. I've never seen it, but I thought maybe.
Yeah, no, we've never done that. So, but we do heat all aluminum.
All
heads.
aluminum, and you use a lubricant on the
We
seat
just use motor
or the
oil.
guide.
Or maybe just use motor oil, right?
Yeah.
Yeah.
You can use any press lube.
Okay. But the key is don't roll that material.
Yep.
Yes.
The key is making sure your seats got a nice radius on it, and your finish
And
of
your
your
tooling
bores.
isn't sloppy.
Okay.
It's got to be
Rigid.
registered. Yeah, rigid.
Okay.
Yep.
All right. Let's see. And now we're going to get into a little bit, we wanted to get into some porting discussions. Now, we're sitting behind a brand new 5-axis porting machine that Mr. Bischoff was kind enough to purchase from us, but we want to talk about basics. Are you out of? Oh, there we go. Well, we want to talk a little bit about basics because not everybody is going to spend this kind of money to port cylinder heads or do blocks. So some of the questions that the fellas had is how do you choose a grinder to start with? I know that's a very basic question.
And it is a personal preference.
Okay.
I mean, some guys like the old Milwaukees that weigh 10 pounds.
Right.
And I've never been able to do fine work, but I have managed to actually persuade many of the people in the industry to switch to Dotco grinders.
Okay.
Because, yeah, they're $1,000 a piece. They're $1,800 for the big ones that I use. And you got to remember, I use a 3/8 shank with a 1-inch diameter burr that long with 8 flutes on it,
Holy
spinning
cow.
28,000 RPM. Well, I can walk into a wall and take a 1/4 inch out with that thing.
Wow.
And if it got away from you, it hurt you.
Yeah.
But if the Milwaukee's got away from you, it could kill you. I mean,
Okay.
I have been knocked to the floor with those things, and that was that. So I started looking for different grinders, and the Dotcos are the most bulletproof. I've had the 2 in there are 22 years old.
Wow.
And yeah, they're $1,000.
And
you just replace the bearings and the blades every 2-3 years, and you're off and running.
And I suspect you've put quite a few hours on those 2 grinders, Darren, for your career.
I can't even imagine.
So, when you talk about those, is it the feel of the grinder? Is it just the quality of the grinder? It's the Okay.
Yeah.
Yeah.
Being able to manipulate it in any way and still have that torque.
Okay. Versus that big old bulky.
Yeah,
kind
you
of
have
over the
all
shoulder.
the torque and no RPM with those things.
Okay.
These things are 28,000, and you need real high speed because you want the burr to do the work for you. You don't want to sit there breaking a sweat on the thing. Just let the burr take the material out for you.
Okay. All right. Great information.
But the good thing about the Dotcos is if you want torque, it's there. You
It's
can
there.
walk into something and it will
remove some material.
Yeah.
Okay. All right. There was another question on how do you choose a lollipop cutter, length, shank size, lollipop diameter, cast iron, aluminum. Well, obviously, there's different flutes for cast iron and different flutes for aluminum. We all know that.
You need to see my burr collection. I've got about $6 grand worth of burr sitting there.
Really?
Yeah, all different shapes. If I have to grind a shape, I want the cutter to have the shape.
Okay.
If I want a certain bowl arc, I want that to already be close within that cutter, not try to actually shape it.
Okay.
But
All right.
that helps immensely.
So if you were trying to put and I know nothing about this, but if you were trying to put a 3/8 radius in a intake port, you wouldn't be using a 1/4 inch tool trying to create that. You would be using a 3/8.
Reverse tapered cutters. Instead of a cutter shaped like this, mine are shaped with a T. so I can reach around the corner a bit.
Okay.
So when you, especially like a Pontiac exhaust port that comes out like this,
right?
I mean, there's almost no way to reach it, and when you're contouring short sides with those little radiuses or whatever, you have to have the proper shaped burr to actually get in there. Otherwise, you'll be forever.
Okay. All right. All right.
I mean, there are a couple of companies out there. There's Circle File, there's SF Carbide, and both of those companies make and have made all my cutters.
All your cutters.
Yeah.
How about once you're finished with a cutter? Obviously, I assume you use sand rolls. What grit size, roughness, that sort of thing? That's another question that the guys I ask constantly.
It depends on the application, but if you just go 60 grit all the time, you're never gonna
you
mess
won't go
anything
wrong.
up. Yeah.
Okay. All right. Well, there you heard it here. 60 grit, and you're good to go. How do you actually hold a grinder to prevent the thing from running away with you? And we kind of laughed and talked about this earlier, some of Darren's skills and what he can do with a grinder, but
It's practice.
It's just practice.
Yeah. I like to have the hose behind me, and I like to have it right here, and I pull my arm up like this, and I brace.
Brace.
Yeah.
Brace.
If it gets away from me, I don't want any slack, because if there's slack, it comes back and hits you.
Whacks you.
Yeah.
He's probably all the time he's got some part of his body up against the manifold, like his forearm or something. So he's braced with the part he's doing. And like he said, practice. You got to have strong hands. It's going to be a little bit harder for somebody that's never done it. But I bet if you checked his grip,
After 25
he could
years,
crush you.
you're
Yeah.
You'd never guess it, but I guarantee you, he could crush you.
Yep. Yep. It's like you need that almost like a 3 legs. You got to have the 3 areas of support there to keep the thing under control.
Yep.
Okay.
And you'll subconsciously learn that, you know.
Right. After it gets away from you. Yeah, the hard way.
Once he goes to grind it, he ain't thinking where he's putting it. He just goes.
He just
there.
does it.
Yeah.
Yeah. Just comes
He'll
natural now.
He'll make
after.
it look easy, and it's not. It
Right.
ain't even. You know,
Nope.
you give a novice one of them things, it ends up bad.
I just try to grind a hole I drilled that wasn't big enough, and I try to grind it out, and I end up going, you know. So I know exactly. Believe me, I'm in awe of your ability. Let's see. How do you? Great question here. How do you go about laying out an intake track? And what are, if you were to look at, what are the 3 most critical things when you start, when you're starting out?
It's kind of a little loop there, because it's like, how much power do you want, and can the head support it? And then we're going to tune the intake to what we can get.
Okay.
You know, so guy comes in and he says, I want to make 1,000 horsepower. Well, you only have a 250 valve or a 200 valve. You're not going to get there with that cam. So what we're going to do is we're going to say, okay, start at the valve. The valve is a limiting factor. How much air can that thing support? And then that will govern the RPM range of the engine. And once we know where that thing's going to run, then I can say you need this long a runner to fit with that cam and that RPM range.
Okay. All right.
It's the basic steps.
That's the basic steps. All right.
And to add on to what he's saying, sometimes you have an engine that you're starting with that you can't tune the runner length or taper. So the 2 things establish power band, RPM range, is runner length and cam duration. So when you typically speaking, if you have too short of an intake runner, you got to have a shorter camshaft. Even how you time it changes a little bit. So again, talking about tuning a runner length, some of it's relative to your constraints, what you got. You can only put so long in some applications. You only get certain intake manifolds. So you got to look at the whole cam and the intake together. Is my point.
Okay. All right.
Sometimes we get to pick our battles. Otherwise, we have other ones we just have to fight them as they are.
You just have to fight them as you are. Yeah.
Most of what we deal with, we fight them as we are.
How about the exhaust track? Is it pretty much the same, or is there?
No.
Okay.
It's not. Because the exhaust side is, I hate to say easy, but it is kind of easy. You know, all the heat energy and pressure energy is over there.
Okay.
So you can cam an exhaust port that's kind of crappy, you know, it doesn't flow quite as much with cam timing and duration and stuff, you can make up for those little faults. On the intake side, you can't. It's either right or it's not.
Okay. Intake side's much more critical to the...
Yeah, about 20 times more critical.
Okay. All right. All right.
Much simpler for sure.
Much simpler. All right. That's really all of the questions that we have. I want to thank Tony Bischoff and I want to thank Darren Morgan for taking time out of their busy schedule to answer some of these questions for our EPE group, and hopefully we'll see both of you guys there in Piney Flats, Tennessee in January, we hope again. We always love to have you. It's a great time. We sure enjoy being able to pick your brains and gain some knowledge. So thank you everyone, and we'll carry on later.
Engine Performance Expo continues to roll on. I do miss our friend Ed Keebler.
I do. Yeah, wish Ed was here. Ben's not here this year. Ed's not here, but hey, that's life. People got other things going on, and we're praying for Ed and his wife. Surgery is recovering, going well. So
exactly. But now, a hidden horsepower episode on location at the Engine Performance Expo. This one I'm very excited about. Pro Stock, as you know, and you as well, with your relationship with Matt Hartford and Total Seal after one of their best year ever. Actually, we're just trying to figure out. Mike Valerio, jack of all trades, says he. Pro Stock Pioneer says me. Welcome to Hidden Horsepower.
Thank you.
So your career has spanned many decades. Talked about doing a lot of work in the early days with the OEs, up until this past year where you helped Mark Powick get his first Wally in many years in the NHRA Factory Stock Showdown. What a career you have had.
Yep. It's been a long career. It's been great.
Let's go to the beginning. How did you get into this?
I had a friend in high school who had an older brother and older friends. They had a little hot rod shop, so we would hang around the hot rod shop. So that's where I first got interested in, back in the 60s. And I started getting little jobs for nothing, like drilling holes in beam axles of 48 Fords, hardened drills, burning up drills. And
jobs no one else wanted to do.
Right. Give that kid over there, he wants to hang around here. Charge him rent, too. So I had to pay $15 a month, my rent. But anyway, I started in Lycan cars then and worked at a Chevy dealer and living on a farm. And just got it very, very interested in it. And from those older gentlemen that were 2-3 years older than me, helped me take an interest in it. It's been a passion my whole life. I can say that I've only had one job out of high school, and I went into this building cars and
took over.
Followed your passion.
Yeah.
That was the bug. Yeah. What was your first car?
First actual race car,
yeah,
65 Chevelle. That was the first car. And second car was a 67 Camaro. I worked at a Chevy dealer, bought a brand new, big block when it came out halfway through the year, high horsepower, 409 or 396 with 4-speed. And a month later, I got a call from the insurance agent. He says, "Hey, you don't have insurance on this anymore. They came with this rule of horsepower to weight." And I said, "What am I going to do? I got this brand new Camaro, 300 miles. So I took the engine out of it and I blueprinted it back in those days, put it back in, and I ran into Ron Hutter, who had a dyno shop. Okay. So we backed that Camaro on the dyno and we ran on it, and Ron says, "This thing's got some pretty good snot. I think we can get some more out of it." So we became friends. And that particular car I bought at the dealership, we turned it into an A-modified production. I got to give Ron Hutter all the credit for getting me involved in the NHRA type racing, because he had a C-stock Pontiac Ventura.
Mm-hmm.
But anyway,
so are you from that area?
Yes, I live one town away from Ron.
Okay.
So I took that Camaro over to Ron's, where he worked at a Chevy dealer. He had an engine chassis dyno in there, and so we got to talking. I said, "Ron, maybe we ought to just build this thing up." And he says, "Oh, okay." So he started building engines. This is when he first started. We'd take the block, the speed equipment in Cleveland, and the crank would go somewhere, and we'd assemble it till he got his own shop.
So you were right there with Ron at the very beginning.
Yeah,
of all
right in
this.
the
So
beginning.
really, it's the insurance guy that got you into racing.
Yeah, that's right.
Unintended consequences.
Yeah, the insurance guy got me in it, and one of them kept me in it because I was going out and buying these stripped out, they call them stripped out high performance cars back in the 60s.
Mm-hmm.
The average life expectancy of a big block Chevy or a high performance car on the streets of Cleveland was about 30 days. So
maybe shorter in the wintertime?
yeah. So we had this insurance adjuster, and we had a Chrysler guy and we had a Ford guy, and I was a GM guy. So every time one of these come up, we'd bid against one another. Of course, you know, the juggle of bidding. I got all the Camaros. I had Z28s lined up, Chevelles. I had a whole yard full of them. So I started selling parts off of those cars to help the racing program. I sold parts to the local junkyards until they were able to buy them through the salvage pool, which is now a salvage pool. So that canned heat Camaro that we built in '69, that was one of those insurance cars that we got.
Whoa, okay,
So
hey, wait, time out. Right. So you're saying canned heat, like one of the famous race cars in NHRA history, that was you and Ron building that car out of basically junk parts.
Yeah. We went
an insurance car.
An insurance strip out car, yeah.
Insurance strip out car.
We'd roll her into the shop and tear her down. We could take one of those things apart in about 15, 20 minutes and still know every nut and bolt in one of them things. There ain't very many, the whole front end comes off. And then we'd start chiseling the body, deadener out to lighten it up.
Mm-hmm.
And down the road there's a place called Diamond Alkali. One of our buddies worked there and they had an acid tank in there. So if we're gonna build this car, it's gonna be, the best it could be. Acid dip the doors, acid dip the fenders and everything. Of course, I don't know if it was shady rules.
Well, so let's pause there. Because
yeah.
The story was, hey, Mike's going to be on Hidden Horsepower. There were a couple of different notes, and I reached out to Michael Heiner, who's the crew chief of the Get Biofuel car. He's from Ohio. A lot of great racers from Ohio. Acid dipping. Ask him about acid dipping. One of the first to do this. How did that come about? It's kind of out of the box thinker.
Yeah. So we thought to lighten this stuff up, we were going to go up to this shop up the road at 3 o'clock in the morning and use their acid tank. So we lightened the doors and lightened everything we put in there. We left it in there and cooked it. So then the following year I was building a 70.5 Camaro, and we were going to the Winter Nationals, the first Pro Stock Winter National, 1970. We had the 70.5 Camaro on the trailer going to Aerochem in California, which is a chemical milling aircraft plant. So we got the body cleaned, some Mexicans stripped all the paint off it, we took it over, we got it stripped, we got it back. And somebody in Akron had this big tank, a big acid tank, but they were having trouble, they were ruining stuff, and they built Hunter Miller's first car, and they had trouble. Anyway, I ended up buying that tank from them, and I put it in there. And started building Vegas, acid dip Vegas. There was an article in Carcraft magazine, and the General Motors engineers saw it, and it was right at the time they were trying to take weight off of automobiles for better gas mileage. So they says, maybe we can use this guy. So they called me up and said, hey, we want you to acid dip some Camaros for us. I said, oh, okay.
GM,
yeah.
Okay.
Yeah. So I started doing those bodies for them. They called it an A-pillar crush test. It had to meet a certain, it was way overboard so they could go farther with it. So they were going to buy this real thin Campbell's soup tin and build one of these cars, and it was running them millions of dollars. So they called me up and they saw this article. I built a Camaro that weighed 1,800 pounds. So that's what started it. They started bringing them in, and then they produced them. And the last one I did, we acid dipped or chemical milled every panel in that whole car, and they sent it to Cincinnati and had it built. They built the whole car and then crush tested it. So that's how I got into that. But I think the real stories you're looking for is the time I fell in the acid tank.
Oh no.
Yeah.
Uh-oh.
Yeah. Yeah.
Obviously, you survived.
You have superpowers.
Yeah, survived.
Right, like in all the movies, if you fall in the acid tank, you come out
You're
with
done.
superpowers.
Yeah,
or you're diabolical.
Yeah, right. I was yellow.
See? There you go.
Yeah. So I just recently started doing some work for Chrysler. And I had to build a bigger rack to all those big cars and everything. I had an electric motor, an electric lift on a chain, and it was, you know, I was like in my 20s. I wasn't rocket science to worry about that electric motor up above that acid. So I had Ronnie Sox's car in there. It's about the third car I did for Chrysler. Had Ronnie Sox's car in there. I go over to the trolley to pull it up, and I go, I look up, and it's not moving, and it's sparking. So I had one of my helpers, I says, run down to the shop and get that come along up here so I can get that thing out of here. They only have to stay in there 20 minutes or so. They're done. So he brings it back, and I go up on the rack, and I hook it onto the rack, and I start standing out on this carrier, and I'm jacking this thing, jacking it up, and it's gotten up, and I'm looking for places to put my feet, and it's coming out, you know, looking down, and, you know, oh gosh, there's a big hole. Well, there's another one. And I slipped, and I fell in the tank off of that. But I got out, and I got right out, and my buddies ordered bringing this thing out, and I went over and I had all safety stuff, you know, you wear a suit, but the acid goes through it, goes underneath it. Sprayed myself off, I was okay. Went down to the office and I called Larry Henry at Chrysler. And I said, Larry, got some bad news. I says, I just lost a duster, and I think it's Ronnie Sox's. He says, well, what's it look like? I said, did you ever see a turkey after Christmas? It looks like a Christmas turkey. It was just the A-pillars and just some of the inner structures. So they says, well, you better get up here to Hamtramck. We'll have you another one ready in a couple of days. But, you know, it was a lot of fun.
Amazing.
Yeah.
I'm envisioning Wile E. Coyote after, you know, like a bomb's gone off or something.
Yeah,
You know?
yeah. So
But you're obviously lucky to have escaped that.
Yeah, escaped a lot of things.
But in that era, though, and just thinking about the people who were around, you know, we're talking about Grumpy Jenkins, obviously the Bob Gliddens of the world, Sox and Martin, Mr. Four Speed, Roy Johnson, like the Pro Stock was popping at that time. It was, and still one of the big three categories in the National Hot Rod Association. It's morphed and changed over time, a lot of technology. But we say the word pioneer as in, it was a wide open field. You guys could do a lot of different things. What was that like to be able to have like this open playing field, to be creative and come up with different things, whether it be on the car, the chassis, under the hood?
Yeah. Well, it was right up our alley. You know, challenges are what we live and die for. So when we get one of these new cars, we'd first lighten it, and you know, it's just everything we did we have to make. And we would talk to different manufacturers, and they'd say, like a carburetor company would say, you can't put those carburetors on there sideways, it'll never work. And Ron Hutters, Mr. Technology, it was gonna work. So we would make stuff like that up, and we'd run our carburetors sideways, but you basically had to fix everything. One of Ron's famous sayings was, if it comes in a box, you gotta make it right.
Yeah, I've heard him say it.
Yeah, you've heard him say it.
Yeah.
Probably some of your boxes at one time.
That's right. Everybody's, right?
Yeah, that's
it's everybody's, you know?
That's right, everybody's. Yep, so, you know, we would end up either highly modifying or building our own carburetor linkage, things that you just take for granted today. You couldn't buy cams that were, you know, buy a Chevy cam and TRW pistons, which we spent a lot of time developing pistons with them because they didn't, if they said they had 11.5 to 1 piston, it's probably a 10. So I remember in the wintertime I made a cup up for a piston so I could read the CCs, and Ron Hutter and I was out in my garage on a cold winter morning and figuring out they were wrong. We started welding on the domes of the pistons, and that's where you see that famous picture of Grumpy Jenkins looking at the dome of the piston, because we were all kind of late night talkers, you know, and But we redesigned the piston, and then that time TRW went into the piston business. They were an OEM supplier at the time.
So you were taking an OEM piston and welding it
to get the dome.
Dude, that's just cool.
Yeah, and grinding it the way the flame propagation and things like that. We did a lot of that kind of stuff. So that's how the early years were, because Jan's pistons, fuel pistons, wouldn't fit in the 427 Chevy big block. So we had to make it right down to the piston. Of course, we were limited to what we could use. There was not a lot of aftermarket. There was nothing like it is today. So we were, all of us were pioneers in that way. Yep.
And it's just incredible to think. Yeah, I know it from the NASCAR side. I got to spoke to Watto Wilson recently, and they were at home in Moody.
Yeah.
They were building all these engines, but they were getting engines from Ford. So those engines were built at Ford.
Yeah. Ford.
Shipped down, then they took them out of the crate and they would blueprint them. So they would go through everything, and obviously that blueprinting process was trying to make everything as accurate as they wanted it to be, and obviously there were some little tricks here and there in terms of assembly, fit and fitment type stuff.
Yeah.
But what I hear you saying is obviously what you guys were doing in drag racing at that same era was you did all that, plus you were really kind of going outside the box and thinking, okay, well,
there wasn't even a box though.
You're right.
There wasn't even a box. There was just nothing. There was just open space, and they were
like
figuring it out.
It'd be better if I could have this. I think it would be better. Let's make it and see if it actually goes better.
It's a continuous problem solving, basically. You got to know the problem and you got to solve it. And with racing, you get one problem solved and another one comes up.
Yeah.
That's just like the situation I have going on right now with Mark's car, because they took 50 pounds off the car, and I had that car perfectly balanced. I mean, you can read the track and we knew what to do with it, perfectly balanced. Well, that 50 pounds has upset the car. It's taken me 3 months to get the balance back to that car.
Let's go a little.
Those cars are so sensitive.
Let's go a little deeper. NHRA as a category, flex jet, factory stock showdown. These factory engines, but are limited and regulated. They're over like 35, 50, 3,600 pounds now. Mark Powick, former pro stock racer, he's been involved for a while, but got his first win this year, and it was a big deal. But in what I would call mine shaft amazing conditions, ripped off the first 750 anything, and that alerted the rules makers, and they walloped you guys.
Yeah.
And some would say too much. I'm not giving my opinion, but that caused you guys a great challenge, because now you had to go back to work. So let's just start at how meaningful was it to be a part of that, to bring Cowboy back to the winner's circle? It was a tremendous victory. I know he and his family have been working on that for a long time, and you helped deliver it.
Yeah, known Mark a long time. Known him since he had to have a pillow to drive his car. So he calls me up and he says, what are you doing? I said, I don't know, I'm retired for the 4th time. And he says, well, how about number 5? He says, I got a job that I want you to look at. I want you to help me. I says, it better be a good challenge, because I ain't riding my ass all over this country fixing race cars again. So he told me 3,600, 9-inch tire, 1,400 horsepower. I says, hey, I'm on. Limited, you've got to really understand the dynamics of the car. And so I went on with that, and he has Dave Barton as an engine builder, and Dave and I hit it off. We're very similar in our thought processes, and so we began to hit it off pretty good. So now we're taking on this NHR challenge. And that's what I like. I mean, I've been around NHRA my whole life, and when you do good, you get knocked. And you got to come back, and it makes you tougher. So, I'm one of them kind of guys. Oh, yeah, okay. All right, I'll figure this one out. So that's where we're at right now with Mark's car.
So at the start of last year, Mark was having great challenges, just blowing the tires off at the end. He couldn't even get to the weight transfer point. I don't want you to tell us what the problem was, because someone else has got the problem, and maybe they need to go through that exercise. But you clearly solved the problem.
Yeah, between Dave and I, we solved the problem. But those cars are so sensitive, And
Is that just because the tire is so small?
the tire's so small, and they have to stay stuck, a dead hook, and they have to roll without blowing off. So they have to leave the starting line with no power. Well, any race car has the biggest advantage in the first 60 feet. I don't care we all know that.
Yeah.
So those cars were very, very slow. And if you have a bad 60, you're going to have a bad 360. But those cars are so powerful, they got a back end on them like crazy. So to get it to use the horsepower, I did a physics formula, and I figured out how fast that car should run, that weight, zero coefficient of friction, because there basically isn't any tire spin like I'm used to in Pro Mod cars. But anyway, I came up with a number. We haven't hit it yet, but we've been very close. We went one time where I thought, well, we're getting closer, but I threw it out because it was only one time. We have had the car running consistently below the 120, which has been a project for those Chrysler cars for a long time because they're a long wheelbase. And it takes a difficult car like that. It takes a couple of races and maybe a half a season to figure out the personality of the car. Every car's got a different personality. Me being a car builder, building pro stock cars, if you have one welder doing this and another guy doing that, we finally figured out all the sequences, hundreds of welds to make that car torque the way we want it.
Okay.
It took 5 years, but anyway. So I learned at a very early age of dealing with these high horsepower cars, they all have a different personality. They all twist in a different way, and somebody's modified it, and it changed this and it changed that, and we got a degree different over here, and so it's an ongoing process.
Yeah, the chassis is a spring.
Yeah, the chassis is a spring, and shock technology they have today is amazing. And sometimes simple shocks work. It's just
it's like what combination works. But like you say, you knew that with that tire you couldn't accelerate it more than this, so you had to try to get as close to that without going over that. So you're not giving it up. It's like bracket racing.
Yeah, they're that touchy though. They're that touchy.
They're super sensitive.
Yeah, half a degree at a time and blow the tire off it.
Which is great though for entertainment value, because we have these cars that, they're 3,600 pounds and they're both blowing off the tires, and now the driver's got to figure out how to get to the end first in the end because it's a drag race. And it's very exciting, and people love the class. We got Factory X coming as well. Does that interest you?
Oh yeah, I'd love to get into that, and I'm doing some serious talking, trying to. But they're very expensive.
Come on, Powick, spend the money.
Yeah, I think we.
You got heavy hitters in that class.
Yeah, well,
that is not for.
And more coming. It's very serious.
I've been through that deal with ADRL. I had a Pro Mod, ran on 10.5 tires. I've got a lot of experience at running 10.5 tires with about the same horsepower of these cars, and those guys are struggling. I can't figure it out, but I know it's there. I would like to build one of those cars because I think we'd have an awful fast hot rod. It's just pulling it all together and running the car this year, and I'd like to have one right now to start working on, kind of build our own car.
It's been interesting to see how it's being received with all the rules of the engine, crankshaft centerline, engine's very far forward, it's in a stock location. It's interesting. There's no nothing to copy off of to really take a base setup from, is what everyone is telling me.
My only thought on that is they'd have a lot more of these cars coming out if they were to allow a fluid-driven transmission instead of the clutch.
Yeah.
You could put a Liberty behind a tie drive, a fluid drive. I think they're both about equal. Maybe the little disadvantage of the fluid drive, but they're making a lot of improvements on those.
But just to avoid resurfacing the clutch and all the associated
that's
work.
they want to keep the cost of it down. Now you gotta have a clutch guy.
Right, you drive the cost up,
Everyone's excited for the Liberty though. It's gonna be it's gonna be a lot of fun.
Yeah, you can have that Liberty with a fluid drive.
Interesting.
So if NHRA would allow that, I think that class would, everybody be building cars. You know, Haas would have 6 more than he has now.
Oh my gosh, I don't know if he wants that.
No, I know he doesn't. None of them want them.
Right?
That's another thing.
They're overwhelmed. But
yeah.
a good problem to have, and who knows what will happen down the road. So isn't it interesting that we just talked 2 stories. One, the very beginning pioneering moments of Pro Stock, and then the most absolute current category of NHRA drag racing, which is Factory Showdown and Factory X.
Yeah.
And this guy is involved in both.
It's incredible. And you mentioned something, just as a kind of casual statement, that you and David Barton kind of hit it off and thought the same way.
Yeah.
I think that's really, really an important moment because from the chassis side, the engine side, they're not 2 separate theses. They have to.
No. I got to know when he's bringing the power in. I got to know, and he's got to know what I got on my mind. I'm putting more weight here. Well, why? And we get along great. And that's part of a championship team, is to have everybody do their job and give everybody a break.
It has to.
That's what we're trying to do this year.
And for those of you who are enjoying the Hidden Horsepower podcast feed, you can check out the David and Ray Barton episode in the feed, which we had them both on. Now I understand.
And there's a Ron Hutter one too.
Yes, I think David is stepping back from the driver's seat this year, is what he told me, and he's going to help with the customers and the clients. So you said the word championship. That's exciting.
Yeah.
That's the plan.
Yeah, so it's going to be an uphill battle, but we're tough. I might be old, but I'm tough.
He survived falling in an acid bath. I mean, come on.
There's your second T-shirt quote there, Lake. I might be old, but I'm tough.
Yeah.
No,
I can feel that, man.
Can we go back to some of the characters of the early days? And I don't know that you have a story ready to just pop up on us, but that's kind of part of Hidden Horsepower, in that you were in the middle of this golden era. Like, Grumpy Jenkins rolls out the first chassis car.
Yeah.
What about that? Like, where when that, like, oh man, this thing is all chassis, all pipe, there's no factory, nothing in this thing. And a lot of people think that in that moment, NHRA should have sent them to the house, and that might have changed the direction of Pro Stock. What is your take on that moment?
Well, I was there when that happened. Well, they allowed it. No matter what, NHRA can do whatever it thinks can help. So they allowed it, and Ron Hutter went along with building his own style of that car. And by that time, he had his business going pretty good, and I had gone and formed competition engineering. But before that, I built some cars. And that was the deal. He lent me his blueprints to build my car, and I built my car, and of course, Friday come, I need money, somebody wanted to buy that car, it was gone. So I think I built 5 or 6 before I got my own. But
so competition engineering, that's the same company that Moroso had later, that people are probably familiar with seeing that logo, that name.
The decals,
that's
everywhere.
You.
Yeah.
You got your decals out everywhere, by the way. That was like, marketing 101.
Yeah.
The logo was everywhere.
Yeah, I did the same thing with MVM carbon wheelie bars. They got them on some of the, well, I used to start at the bottom working with somebody, and I'd finally get to the Grumpy Jenkins deal, But anyway, this time the carbon wheelie bar deal was after Don Ness had started making them. They had a little failure with them. And I always wanted to do it. Even before he did it, I wanted to do it. And I've been working on it a little bit at a time.
What was the thought? Why carbon versus something else?
The material is very rigid. And you can make it flexible, but it's very rigid. Being a car builder and a car parts builder, you could see the old wheelie bars flexing. And even chromoly, where they would flex, so they always had to stagger the right side down to keep the car in balance. Carbon, you don't have to do that 1/16 of an inch. And I changed the design of how they're mounted to the car. I raised the upper strut a lot higher so the wheel had leverage on the rear end, where you just run a wheelie bar out of the bottom with a short stack on it. It doesn't have much control over it. When you put it up over that pinion and you're pushing on it, so that was one of the things it did. The other things that it did was cut down on a lot of tire shake. In fact, at Gainesville one year they had Kevin Rivenbark's car. They were doing a close-up on the tire shake, and it had a carbon bar that was bending. But the wheel and the wheel housing are so much lighter, it's like a pendulum out there. And in all my slow-mo movies, I could see the rear end jumping, and then the wheel would answer it, and the wheel would shake, and the tire would answer it, to shake back and forth.
With the chromoly.
With chromoly, because they're heavy. Yeah. So with the carbon being lighter, it wasn't as much of a pendulum. So one of the first cars I used was Stevie Jackson. Stevie Jackson, he was drive-through tire shake king. So he started putting those on there. He says, man, those things are amazing. He says, I can feel them shaking, but I can drive right through it. So those steel bars, I'd have had to give up and lost the race.
Wow.
So there was a lot of different things. And then people use them now for wheel speed. They'll ride them, you know. They'll make the tire spin off them. They're that controllable. You can lift them up a couple hundred thousandths, gain 400 RPM.
Just by lifting the rear tires off just to get that initial wheel speed up.
Yeah, the guys that really know how to use them, they won't chalk their tires because they don't want you to see how far out they ride them.
How cool is that, Joe?
Amazing. No, it is.
Because you're there every weekend. This is the world you live in.
It's got a lot of things to
and
see.
it's annoying that there's just so much amazing stuff going on, and you can only absorb as much as you can absorb. And I try to absorb as much as I can, but every run that goes down that racetrack, there's something exciting and interesting going on. All right, before we wrap up, you know, we have a question we normally ask during Hidden Horsepower, which is, we're all trying to motivate this next generation of racers, crew chiefs, chassis engineers, engine builders, machinists, and otherwise. And I like to think that there are some young people out there checking it out. What advice would you have for the next wave of people like yourself to hopefully come in and get ahead in this field?
Well, I think they have to have some mechanical abilities. They seem to be the ones that want to get into it. But going to the racetrack, talking to drag racers, the best people in the world, we're all family, you know? And I think that's what I do. My job is to carry on, teach younger people than me, maybe people my own age, my knowledge to help this go on, the whole thing. What little knowledge I have of this whole great big thing, I'm giving it away. I'm working like with David, and I work with Chris Nelson for 6 years. What was that? 7 years at Chris Nelson.
I know Kyle Powick probably wants to know all the stuff you know too.
Yeah.
Just throwing that out there.
I'm trying to teach Kyle too. Yeah.
Well,
that's Mark's son, obviously. He's coming in and
trying to
doing a great
teach him.
job. Doing a great job.
Yeah.
Daughter Kaase as well.
Yep, exactly. Yep, the whole Powick family is.
Ohio must have been a real hotbed. Just thinking about George Montgomery, obviously,
gassers,
but Larry Morgan and
Gasser City. Yeah,
it's
a lot of
pretty amazing.
gassers. Pro stockers, a few, mostly gassers. I think we held from Virgil Cates A-Gas Super all the way down to the G's.
So is it
Schwartz.
Is it Lima or Lima, Ohio?
Lima, I say.
Okay.
You say Lima?
We don't know.
Yeah, well, we just
potato.
Right.
So you're asking all the Ohio people.
I'm just asking.
Oh,
We're getting a poll.
That's important, right?
Yeah.
Okay.
Lima.
Look at that. See, we get the answers here at the Engine Performance Expo on a special edition of Hidden Horsepower. Mike, thank you very much for joining us. So exciting, obviously, that you continue to enjoy this sport and be challenged by it. And thank you for sharing your story.
And he's giving back. I mean, what he just said as his answer is basically the ethos of the Engine Performance Expo. We're here sharing what we know to try to help those who are watching. And stay tuned because we have a new video coming out on surface finish, which you know is my favorite topic. We talk about surface finish all the time.
We do.
And it's super critical. But one of the questions is, well, how do you get there? So really, abrasive selection is like the first step in getting the correct surface finish.
Exactly. You hear us talking a lot about the correct RVK and how that number is going to change a lot depending on your application. And that's the number one question we have is, I'm not getting the deep RVK I want. How come? And basically, we're trying to put together a little video here to show you guys more or less where to start.
Because turning up the load is not the way to do it.
No, it is not. You're not going to keep your cylinders very straight if we're doing that, and we're not really going to get that much deeper turning up the pressure.
Right, so you really want to begin with the correct abrasive for the application.
Correct.
I know I feel like it's like a broken record, like I'm always using the word application, but it is application specific. So, for example, this is a diesel block. So what do we got here?
We got a 6.4 Ford Power Stroke right here, and right now loaded in the hone head we have a 170 grit diamond.
Now we use that a lot. That's like probably our most common go-to diamond. Why is that?
Because it's going to give us the RVK that we need for this particular application, but if it was getting really heavily boosted or more boost, we're going to want a deeper RVK. But we actually have...
So like with the 170, 600, or 170 diamond, coming back with a 600 grit CBN as a finishing combination.
Yep.
My experience has been you can usually, depending upon the hardness of the block.
Absolutely.
You can be somewhere probably in, we'll call it the 50s, maybe 60s. Up to the 60s.
Yeah, right in
that's the range that will give you, right?
Yep.
The softer block, you'll get the deeper valleys. The harder block, you're going to be a little shallower on that.
If that Burnell is super high, obviously you're not going to be able to dig quite as deep with the same diamond.
Right. So if you want to get to like the 70s or the 80s or beyond, you're going to have to go to a coarser grit abrasive. So you may be at a 140 or a 100
or 100, absolutely.
Okay.
And I mean, we got as Ed Keebler likes to label them, the crazy diesel guys.
Yeah.
We have customers running 60 grit diamonds.
60s.
Which is going to give you a really, really deep RVK. I don't know exactly what that number is, what they're shooting for off the top of my head, but
big,
yeah,
deep valleys.
Yep.
So I guess what the moral of the story here is that you got to begin with your application. Understand where you want to end up on terms of your RVK. The more fuel you put through the engine, the more value you need.
So,
which is why the crazy diesel guys, I mean, they're literally, when we say that, we're meaning like the 300 PSI compound turbo diesel guys, where it's just basically a constant injection of diesel the whole time, pretty much feels like. So in those cases, you need that deep valley, and the way you're getting that is by going to that coarser grit diamond. The less fuel you're putting through there, you can get shallower and shallower. So that range of maybe from a 60 grit all the way maybe up to even to say what's about the for even a gasoline application, right? Grocery getter, OEM rebuild type stuff. What would you recommend for?
We're seeing people do this exact same application for that.
The 170.
They might do a few more plateau strokes, so their valley might be closer to say a 40. But I mean, we have people doing grocery getters with 170s even.
That's kind of what I was thinking too, is that I don't really see a use to go finer than a 170 diamond for your base finish.
Yep, and the base is what's going to lay. I mean, so we're talking a lot about base finish, and we're talking a lot about how we want to. If we want that deeper RVK, we want to establish that in the beginning. It's the first. The first selection is that diamond. Now we're talking about RVKs a lot, but they're not going to be able to measure the RVK until they're not going to be able to measure the RVK first. They're going to actually have to look at the RZ number.
Absolutely. So because when you're doing your base finish, it's a single grit finish. So the peaks and the valleys should be the same height. So RVK doesn't tell you the truth. Like for example, that might only say it's an RVK of 70. But as soon as you begin to plateau,
chop into it,
that valley will grow because that proportion now changes. So like you said, you want to begin to look at what's called the RZ, which is your total peak to valley. Now, you guys have a nice innovation that you've added to the package.
We do.
So show them what you got, because this is the game changer right here.
So we've been talking a lot about surface finish, and we've shown you guys trace boss in the past, but I believe this is going to be the first video we have where we can show you trace boss on the machine. And so
for people who don't know, talk about what trace boss is and how it connects to this little device right here, right?
Yep.
Our profilometer over there?
Our profilometer is right here.
All right, so the way to know what surface finish you have to measure it. This little diamond tip stylus drags across that cylinder surface, and it's gonna, like a needle on a record, it's gonna give you this trace. Now, what we've done in the past is we've relied on those numbers.
Yep.
What Trace Boss, especially this Trace Boss Plus on the machine, changes that, because now you can actually see that trace.
Yep.
And it just changes the game. Like I said, I sound like a broken record, no pun intended. Yeah, actually, that was pun intended, sorry. I'm bad that way, right? But it is so revolutionary when you can actually see that surface and see the progression, which we're going to show you. So stay tuned, because we're going to show you how we go from that base finish up and down and create the plateau.
And one thing that Lake here has been great at talking to people lately is, yeah, we kind of use the numbers as guidelines, but this picture is going to be very crucial in telling us what we actually have.
Right, so let's go ahead and put some base finish in one of these cylinders. We're going to measure it, and we're going to show you the difference between that RA, the RZ, and then your RVK. And over time, you're going to see that RVK change, and we're going to show you why RA doesn't matter. And then we're going to look at that RZ and let you kind of see that progression.
Perfect.
Sounds like a plan?
Sounds like a plan.
All right, so 170s are already loaded?
Yep. They're loaded, and we're just going to go ahead and we'll take out, I don't know, maybe 7/10 of thou. What do you want to do?
Okay, take a full thou, yeah.
Full thou? All right. So
and watch how fast this goes, by the way. It's pretty amazing how fast this thing can take a thou out. You know, Scott, I love it every time the machine sits there and starts to kind of stroke in those different areas, you know, because that's the thing about this machine that's so amazing, is that it's sensing and feeling the fact that cylinders don't wear evenly up and down, right? I'm a piston ring guy, I can't help it, right? Because the piston is actually not going the same speed up and down, and the cylinder pressure isn't the same top to bottom.
So it's going to wear differently.
Yeah, cylinders don't wear evenly.
Yep.
And the machine sees it, it feels it, and then it fixes it.
Yep.
And you can even see it right here between this cylinder and that cylinder, where you only got 1/1000ths here versus 4/1000ths over here. At 1/1000ths, that you can still see it where the ring has been running
turning around. Yep.
Yeah.
100%.
That's kind of neat.
Yep.
Right? Just random side. You just I love it. All right, so we've established our base finish now.
Yep.
So like we said, we want to go in and measure this with the profilometer and see what that RZ is.
Exactly.
All right. So what we'll do is we'll clean this area up right over here. I mean, you can feel the difference with the base finish, how much rougher it is versus the end. All right.
So we're just going to have to hold that, unfortunately. All right. You ready?
Yes, sir.
So. All right.
Perfect example.
Yeah.
All right. Yeah, so this is exactly what you're looking for. You can see that uniformity up and down, essentially. And the way you can see that is those detection zones. That red area is your RPK. The blue area is your RVK, and they're equal. And you can see the material ratio curve that is basically balanced.
Exactly.
That's a single grid finish. That's how you know it is. So right now it's saying the RVK is only 50.
Yeah.
We're not worried about that. What we're looking at is our RZ. So our RZ is 260, which means this is a pretty hard block.
Yep.
You know, that's what, because usually a 170 is going to give you 300 plus.
Yep, usually.
You know, if it's a really soft block, it could be up to 500.
Yeah.
So this one's really hard because it's basically half of what a soft block is.
Exactly.
All right. So one thing I really like to do with this trace is that because our scaling is here, because this is a little bit shorter than we thought, I want to do is go in here and adjust the scaling real quick. We're going to go to, where's the keyboard?
Right there.
All right. So we're going to do pop right here, and we're going to do 200 micro inches up here. And we'll do 200 micro inches this way.
Minimize that, and then shit, okay. There we go.
All right, perfect. Okay, so now we change our scale to plus minus 200 micro inches.
Yep.
So every 100 micro inches is a tenth of a thousandth on the side, right? Which means that's 2/10 on the gauge.
Yep.
Right. So looking at this right here, I mean, we're only maybe 100 micro inches.
Yeah.
So we could be within a tenth or two of size and be able to knock this down and plateau it. So really, it's minimal stock removal when you're coming to the finishing strokes.
Exactly. So this is a great way to measure if you want to figure out if you needed how many plateau strokes, and if we're talking total stock removal, if we saw that these weren't as large, then we know we don't need to do as many plateau strokes,
right?
Which means that we're going to end up, we can hone closer to size, essentially, is what you were saying.
Right, yeah, so
with this application, right?
So with this one with a very low RZ of 260, there's going to be only a few strokes with the plateau operation. Whereas, let's say we had an 80 grit diamond in here and we're trying to create these deeper valleys,
and that RZ
this would be way higher.
Way higher.
And you may actually have to come maybe almost 3 or 4 tenths from size to stop because you've got so much removal, so many strokes you have to do to be able to get there. Because what you want to do is you're trying to mow the grass and get down to here. So that top part's got to go away, but you want to maintain this bottom down here. So really, yeah, we're talking about maybe 50, so really about maybe a tenth actually total is all it would come out potentially.
Potentially, correct.
All right, so let's show that actually. So let's swap over to the 600s and let's actually take out maybe like, say 6 strokes and just come back and see what it did. Because I think that's just going to do, I'm going to guess, right? We'll see how good I guess here. I think that's going to knock us down to right about there.
I bet you're going to be close.
Yeah.
Alrighty, here we go.
So talk for a second about the plateau mode and how it's different than the normal honing mode.
Absolutely. So one thing that's very different about our machines is we plateau out. When we're starting our plateau, we do a couple feed click outs here. 1, 2, and 3 against the wall. And we're not spinning when we do that. So we're not changing the surface finish at the very top of the cylinder. We have a consistent cylinder finish top to bottom. And so that's something very unique with the Rottlers that we're proud of.
Oh yeah, it makes a giant difference because you can see it. With the camera, which we'll show you later.
With the profilometer.
Yeah.
Absolutely.
The surface finish doesn't vary top to bottom, and the crosshatch doesn't vary top to bottom either.
Nope, not at all.
All right, so, man, you can already feel the difference just wiping it. Yeah, when it's rough, I mean, you can feel it kind of dragging, and when you do this, it's amazing how different it feels just off the go. All right, so we got that done. All right.
Alrighty. Ready?
Yes, sir. Go.
Usually it switches and says receiving. Something's up, I think. Pretty good.
Boom.
Right at the top of the, yeah, just like what you said.
I guess pretty good.
Yeah, pretty much.
All right, so what's interesting here is, I said we came out here with 6 strokes. It kind of took that, we didn't change the scale. So we had all this up here, we mowed it down to here. It's getting pretty good, but we're still not quite there yet. You know, the RA went from I think around 26 to 21, which shows you how much it changed, but the RA lies to you.
Uh-huh. Look at your RZ number.
Yeah.
So the RZ originally was 250, 260?
260, yeah.
And now we're at 148.
Yeah.
With 6 strokes.
Yeah, that took it down that much. And your RVK really was around like 50 something. It's 46. It really didn't change.
Not yet.
Not yet. So what I think we need to do now, our RPK is 14, our RK is 54. So our RK is still higher than our RVK, and you can see that right here. That's why. So it needs a few more strokes. What do you think? What's your gut on how much more take out right now?
I would guess about 4 strokes is my guess.
The same thing. Let's try 4 more and see what happens.
All righty.
So we got the extra 4 strokes done, and man, Scott, you nailed it. It's right there.
It's pretty much right there. The one thing that we want to point out here, this trace looks gorgeous as far as it's nice and consistent.
Yes.
Consistent is a good word there. However, we have these couple outliers here where we got the RPK where it's saying that peak's a little bit higher. And so that on your RPK, it's telling us our RPK is 13.7 right now. But in reality, when we run this, those RPK numbers are going to drop right away. I mean, even just rolling it up and down once, just manually on the
assembling the engine, these are going to be gone. And that's what the beauty of the software is, because if you were only relying on the numbers, you may be tempted to say that's a little bit rougher than I wanted to be.
Let's do one more stroke.
And you didn't need to.
Exactly.
Just putting it together, you'll be able to knock that down, and you can see that with the software so clearly where those anomalies are, so you can actually get a bigger picture, no pun intended, of what's going on. The nice curve there, everything's the way you want it to be, and now we're still, that RZ is 145. It didn't really move that much, but with those 4 strokes, we were able to flip the RK and the RVK. So the RVK went up. Did you notice that? We were in the 40s before, now we're back to the 50s.
Yep.
And that was just because we're taking that peak down. That ratio is changing.
Average. Yep. 100%.
And then the nice thing too is we used our camera, which integrates now into the Trace Boss Plus, and we're right at 45.7 degrees crosshatch.
Consistently through the cylinder, top to bottom.
And you can see in the picture here a little bit how consistent it is. Like you said, when you're spinning it out, it's not changing it.
Yep.
And that's the beautiful thing, is you can check this thing, you can take it up and down the cylinder bore anywhere you want, and you'll be able to see the consistency of that crosshatch. So that crosshatch is consistent. You've got the right crosshatch angle, you got the right surface finish. It's job done.
So now we can look at the overall picture and not just the numbers, basically.
Right.
Is the big takeaway. And we can look at the picture on the hone itself right here, which is amazing.
And one nice cool feature too is you can save all of this, and you can even print it out and export it to give it to the customer, so that the customer can know what he has for surface finish.
On each cylinder, even.
Right.
Yeah.
It's pretty great.
It's awesome. So we talked a little bit about surface finish now. We're going to change gears here a little bit. A lot of other questions I get are regarding stones and whether I want to run a 4-stone hone head or a 6-stone or 12-stone.
So we just did 6 for the roughing and then 4 for the plateau.
Yep. So our thought process there is you can order CBNs in sets of 4 or 6. What's the difference between, if we've already established the whole geometry with the 6-stone hone head, if we go back in there with the 4-stone, we're really not changing the geometry of that hole at all,
right,
especially with the light load we're putting on it.
Yeah.
All we're doing is we're just changing the surface. So yeah, if we're using 4 stones, we might have to give it one more stroke than if I was using 6 stones. But essentially, we already established the geometry of that hole with the original 6 stones we ran. So that's something to be taken into consideration.
And 6 is better than 2.
Yeah.
So the more,
basically, they used to hone with 2 stones. You can still probably find them out there. 2 stone hone heads. 4 stones pretty common. I mean, it was around before I was born, and will be continued to be used well when I'm gone. But the fact of the matter is the more stones we put in the hole, the more we can disperse that pressure, which is going to allow it to stay more round while we're honing on it. Excuse me, and that'll give us a more round hole. And as far as straightness, the big advantage of being able to stay straight is with the vertical hone, getting directly above the hole. We talk straight and round all the time in our classes. Really, the only way you guys would be with your bore gauge, you can't measure straightness. We talk about it all the time. We have that picture you have in your slides of the slinky. Go ahead.
It's round, but it ain't straight.
Yep, exactly. And if you were to measure that with a bore gauge in every position, it would measure exactly the same, but it definitely ain't straight. So basically getting directly above the cylinder helps us eliminate a little bit of the banana shape or the rainbow shape that you might be putting in there from the rocker style machine. So those are some of the big advantages of going with a vertical honing machine. We can keep the cylinder straighter, and as far as roundness, the more stones we put in the hole, the more round we can make the hole. Not that you can actually verify that even with your bore gauge.
No. So the nice thing is this machine gives you the bore geometry you need, and now we have the surface finish measuring equipment, so that way you can choose the correct abrasive. That way you're not having to guess what abrasive you need. You can use a profilometer connected to the software. You can come in here, you can test it out. You can kind of pre-flight it, if you will. Make sure you're going to get the RZ you need with that abrasive so you can tune it in, because that's something you didn't mention, is that with, let's say you had to go 4 or 5 thousandths to size to clean it up. You can take out a thousandths with an abrasive and then go check your RZ
see exactly
to see where you need to be.
at.
So you could have a handful of abrasives to choose from, pre-flight it, figure it out, come up with your recipe on one hole, and then the machine just replicates it over and over again. So basically perfect that one, and then it will just repeat.
Exactly. It's one of the very nice advantages with the CNC machine, just the repeatability and being able to create that nice soft plateau finish without changing the surface finish at the top. We're able to give you a complete package, basically.
There you go. So that's the cool thing. As we noticed today, the hardness of the block is going to definitely impact what the choice of abrasive needs to be in order to get the correct surface finish, and you just saw it.
For a new product spotlight here at the Engine Performance Expo, Randy Neal from CWT Industries is back. Randy has been with us at every Engine Performance Expo. We keep the streak rolling. It's all about balance, Randy. It's all about balance.
Well, balance is one of those parasitic events that takes place in an engine that if you don't take care of it, it's just you're actually killing horsepower. So the balancing doesn't make power, it unleashes power. So the key is getting to the point that we can take all the parasitic loss out. Well, that's the mission statement of balancing, pure and simple. But as you go through this thing, one of the things we've evolved in some of the cranks, we're starting to learn and get a little bit better. If we lower the weight of the crank, then that also nets more power. Well, we have developed software now that added to our system. And keep in mind, our bases are about 5,000 pounds, so we have a good stable platform. But what we want to do is have a means for the technician to understand, hey, I want to reduce the gross weight of the crank. And so he always had to guess. He'd put it on a lathe, spin it on, oh shoot, take it back. Now those days are over. The software now can calculate the surface area against whatever the unbalanced force is. Let's say 50 grams, all right, or 150, I don't care. But the bottom line is it'll do the calculations quick, so we just eliminated the mental gymnastics of the process. Bottom line is everything that we do in balancing unleashes power, but it is through the benefit of reducing mass, where your polar moment is decreased and the moment of inertia is decreased. Now these are words that people may not understand. Just understand it'll accelerate faster and decelerate faster. Well, that's a net benefit. So it's easy to do. With the computer now, you can sit there and plot the counterweight shape, ask for the result, and it'll spit that out to you as quick as we're just talking. So no headache.
Well, to me, that's the biggest part, is that, yeah, you can talk about balancing. We've talked about it a lot in the past, and there's more to come even on this expo about it. But going from knowledge to putting it into practice, how do you go about knowing how much to remove, where to remove it, so that you get the proper balance? Because I think the idea of something being in balance just kind of makes sense. It's kind of like intuitive, like, yeah, should probably do that. But how you get there is tough. And I know when we were doing the Engine Performance Expo, LS engine, we came down and we went through it, and it was like, wow, this is like stupid, dumb, easy to be able to get it right. And the proof's in the pudding. I mean, you'll watch it tomorrow, because you're going to come back and watch tomorrow. You'll see the engine running tomorrow. This thing has got 180 something pulls on it. Runs over 1,000 horsepower. It just runs and runs and runs. And I'll show you the oil analysis tomorrow. The bearings are fine. Why? Because it's in balance. We don't have these things going crazy.
Yeah. Listen, the amount of force that unbalanced can, just to give you an idea, if you had 100 grams, right, and you put it on dyno, it'll run. It'll even make power. However, it won't run long. All right. Now, the net benefit of that is simply this. You want to make sure that you build a product that the customer is going to enjoy, but it better live. I don't think there's a single customer out there that likes to see an engine that has a short life cycle. So what we've done now is we've added an avenue that takes the mental gymnastics out, that'll take the job, make it easier, process faster, and in this case, documentable results. So this is math 101. Now, you can do it yourself. I mean, there's some skilled technicians, but you don't always have to run uphill all your life. You can take the easy road, right? Yeah. And that's all we've done. We're just making it easier, faster, but more importantly, deadly accurate. So that's what matters.
Well, that's, again, the ethos of the expo.
Yeah.
Hey, do it right. There's a way of doing it better than what just runs.
Right.
But if you can do it faster, with less time and with less waste, and more accurately, well, that's the home run win.
Oh, absolutely. Look, time is our nemesis. I checked on this, and I still think that's a 1224 gig.
Yeah.
Well, you have choices. You can process it accurately. That's number one.
Yep.
All right. But why waste time when you have the technology available? And that's where we're at. See, everything that we have on all of our systems, that's embedded now. It's automatic. Not just shaping the counterweight, but also clipping the counterweight. So I would say give us a call and let us show you how that works. It's really cool stuff.
Latest, greatest software available with new systems. What about legacy systems that are already out there? Is it easily updatable?
Anybody that has the original 5000 series, we will back that for free. Just that simple. Now, again, original owners. Let's keep that clear.
Yeah.
All right. But at the end of the day, no, our mission statement is always move the entire process to a higher level of more efficiency. That's our commitment at CWT.
That's the expo right there.
I've learned if it rotates, it can be balanced.
Oh, absolutely.
Yeah.
Yeah.
And if it doesn't, it has that little baby hammer thing.
Oh, thank goodness we talked up. I was going to bring up the baby with the hammer destroying everything.
It has to be in there, right? Because it's so true.
And now it's there. All right.
So.
Huge moment here at the Engine Performance Expo. Each year, we like to honor and highlight the greatest of the great, and Lake, we're going to continue that trend right now.
And we're taking it to a whole nother level. So right over there at that table, which you can't see from that camera angle right now, is our round table. And last year, at the final round table, at the end of the day, we put a stake in the ground and said, you know what? We're going to go beyond this Lifetime Achievement Award. We need to do something to really honor the heroes of the engine building business. There needs to be an Engine Builder Hall of Fame.
Yeah. No, I mean, and you have to understand, growing up in this industry, you know, I caught in the very tail end of a very magic time.
Mm-hmm.
You know, when some of the first people that I got to talk to was like Bob Glidden. You know, and you think about, I mean, Bob cussed me like you wouldn't believe and stuff like that. They're, you know, you get to meet these people and they're heroes that you grew up reading about and everything like that. And you start learning that this community
it's known inside the community who the real players were.
Right.
And these guys, they not only did amazing things, but they had left a legacy behind them. They trained people. You know, we've looked at, as you've doing interviews, you'll find out, well, this guy worked with this guy who taught this guy and everything like that. And it's like these coaching legacies. It's like these family trees. And there needs to be a place that's not just about the results on the track. There's places for that, right?
Yes, absolutely.
NASCAR Hall of Fame, NHRA's got Hall of Fame, everything like that. But where is it for our sport, the engine builder sport, to recognize the people who laid down the foundations that we build on today?
I couldn't say it any better than that. So here's what we need to do. I think we need to go ahead and show the videos here in just a second, but kind of to preface the videos, what we've done is we've broken this down into 4 eras. So, because to make it things fair, right? So we have the pre-war era. So basically all the guys who were before World War II.
Right. And they lived in a very different era, because pre-war, there weren't any of these cylinder head manufacturers. If you had an idea, you created a pattern, you melted aluminum, you poured it into sand, you built it from hand. And so these guys deserve a place of their own, because that's a whole different deal.
Oh, completely different ball game, right? Well, then you have the post-war era, because now you got the big automakers, you got mass production. It's a different thing. So we have the pre-war era, we have the post-war era, up until about like 1960. Then, like when Mike was sitting here a minute ago, well, then that was the kind of that golden age where things really started to take off.
Welding on a TRW piston, that was worth the trip up here in and of itself.
Yeah, it's like, wait, time out. Did I hear that right? You know, that was those guys in that era, you know, and that lasted until probably the mid 70s. Then you got companies like Comp Cams and stuff. Everyone's really coming in. There's more aftermarket parts now.
I mean, the first year of PRI, you could have put this building we're in today for Engine Performance Expo could have fit 10 PRIs, right? You know, it was tiny. You go in today, it's 1 million square feet. So what was it like during that era as it blew up into what we know today as the aftermarket industry?
Right. So then you've got that next group that kind of came 70s to the 90s, like you said. So that's our group. So what we're going to do is we're going to show you only one person in the inaugural class from each of those eras. And then tomorrow we're going to come back and we'll show you the second one. But go ahead and watch the video now, and we'll come back and we'll discuss our selection in the end.
Our entire industry, Lake and I have real jobs. We all have real jobs because of the work that was done by guys in this room. When Harry Miller was building these engines, there wasn't a aftermarket. There wasn't any of these. There weren't Edelbrocks. There weren't Winfields. There weren't Iskanderians yet. He made all of this by hand, basically. So all of these engines, when you think about, double overhead cams, this double overhead cam engine was built like this. All of these are neat. Like, these engines don't have head gaskets in them. They would actually have to come up from the bottom and machine the valve seats in here, because when they boosted these, they had so much power they blow every head gasket. So they're like, okay, we'll fix that.
I got yelled at for that in the Ed Pink video. I said, "Is that an offie head?" They're like, "You don't know offies don't have heads." I'm like, "No, sir, I don't know that. I'm not 60 years old."
Here is your offie. Yeah, that is the little 110. Here's your 270 offie.
When did they realize that maybe making the head removable would be easier to work on?
Mid-50s. I think the gasket technology had to come around. There's a lot of things that go on here. Carburetors, they weren't good at metering fuel back in the day. So they had these updraft carburetors. So as everything got hot in here, it made the fuel more like lighter and vapor, and it'd be able to distribute better and burn better. You have to realize this is really before gasoline was gasoline. These early motors were low compression.
Pre-tetroethyl lead.
Right. No, there was nothing like that. So you have to understand, you have people like Rockefeller who were big on prohibition to get the bootleggers out of the gasoline market so the oil guys could have more of it.
Yeah.
So everything that we take for granted that just existed
it didn't exist back then. But I mean, think about these guys running the big superchargers on the front, and what'd you say, 10 times today or 20 times today? That no ideas are really all that new. We've just gotten the execution better.
Well, like this engine right here is a 1953 Studebaker with 4 valves per cylinder, overhead camshafts, Hemi-headed. I mean, what's your Hondas and Toyotas today? 4 valves per cylinder, overhead cam, hemispherical combustion chamber. This was 1953.
Yep.
Right.
Agajanian, that's a familiar name too. We just did the Mike Carr Museum.
Yes. Yeah.
Yep.
The same people keep it up over and over again.
Yeah.
If you look at this, I mean, check out this draft table imagine the talent it took to go in here and be able to conceive what's going on in 3 dimensions. There wasn't any CAD at the time. They weren't able to rotate anything.
No rapid prototyping.
They had to do this by hand. I mean, and when it came time to make it, you made a sand casting, you poured it, or you had to machine it out of billet. So these guys were, man, they were just so good at what they did.
He wanted to make good stuff, actually. He wanted to make boat engines, he wanted to make automobile engines. Actually made some fantastic engines. The person who helped him the most was Leo Goosen, because Miller would say, I need this, here's a concept. And Leo would write it all out and put it on paper, and they'd get machined and everything worked. I had the Packard Wire Special car in my shop in Redwood City. It was a Miller race car with a supercharger on it. We were going to restore it for the owner. Right now the Packard Wire Special is in the Smithsonian. That engine was pretty cool. All the stuff on it was really nice. The machine work, he always had craftsmen working on stuff. Harry Miller was always going up and down, making a lot of money, losing a lot of money, making money, but he really loved what he was doing.
Okay, I'm going to tell you a good story. Last year, for Eske's birthday, they did a birthday for him at the Peterson Museum. And they invited a few people to be part of a group honoring him. There was about 6 or 7 of us. And I was sitting right next to Ed. And everybody's saying their little thing about him. And all of a sudden, Eske looks over at me and he says, you know something? He says, do you remember when you used to be an usher at that theater? And I'm thinking, this goes back to, I was probably 14 years old, maybe 15. And there was a theater on Adams Boulevard, Adams and Crenshaw Boulevard, called the Bard's Theater. And I would work there as an usher. And Eske came in a couple times, and I would take him to his seat, usher him to his seat in the movie house. And he said to me, he said, you know, I remember. And he brought that thing up and told me. And I told him, I said, you got a hell of a memory. Because as he said, and I remembered, yeah, I did work at the Bard's Theater. And I know I was really young, 14, 15, maybe 16 years old as an usher. And I ushered him to his seat a couple times. He and I were 10 years apart. He's 10 years older than me. Now, his life is a pretty open book. He's not a secret person. He's very good with people. He knows his friends, and he knows the people that are just hanger-oners, that really aren't friends, they're just acquaintances. But he knows his friends, and he and I have been friends for a lot of years. I can remember back when I was a young guy past the Bard's Theater deal, and I used to ride my bike, and when he was living at home with his parents, he had a machine in the garage. And in those days, garages didn't open to the street, they opened to an alley. And I used to ride my bike back and forth across the alley, looking in at his little garage, wondering what he was doing. And I was always afraid to stop and go in and talk to him, that he might run me out, and then I wouldn't be able to do that anymore. So I'd just ride my bike up back and forth in the alley, looking in his garage to see what he was working on. But I had no idea what he was doing. 59, 58 right in there. I had a repair shop that used to be Frank Barron's on Venison Island. And Esky would come to see me every once in a while. And it had a little driveway. So he'd pull up on the driveway and his car would be like this. He'd be in an old Cadillac. And he'd get out of the car and oranges and apples would fall out and roll down the driveway. And he would in fact, Sylvia has a picture of one of his cars that finally got to the point that he had to park it because there was no room for him to sit. He doesn't throw anything away. And I'll tell you a very cute story. One time when he was still working full time, I needed to go and see him. And this is back probably in the early 60s when I first opened my first engine shop. And I went to the front desk and Norris Baronian was working for him, who later was Baronian Cams, Norris Cams. But anyway, they all knew me and I knew everybody there. And I said, I came in to see Ed, okay. And they took me to his office. And they sat me down in this chair behind his desk, on the front side of his desk. And I'm sitting in the chair waiting for Esky to show up. And all of a sudden I'm sitting there and I look up like I'm looking at you and I see this little smoke ring go up in the eye. And I stood up and I looked, it was Ed. He was sitting at the desk, but he's got so much junk piled on his desk, I couldn't see him. And all of a sudden he was smoking a cigar and the cigar smoke went up and I realized there's somebody there. And I get up and looked and there he is. And I says, how long you been here? He says, I've been here a long time. How long you been here? I said, well, I've been sitting here for 5 or 10 minutes waiting for you to come in here. I've been here all the time. And I said, well, he couldn't see you. And he was in everything, in the camshafts and lifters and push rods and valve springs. And back in the day, he was the go-to guy if you for camshafts or whatever. And he had his brother was one of his cam designers. They had him locked in a room all the time while he was doing all his designing. You know, the thing is this, that he knew what needed to get done and he got the right people to help him do it. And he didn't nickel and dime stuff. He did it right. He was good for the sport and the sport was good for him. I think it was a two-way street. He wasn't a guy that sold cams and took the profit and ran. You know, he took care of everybody. He took care of his customers, and now he's the first one with real race T-shirts. He was the guy. His cams were good, his springs were good, all this stuff was good. He did good PR work. He took care of his people, and the good Lord's taking care of him, letting him live so long. I would say Esky earned his with his performance and his promotions. And Vic did it flat racing and making racing equipment for the flatheads.
What a character. I go out and see his son, Richard Ron, and of course had to catch up with Ed. Well, Ed eats at the same hamburger place he's ate for the last 100 years. And so we had to go down there. And what is so fascinating about Ed, now last time I saw Ed, he was probably, I don't know, 92 or 93. And the first thing Ed wants to know is, what are you doing? And he wants to know, what are you doing on this? And then he'd say, you know, back in '38 on this engine, we found, I mean, Ed's mind is just, you can see why he was so successful, because he never stopped thinking and never stopped inquiring. And I mean, I can't tell you, one of the fun things about Ed is he hated trash. And so he'd get an old car and he'd start picking stuff up off the sidewalk and putting it in the car. And I go to Rich, I said, it looks like the trash is up covering everything. Oh, he says, yeah, I got 10 more cars in the back Ed did said, I go, really? And so I got there another time, and he had part of his hamburger, and he was feeding the pigeons. And when he got done, he took this wrapper, went over and threw it in his new trash bin at the car. And Ed obviously came through the Depression, and nothing was wasted. Everything was saved and reused, and just how Ed carries himself in that manner is amazing. I mean, not many people at his age are still interested in everything else. You know, if it's auto-related or an engine or something, he wants to know about it. And just a super nice, never had an opinion if somebody was bad or not right or this or that, just a wonderful guy. And of course, the same thing flowed through to Richard and Ron, both great guys. And but Ed won off. I can't believe he's still here, but it's wonderful he is.
I had an absolute joy at PRI a couple of years ago. We used to go sneak around and miss breakfast lines, go to the subway that was back behind some of the hotels. And I go into the subway one morning, and it's Dave Henniger and myself. We get up there and we sit down, and who sits down in the booth next to us but Ed Iskandarian. Ed Iskandarian had a presentation he was going to give at 10:30 that day, and it's about 8:30 in the morning. He proceeds, finds out we had comp cam shirts on, you know, and then proceeds to go over his presentation for over an hour, talking about everything that's going on in an engine, how the intake stroke really works, what's going on overlap, about wave tuning. You know, I am listening to a guy who's probably at the time about 97, 98 years old, who never had the modeling and the ability to test that we have today. And yet he's going through all the fundamentals of how the camshaft is the conductor of the entire engine airflow package. And the amazing ability he had, it was like watching the pinball wizard. Because when we talk about deflection, we can measure deflection. When we talk about port velocities, if we can't measure it, we can model it really, really close. So we have all of these tools today to try to understand what's going on. Ed just saw it. That ability to look inside an engine set Ed apart from his entire generation, and probably set the whole performance aftermarket Valvetrain going. You know, clearly Ed Winfield was amazing. You had people that were doing great camshafts before, but really they were just adding some duration to camshafts, adding some lift and moving them around. Ed Iskandarian took that science, made that into a science and an art form by figuring out what's going inside the engine. Why does the intake need to close later? Why does the exhaust need to open earlier? What is happening under overlap? All of this stuff was really ignored before Ed, at least to what we can see, that Ed set that and made that to go. A lot of people would say, you know, I was brought up under Harvey Crane. I spent my time going down to Daytona Beach, Spruce Creek Drive, going over to Harvey's and learning from Harvey. Harvey Crane was the artist of cam lobes, but he just designed a cam lobe that was the most beautiful camshaft lobe he could for that lift and duration. The difference between Harvey, who was as good of a dynamic lobe designer as you could ever imagine, trying to get a lobe that would be stable to a certain RPM at these specs. Ed, in my mind, was even better for our industry because he could figure out what size it needs to be. Together, when Harvey was able to see what Ed had optimized the specs and to design a better lobe, that's how Harvey wound up taking a lot of customers from Ed. But make no doubt about it that Ed had the fundamental understanding. He was probably 30, 40 years above anybody in the field at understanding why do we want to add duration, why do we want to add lift, what are we actually doing in the engine when we change cam specs. And for that reason, first ballot Hall of Famer.
Ed Pink. Ed Pink, of course, everybody knows Ed Pink. And I was running the GTP program and had done the V8 engine. I had done a magnesium block, aluminum heads, carbon fiber everything. And of course, this is in mid-70s. And the whole engine with the ECU weighed 268 pounds. It was 305 inches. And we were making not quite 600 horsepower with it, which was pretty good. Anyway, we had some issues, and I asked Ed, would he take our current engine, look it over, give me some suggestions. Well, that led to Ed taking the program over. And Ed, just super clever guy. The first thing he said, well, why is the engine together with silicone? And I said, because people aren't using the O-rings that are supposed to go in there. Oh, well, we'll never do that silicone again. And you know, Ed was so specific about no leaks, easy to take things apart, how do you work on it? An amazing shop, an amazing person. And his record over the years, I don't think there's many people who even come close to Ed. In the wins, everything. Anyway, Ed boosted the program with his expertise. And wonderful person to work with. Never raised his voice, never, you know, he just worked and made it happen. And the people in his shop were excellent, which you would expect. Ed demands the best, you know, so I just saw where he put his last engine together, which was pretty cool. And Ed, what a career, what a person, great individual, and can't find a nicer person.
Probably one of the coolest things that happened in my career is being able to call one gentleman a dear friend. Ed Pink is that guy. You know, Ed Pink was called the old master when I was probably riding on with training wheels. Back in the 70s, you see these advertisements, Ed Pink, the old master. And you see the advertisements with him doing, you know, this plug wire, or you see him in these yellow jackets. And, you know, Ed was just the guy back then. But then you meet this guy and you start talking to him, you realize that not only was he the master back then, but Ed Pink has a mind that's just absolutely amazing. When he would get into a project, it didn't matter whether it was for a Porsche, it didn't matter whether it was a Land Speed, it didn't matter whether it was the FE Fords. He went to work for Toyota, he did all the work on their midget, he went and did the stuff on their drift cars, of course all the work that he did with Infiniti on the IndyCar IRL stuff. Any engine, he could just sit there and look at it and massage it and rub it, and he'd always find more power. And I remember, like, when he was working for TRD, you know, he and I are joking around, we're going to take a sprint car motor and put it into one of these little Toyotas and put this driver behind the wheel. And it's pretty amazing because we're like, okay, this is a 410 World of Outlaw sprint motor. You know, this guy is going to absolutely lose it. So we start playing with it and everything. We get, you know, no rules, so let's make a longer stroke, let's get all this stuff. We put this absolute monster of this engine together. And they get out there and they're doing filming on the Canyon Road out in California. And the driver gets out and said, yeah, it's pretty good up high, I need some more down low. You know, and so, you know, Ed calls me on my cell phone from the event, and, you know, and the thing is, instead of just telling him to shut up, Ed was the guy like, okay. And so we went and totally redesigned this Valvetrain system to work with that head, to take this 450-inch sprint car motor and focus the peak torque for the transients down around 3,500, 4,000. And some have still turned 9,000. And I remember working on it. I don't think there was anything like that at the day. And we learned things in that sprint car that we could have, in the drift car, that we could apply for sprint cars, because you start thinking about it and go, sprint cars don't have a transmission, they don't have a clutch. They're, if somebody gets on the brakes and then can drag the field down and then shoot off from the line, hey, here's something that Ed was playing with a drift car, which we all made fun of back in the day, and applying the same technology to a sprint car. The midget motors he built probably outran everything, on the track. You look at just the way from the single overhead cam, the camera motors, he was the guy from that. We made special cores for him for that. Just anything you could imagine, and just total insight. I guess what happened later in the NASCAR days is that to kind of save the engine shops, their intellectual property, what they started to do is make engine builders into specialists. So you had one guy who's like, this guy's a Valvetrain guy. Then you had another guy, he's a top of the piston guy. Then you have another guy, and the top of the piston guy is probably really close with the combustion chamber guy. Then you got another guy that's rings and bottom of the piston. Then you got a rod and crank guy. You've got a cylinder bore guy. You've got everybody who has these different levels of expertise in a certain small window of the engine. What makes Ed Pink and his generation special is that you could ask Ed about any question on an engine and get a great answer. If you want to ask him about rod bolts, he knew about rod bolts. He knew about connecting rods. He knows about counterweights. If you want to talk to him about cylinder bore finish or rings or pins or how the bottom of a piston should be constructed. If you want to talk about the valve guides, if you want to talk about valve seats, any part of the engine, and just look at his son and how much success he's had in the carburetors. Ed Pink may be one of the world's best carburetor guys, and he wouldn't even consider that on his resume. When you reach a level where your weaker skills are world class, that's when you get to be called the old master.
John was good friends with Mark Heffington at Cam Dynamics. Now, where that started, I don't know. I was in the service when all that took place, but John and Mark were good friends. So this is before comp cams, so we were still involved with Cam Dynamics. And when I got out of the service, I had decided that I wanted a race car. This is in my career when I still thought I was going to be a racer, and I hadn't figured out that race stuff is made to sell and not to use. So I had decided I wanted to be a racer and started racing a little bit and wasn't very good at it. I had a 69 Camaro convertible that raced in Superstock. John had one very similar to it. And he would kick my ass. Just terrible. And we knew each other and were friendly with each other. And finally I asked him for help. And so we started doing a lot of stuff together, and he worked on the car part, not so much the engine part, but the car part. And that helped a lot. And then we started working on engine stuff together. This is during the RHS days. And actually completely during the RHS days is most of my dealings with him. But we did a lot of crazy things. We'd go to Bowling Green and test and probably make 100 runs in the car one day at Bowling Green, just testing stuff. Crazy, fanatical, driven tester John was. And he was probably the most serious. You know, John had all different kinds of projects he was involved in, from being the fastest Corvette ever to that crazy race they do out in Utah or something where they run 50 miles or the drag racing. I mean, whatever he did it at 134%. Whatever, he did it all the way. And I was only involved in the drag racing side with him, and that about wore me out. It used me up. But we got to know each other really well. There's so many stories to tell about him, but he was just really, really good. And I had to race him one time somewhere. And this is where I came home and learned about front shocks. And he had never worked on front shocks so much. And I would tweak on my front shocks and the lift and the rebound. And I outran him one time. And he said, you're cheating. You've done something to that engine, you're cheating. And I said, nope, hadn't. I said, it's all in the shocks. I don't believe you. I said, well, whatever. So I said, here, we'll take these shocks off, put them on your car. And we did, and it picked him up. And so we had that whole relationship worked out very well. And I finally quit the racing, and he went on and did many other types, and we worked together along the way. And Billy probably worked with him more on engine stuff as Billy came along and became more and more a part of Comp Cams. They got really close, and saw that develop, and that was comforting to me to watch that develop and carry on beyond me. And I'll say one big difference, John was very analytical about what he did. He studied everything. He wouldn't, as Bob wouldn't understand timing events of a cam, John understood every event, what it did, why. And he didn't really know how to move them around, but he understood what he wanted it to do. And he'd come to us to say, here, this is what I want to do. Now you go do it for me and give it back. So they were very different in those respects, but very similar in the ways that they were just possessed with doing 100% of what they knew how to do. Yeah, as far as I know, he started in drag racing and went on from a business standpoint to do his street Corvettes and all the other things. And John may have been, maybe next to Carl Wagner, may have been the worst businessman I ever knew, because he just could not figure out how to keep any money. I mean, he'd either spend it on racing or spend it on women or whatever, but he enjoyed every minute of everything that he did and never worried about money. And after he passed away, his brother came in. His brother was a very successful businessman, and he had the Castrol dealership in the southeast United States on the industrial side. Very successful. And he cleaned up the business and got it all straightened out, and he would just shake his head about John and all of his business dealings, but he was really, really good at all the other stuff he did. I'll tell you one little project that we started, and it's kind of funny how it ended, but when in Superstock, we had to use stock castings for the heads at the time, no porting. And so we started thinking about acid dipping these heads. And neither one of us had ever done any of that. So at the time, he had a little engine shop in Decatur, Indiana. It was right beside a river. Right behind his shop, the bank went down to the river, little small river. And we went to the hardware store and got a tub and put acid in it, and we put the heads in there and said, I don't have any idea how long they need to sit, but we'll go down to the Pizza Hut and have lunch. So we went to have lunch, and all of a sudden we hear this noise. And it's the air raid sirens are going off. Holy crap, you know, and we look down the street, and there's this big orange plume. Damn. So we hauled ass back, and the acid had eaten the brass plug out of the tub, and the acid had run down into the river and got onto something else in the river and was creating this massive orange thing. So we real quick, before anybody got there, had to clean all the mess up and hide it. And all of a sudden, everybody's coming looking for where this stuff is, and we're just saying, we don't have any idea what's going on. And John was able to do it with a straight face. And we said, we need to get out of town. We got to go. So out we went and let that whole thing settle. But that ended or at least ended my development of acid dip cylinder heads. But that was a pretty funny thing that we did early on. And it just shows you got to try crazy things sometimes. It turned out people understood not to use brass plugs, and they figured out how to acid dip, but I never did do it. We switched gears at RHS before that. You know, John was probably one of the nicest people that you'd ever want to meet. I mean, he wanted to help everybody. And he would help everybody. He would do anything in the world. Aside from, if you pulled up there a race, he wanted to beat you. No matter what, he wanted to outrun you. And I don't know if it's as much of a story as it is just a statement about him. A word about our relationship. When he got hurt in California, you know, he crashed his compact, whatever it was. I flew out there the next day, and he was in a coma. He couldn't, I mean, it was a tragic way that all that happened. But I stayed with him about a week and let his wife Cindy go off and get a breath. But that was a tough loss for me because he was so young and so energetic and so go do it. And his smile, the smile that John had, in every picture you'll ever see of him, the smile just melts you. Even when you'd go to him and say, "Why did you write me that bad check?" The smile, you'd just say, "Damn, I wish I hadn't done that. I wish I hadn't brought that up," because it melts you. You know, one of the things that got him a lot of press was about 1980, 79, 80, somewhere in there. At the U.S. Nationals, he had a Corvette Superstock car that was lightning fast. And they used to allow a time trial Monday morning before the final eliminations. And he went up for that time trial, and when he was leaving the line, the torque of the engine just pulled the side of the block out. This was before we had all front mounts and all that. It had regular side mounts, and just cracked the block, pulled that out. Everybody else would have said, you know, hell, it's 4 hours before we have to run. Not John. He's sitting there thinking, and there's a helicopter doing tours around the park. And he thought, I have a block at the shop that's all ready to go. And it's 30 minutes away by helicopter. He's thinking and calculating, and John was really smart. He's a mathematician. And he did the math, and he said, we might can make this work. So he went and hired the helicopter to fly him to Decatur. They landed, they'd called ahead. The police had the street blocked off. This was, they didn't realize we were the ones that created that massive mess, but they had the street blocked off, so he landed the helicopter, went and got the block, put it on there, came back. Well, while he was gone, 5 or 6 of us got together and made a plan on, we pulled the engine out, cleaned and laid everything out, got all the tools laid out and everybody knew what they were going to do. He came back with a block. We got it assembled in the car, in the staging lanes, 10 or 15 minutes to spare. All's good. So they call him up there to run. he started it, and the carburetor was flooding out. The little piece of silicone where somebody had put a bolt in the line to keep it from leaking, a little piece of silicone came off and got under the needle and seat. So he couldn't make the run, so all that was wasted. But NHRA, contrary to the way they normally do things today, they allowed him, since everybody was following and knew what was going on, they allowed him to clean it out and go make a run, and he was like a full second under the index. It's just, he would have won so easily, but it's just, you know, fate wasn't going to be his friend that day. You know, it just wasn't going to work. So I fast forward until the day of his funeral. And he had, his shop was in Decatur, and next door was a Kmart or Walmart or something. Well, he bought that building. It closed down, and he had bought that building. And had, all around the front of it was like a foyer thing. I don't really know what they intended to do there, but they had laid out all of racing memorabilia all through that. And Jeff Smith was there at the funeral, and Jeff and I were an integral part of that engine swap thing. And we're going along looking at this memorabilia, and both of us just stopped and locked up in our tracks when we saw all the pictorial of all this stuff. And I think they even had the piece of the block that pulled out and all this. And both of us just cried like babies while we're, you know, because we love that man and we loved this and what was going on. And it was, that was really something to see that right there in front of us. It just really got to both of us. And as I'm sure it did others, but especially us.
John Lingenfelder, we probably have known each other 30-something years. And the one thing about John that was amazing was his smile. He just melted everybody. Plus, a very, very sharp individual. John was always thinking how to get more power, and was always thinking, nothing said, oh, I can't do that or that won't work. He tried some crazy stuff, you know, and that's what made John so successful in his business. Where I came along, I was running the Pontiac program, and the four-cylinder Pontiac was the first deal for the Fiero, and then it went into NASCAR, then it went into road racing, and we went against an IMSA against the 924 Porsche, which had won everything for the last 200 years. Anyway, and what I couldn't understand was the four-cylinder was making more horsepower per cubic inch than what we could get out of our V8. We had the NASCAR head done in the big block, but couldn't come close. And so I called John and said, look, we're making over 2 horsepower per cubic inch. I'd like to see if we could put 2 4-cylinders on a V8. Think you could do that for us? And he goes, well, what do you think for the head gasket? I said, well, you're going to have to fake the head gasket because the water hole, nothing's going to line up. And all we want to do is be able to run it for a short period of time to get some power figures on a V8. And he said, sure. So anyway, I sent him some finished heads. And of course, John had to work out how to get the push rods from the V8 up to the cylinder head, which was a challenge. But luckily, because he wasn't trying to run water under pressure, you could kind of cheat things around and do it. Anyway, John called me several times and said, I just don't know if I can make this work. This is more difficult than I thought. And I said, well, John, we're not under a time frame here. It doesn't have to be next week. And sure enough, John finally got the thing running, and he could fire it up. We'd have some oil temperature, and then he'd make 2 pulls with it. And of course, at that point, it was pissing water out, and you know, we'd shut it down. But the point, what we learned was, I couldn't understand, at that time, our NASCAR head was 23 degrees, and the 4-cylinder was basically 0 degrees. perpendicular to the piston. And of course we ran a flat top piston. We never ran a dome. And so anyway, all of a sudden John's getting some power numbers that are big. I'm going, I kind of figured out that the cylinder, the more you straighten the valves up, the more efficient the cylinder becomes. And that's why we've gone from a 23 to an 18 to a 15 to an 11 degree, and I hear they got some 7 degrees out there. And so anyway, we kind of backed into doing it, but if it weren't for John's perseverance, you know, and his ability, we never would have found out the really reason why.
You know, if we want to start talking about John Lingenfelter, he's one of the most interesting people that's ever been in motorsports. John had a passion for life that was really almost unequaled. The broadness of what he was able to do was also something that was just unheard of. You know, there's the side of drag racing that he really loved, you know, whether it was his green Corvette, whether it was all the complimentary racing, pro stock truck. I mean, he did such a great job with that. Then when it came to the Sport Compact, he started taking the Ecotec engines and make those make unreal power. By the end of what they were doing, they actually had bolts going from the pan to the head, sandwiching the engine together to keep from running over the crankshaft. But from my side, John was the guy when I was very young who I would call and ask questions. John was the one who would try anything on the dyno. When people started talking about firing order, John called up and he goes, how many firing orders can we do with a V8? And it's like, well, okay, do you want cross plane or, you know, flat? Well, let's look at cross now. And then he ordered one of every cross plane firing order, whether it was the center throws this way or that way, every firing order you could do. And I mean, some of the firing orders were bizarre because one of the firing orders will run all the cylinders down one bank and then all the cylinders down the other bank. And it made for a really odd combination. But you know, he was doing that before anyone in NASCAR was doing it. This is at the time when people are just playing with 4 and 7 swap. You know, when you have Rear, when you have you know, Steve Schmidt, you've got people who are just starting to play with 4 and 7 swap in pro stock. And within a couple of years, he's tried every possible firing order combination. One time, like when John was working with things, he would keep running the lash looser and looser to see if it would work. And you know, one of the times we're sitting there and, you know, I designed something around 30 lash, and of course he tries, you know, 35, and then he tries 40, and then he tries 45. And, you know, and it was like a little bit better at 45, so he had to try 50, and then it was worse. But you know, if you start looking at the velocity when it was open close the valve, it was terrifying me. And so when we came back and we started doing tight lash camshafts to try not to have the wheel so far away from the lifter, I remember Gordon Holloway, who's one of his dearest friends. So you've got Gordon and John, and they're going, Billy, how much lash do you need to run on this? And I was like, well, negative 15 thousandths. They're like, well, how in the heck do you run negative? It wasn't quite that. But how do you run negative 15 thousandths? I said, John, I don't know, but you're going to add 30 to whatever I say. So I figured I'd start at negative 15 and get you a chance to get up to positive 15. John had that idea. He probably blew up less engines on the track than anybody I knew. He would test everybody else in pro stock. If they were going 9,200 on the track, they only dynoed to 8,800. And they're going, okay, this last 400 RPM, I'll just let it kind of lay over. And you know, you'd see people blow up engines on the track all the time. John was like, if I'm going to run at 9,200 on the track, I'm going to run at 9,400 on the dyno. Now, just like the firing order side of things, John wasn't trying to build business cases for why you do something. You know, almost everybody that I've ever dealt with
deals with like, how do we make money off of this? Or how do we win races off this? What are we trying to accomplish? John wanted to know. And whatever it cost to know, however many blown up engines it cost, however many tests it took, he was going to figure out how to make money later to pay for his addiction to finding out. And it was pretty an amazing deal to live in an era when you got to call up John on the phone and say, what do you think this will do? Because his mind was always going. He was just always tinkering, always thinking. And the last thing that, for our Engine Builder Hall of Fame, the reason that I definitely think John Lingenfelter should be a first ballot Hall of Famer is that he could do it in anything. There was a lot of people who could go and be successful in one venue or another. But John could go out there and, the reason he changed the U.S. performance world when he teamed up with Callaway to do that Callaway Corvette. Up until that time, the Porsches, the Lamborghinis, the Ferraris, that was the stuff. And ever since the Fords won at Le Mans, Americans were kind of like, well, you're a little bit knuckle draggers. So John gets in this thing, starts doing with the turbocharged Corvettes, and all of a sudden they build a Corvette that would absolutely take on the world. And it made the people at Motor Trend crazy. I'm sure there were people cursing him in Japanese, Italian, and German, But he is the reason, without that power, that car would have never done what it's done. And just to give you an idea of the confidence, and sometimes it's just overconfidence that John would have, is the idea, they're over there testing the Callaway Corvette, and he's like, well, let me in it. This guy's lifting going in the corner. This thing's got 10 more miles per hour on it, And you got a professional driver out there, and John, it wouldn't have mattered if it was Mario Andretti. John would have thought that he could have got behind the wheel and squeezed a little bit more out of it. And so something like that passion for motorsports, that passion for life, that passion for finding out, that separates John and puts him into what we believe is a first ballot Hall of Famer for the Engine Builder Hall of Fame.
The Engine Builder Hall of Fame is born. Amazing, amazing videos, the history, the credit where credit is deserved, and is now, you spoke it into existence.
Well, this is the best thing we ever did, right? We put that stake in the ground, said we're going to do it, and man, it's been worthwhile.
No, it's one of these things that you start going, oh, we're going to do this. But until you start it, and then you go, okay, and then there's so many great people. You can't do one of these without ruffling some serious feathers, right?
Oh yeah. I'm sure they're in the comments, it's already blowing up. You can't believe you didn't do this guy or that guy. And
we have 4 more tomorrow.
Four
more tomorrow.
So, exactly.
The initial
save
class.
Comments for tomorrow. This will be our initial class.
Will be 8 personalities, engine builders, for the Engine Builder Hall of Fame, but these first 4, amazing. Take me behind the scenes to the selection process, because that's always where no one wants to see how the sausage gets made. They just want to eat the sausage. We just ate the sausage and it was awesome. Tell me about how the sausage was made. This had to be very challenging and very difficult to make sure that you got it right.
Well, it was an iterative process that really began with defining what the criteria is.
Right. It can't be a popularity contest. I mean, you can Google search that, right? It had to be what engine builders changed the way we build engines. What engine builders had people that they mentored, who had the coaching tree, who had the people who came out, and how did they change our world? Why do we do things differently today because of them? Not just they're famous, not just they're great promoting, not just they sold a lot of engines. I don't care how many engines you sold. How did you change the way that engines are built today?
Well, you said it earlier, it's not about how many race wins you had, because there's other Hall of Fames for that.
Absolutely.
Whatever sport you're in NHRA or NASCAR or whatever, it's about that enduring legacy that you left an imprint. And You know, the very first video, the very first person, Harry Miller.
Yeah.
There isn't any of this without Harry Miller, a guy that in the infancy of the Indy 500 said, we're going to go do this. We're going to win. No matter what it takes, we'll figure out a way to win. And, you know, front wheel drive cars. And I mean, cars that are art. There's not many race cars in the Smithsonian, but one of Miller's is in the Smithsonian.
Right. And not only is the car art, every component of that engine is art. You know, that it was making the form right to do what it needed to do. And it was one of the things you'll see on every one that we've introduced in this first class, is none of them were there because they were out to make money or they were out to do this. They were out to win these races, to accomplish this. And they didn't care whether it was easy or hard. They were just going to do it.
Right.
Whatever it took, let's just do it.
Make it happen.
Yes.
You know, and the thing about Miller that kind of, again, struck me is that it's that legacy effect, too. That it's not just Harry Miller. You had guys like Leo Goosen. You had Ed Winfield. The Agajanians were involved. That whole group of people early they just kind of propagated and become the family tree of the performance racing industry we know now.
Right. You don't have Ed Winfield without Harry Miller, and you don't have Ed Escuderian without Ed Winfield.
Right.
So you've got to have him in there.
And apparently Ed Pink rode his bike behind Escuderian's shop when he was a kid. I'm like, that's still mind-blowing.
They're all hooked up together. They really are. You know, it's amazing.
Yeah, and then, you know, little fun fact, so when you were watching that video with Ed Pink, that 427 Cammer engine sitting next to him, that was his very last engine that he ever built.
Yeah, and he thought this thing over just 100 times. I mean, you know, he'd get started on it, go, no, I want to do this different. I want to do this different. And it was cool. You know, I get to be behind the scenes and know a little bit about what went on there. I mean, Ed Pink is one of my heroes. It's like one of these, that Ed Pink probably could have made our Engine Builder Hall of Fame 5 different times.
Right.
You know, for different seasons of his career. He's that amazing of a guy. And really, his heart and his passion for the industry and the people of it is every bit as his skill that he has in his hands.
And I just hate it that I never got to know John Lingenfelter. That time I spent with Scooter and yourself and John Callies learning about, I knew the name. How do you not know the name Lingenfelter? Especially, I mean, Lingenfelter Corvettes. I mean, recently they did that, 0 to 150 back to 0 thing. Yeah. And it's like, the Lingenfelter Corvette from 20 years ago was still faster than most of the other cars.
Right, and even some of the ones that he's not known for, he was doing the engines for. And those Corvettes put American product on the same stage as the best that Porsche, Ferrari, Lamborghini, anybody had to, you know. He's like, bring your best and let's see who's got it.
Yeah.
And those cars that he was involved with, they were at the top. But he had that passion in everything he did and touched so many forms of motorsports.
And it's crazy to think that the whole valve angle thing, that he was right there, him and Callies, and it's like, oh yeah, take this 4-cylinder Pontiac head and put it on a V8 and make a run.
No, there's absolutely nothing that John wouldn't have done. The passion that he had, the inquisitive mind, I mean, like they taught that $1 million smile and just bring you into it. And it was just like, you would do anything in the world. To see all his competitors huddled around his car, putting it together to make a round against them.
Right.
John was somebody who could smile at you and he would make you work your tail off so he could beat you. You know, but he had that passion.
Charisma.
He just wanted to go for it.
Charisma, passion, charisma, energy, and
contagious.
Yeah.
These guys were contagious.
Right. Which is why they are the inaugural class Engine Builder Hall of Fame.
Yep.
That's why they're there. That's why this is so fun. I can't wait for tomorrow.
4 more tomorrow.
Oh,
better
4
be
more
here.
tomorrow is going to be fantastic, and then there's going to be next year.
Yeah.
This is just getting started.
Yeah, no, excellent work, and an honor to see and be in the field. And there should have been a Hall of Fame, and there is a Hall of Fame just like that.
Done.
Made it happen. We'll do more tomorrow, but we're going to keep on rolling.
Yes.
We've got more to come. We're going to do a check-in with Project Pontiac in a few minutes as well. That is still going on. I've been out there like scouting it.
Yeah. But before that, we got to talk a little about balancing with our buddy Randy Neal. Balancing. If you don't believe in balancing, I challenge you. Try standing on one foot all day, and if you start to lose your balance, don't correct yourself. You'll find you probably bump your noggin, and probably if you don't believe in balancing, you probably have bumped your noggin. Because after spending some time with Mr. Neal here, I can tell you it's amazing what the math will show you in terms of how incredibly important balancing is.
Let me start with something here. We always talk about how to get balancing really good. And we always give you little tricks how to get there. We want to talk a little bit different today. I like to go over some things that what you shouldn't do.
That's a great point, because in the past, we have a great video in the Engine Performance Expo archives of going through the Engine Performance Expo LS, and you showed the exact process of how to balance it correctly. But as especially like you said, sometimes people take shortcuts, this, that, the others, and there's some things they shouldn't do. So what shouldn't we do, Randy?
Well, I got to tell you, if you give me about a day and a half, I can cover all of them, but we're just going to highlight a few.
All right.
The number one setup, when we first set this up, we got a crank up here that we just set up, and we wanted to talk to you about bob weights. Now, moment match bob weights versus the things we used to do in the past, all of us have been around long enough to see these things have dings, washers, weld marks, everything on it. But this is just like a micrometer, and precision made so that no matter where we roll it in axis, the center load is there. But there's one other consideration that depends on how you do this or mount it horizontally. For instance, I'm going to sit there and say, we make this little tool, it's very clever. We just set it down, push up against it, lock it, and now I would move from sequence 1, 2, 3, 4. Now, let me tell you,
so the location of that weight, left to right, is actually important.
Critical, absolutely critical. Better yet, if you ever, on your machine, go ahead and set your bob weights up. Make your sample run, get your data, just take one, move it 100,000, that's all. It's not exactly 100, just ambiguous. Go back and run it, it's gonna scare the hell out of you. Now, did it affect just this one? It affects everybody. All right, so garbage in. Just one.
Affects all of them.
All of them. The old thing, garbage in, gets garbage out. Process is critical. Now, another thing that we're doing in these things, notice this particular crank, got a series of holes everywhere. We talk about this because the mission statement of the counterweight is to offset the physical mass of the bob weight. The problem is, as we start drilling, these become unstable. We've showed in the past a couple of Swiss cheese effects.
Right.
This is borderline. But what happens is, you gotta understand, this counterweight at speed, not only does it move this way, right? But it starts to oscillate as you weaken the counterweight. Very important not to go over center. In fact, the pros, no holes.
Right.
All right. We set this thing down and we put it in the lathe, and we have software that will allow you to avoid this. So that's number two. Now,
so you're turning down the counterweight versus putting holes in it.
Drilling. In fact, our rule of thumb is no more than 2 holes, no more than a 1/2 inch deep. Anything you go past that, you're questioning, or basically you're violating the integrity of that counterweight. Now, in the old days, grandma's car, who cares, right? But you gotta understand, we're not having grandma's car. We build high performance engines. In doing so, every little thing happens, but as you increase that RPM, these become unstable. So, integrity of the shaft, materials, everything, critical. Now, as we go through, a lot of the other things that people are doing here is when they're spinning them up, we want to get good data and repeatable data. But the materials that are gliding on, it's critical that they have the right lubricant.
Okay.
All right? What happens is it rubs. If it rubs, it chatters. If it chatters, your data is corrupt. Interesting enough, use whey oil, machine whey oil now.
Okay. Right here.
There, that's right. Now, this is the same thing in a machine used on your CNCs, even your old grinders. But we want them to glide, not rub, right? Rubbing is friction, friction is bad.
Well, it's the stick slip. So if it's too dry, what will happen with the rubber is it gets what's called stick slip.
Yeah.
And that actually basically creates an harmonic that you're picking up in there.
But once again, garbage in gets garbage out. If these are chattering, the machine it doesn't come from the Messiah. It says ouch, and it reports ouch. Now you say, what the hell is ouch? Inconsistency. What I want is centripetal load. The machine will read what you give it. It'll try and analyze it. But come on, guys, common sense. It needs to glide,
It needs to spin freely, and you can't feel that with your hands. You just got to make sure that you're using the correct lubricant and being repeatable, right? Your same process.
Absolutely.
Don't use it one time, but not the other time. Whatever your process is, you have to repeat that process in order to get the right results.
Okay, well, a couple other things. We talk about different orders of balance, but as we develop engines with bigger cubic inch, a lot of people don't understand the distance from main to the rod throw is critical for torsional resistance. So as we increase this stroke and we increase the power, these units will actually get out of synchronization. At max RPM now, we're probably going to see as much as 2 to 4 degrees of torsional load.
Rotation.
Now, it'll come back, but guess what? It does this. They're going back and forth. So now we need to go to the damper again. We've talked about this a couple times about dampers.
Yep.
All right, but this is again one of those things that everybody's doing wrong. They're taking an OEM damper, putting it in a high performance unit and send it. That crank is, I'll give it a technical term. Let's see what it is. Oh yeah, pissed off. That's
yeah, it's going blah, 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 blah.
That's right. As it does this, everything about this starts to resonate and we start hitting frequencies. Now, you gotta understand, frequencies are attached. Remember, this whole assembly's got valves, it's got springs, push rods, everything else. If it finds that frequency, everything goes into hysteresis. Now, all this design process of the engine designer, out the door. And yet it can be controlled with common sense and proper application. Bottom line, horsepower generates load. And as we get these things doing this, now all of a sudden that consistency is gone. So what do we...
That makes sense. You have more power, more load. More load means more flex, but that flex isn't only one direction one time. Now we're creating this movement.
Exactly.
And now that movement can escalate, and then it reaches that point of no return where everything just goes haywire, chaos.
It's done.
Right.
That's all there is to it. So we have to go back and keep talking to the damper people. We need to let them know this is not your father's Oldsmobile. We have to understand all this stuff has to work in harmony. Now, one more thing. People are confused with percentage of overbalance, underbalance.
Yeah.
This thing goes on forever. Now, most of you always heard me say 50%, 50%. Get over this. There's a whole bunch of theories. But let me tell you one thing they're not understanding. As I increase horsepower, it does not change the first order of balance. Okay. What it does do, because that additional thrust, is that's caused that torsional. Now, all of a sudden, this gets out of sync with the rest of the crank. So moving the percentage of, in this case, the bob weight, up or down, that's a fallacy. You can't fix torsional twist with first order balance. Cannot be done. Okay? Remember, this is what this machine does, first order.
That sounds like that's more of an issue of the design of the crankshaft.
Oh, absolutely.
Okay.
You're talking to people like Nick Norris from College and so forth, and when I start telling them that we're increasing the stroke, his blood pressure comes up. And he says, you want to do what?
I want to add an inch of stroke and put a 500 kit on it.
Yeah. He knows.
He's like, no, no, don't do that.
So, but the guy then comes up with this theory of overbalance or underbalance is the remedy. Fallacy. Absolute fallacy. So don't go down those rabbit holes, right? Stay with what we taught you, and you're going to be really closer, or pick up the phone and call us. We'll talk to you anytime.
There you go. That's really great advice, because I think that's one of the things that's easy to overlook is that, okay, this crankshaft has the correct stroke for the cubic inches I'm looking for, but just because it's the correct stroke doesn't mean it's the correct design for what you're trying to do, and you may be actually cutting your own knees off not even knowing it.
Well, I think we're all self-proposed engineers at times, all right? Let's be fair, we try things, that's good. That's one of the unique things about racers. They're not afraid to try.
No, we're not.
All right? But at the end of the day, sometimes you end up with two parts, which used to be one part. That's not the goal.
No, you don't want that.
All right, so what we're saying is, understand, again, I'm being redundant, this is not your father's Oldsmobile. Go back and develop your strategy, understand. By the way, if you're gonna lighten something, piston, lighten the heck out of it, not the crank. Do not lighten the crank because you lose structural integrity. And understand on the overlap, that piston rod assembly is trying to leave the engine.
Yeah.
All right? Keep a heavy piston in, you've exasperated that amount of load. So this thing actually stretches this way. It's designed to handle load this way. All good engine builders understand that. So light is good on pistons, bad on crank, okay?
All right, so if I'm recapping what we've covered so far is, number one, when you're doing your bob weights, location is critical. Not just getting the weight right, you have to be just as critical of getting the location correct and maintaining it. The second thing is when you're actually making the adjustment to the crank to get the balance, how you remove it, where you remove it is also critical to maintaining that structural integrity.
Right.
And then the other thing is weight matters, but you want to make sure you keep the weight on the parts that are structurally integral to the engine. Lighten up the things that are moving, not the things that are rotating in a lot of ways.
Let me put one last thing. A lot of the inline four-cylinder, flat plane type cranks, they cut the counterweights super narrow, all right? They don't realize they've screwed the pooch. That counterweight has to have the energy to offset the piston rod assembly. Once they take that away, they say, well, I'm on a machine that doesn't see it. That's right. The first order won't see it. But when it's cycling, it's going to understand that, and that crank is just going to become doing a hysteresis.
Yeah.
All right, so it's important that we do that.
You're taking away that force that would have actually been correcting it. Now it's just able to bend.
Keep it simple. It's a seesaw, right?
This guy, right? Yeah.
All right, so bottom line, one last thing here on bob weights.
Yeah.
Bob weights are critical to, they're equivalent to a micrometer. They don't drop test worth a damn. All right, so when you drop them, go back and challenge them. All right, make sure they still go together properly. Make sure they're not bent, because anything you change affects the balance.
All right, that's why we got Randy, so you know what not to do when it comes to balancing.
Back over at the Rottler F69 here in the shop, Stroud Technologies, Project Pontiac. Time for an update. Lake, what do you see with our block here?
Well, obviously before it was laid on this way, now it's standing up.
There it is. There's your update. Project Pontiac.
No, what we can see that's already been done is they've already decked it. They mentioned before maybe that the bore size, it had already been bored. So the block had been bored, so they didn't need to do that. So they can just go straight into the hone after the rest of the block work's been done. But as they were measuring it using the power of the F69, they noticed something about the cam tunnel.
Yes.
Which was?
Well, Dave Bullock told me he had never seen one that was more out of, I guess, plumb, out of alignment, 037 out. We're going to increase the cam diameter to 55 millimeters, so we're able to straighten it all out and make it perfect, which is super exciting. But that's exactly where we started. Back in the day, it would be like you make the holes that are there and you surface them.
Yep.
Now you make them right and you make it perfect. And it's just so exciting to see that the machine measures it, tells you what's wrong, and then enables you to fix it.
Yeah, this is going to be nice because it takes time to do the block work correctly. So it's where we're at now. Now that they've surfaced it and done that, now we straighten it up. They're going to begin and index over here, open this one all up, then they'll flip it over, do the other side, then they can come in. This can have a right angle drive. We'll then finish the rest of the cam bearing so that it's dead straight, right size, right alignment, and that's the whole key. You got to keep this center to center, which we'll talk about a lot tomorrow because there's a whole segment with the Dortons and everybody else where we really get into detail on cam to crank alignment and the proper way of doing all this. So don't worry, we're just kind of mentioning it now. Tomorrow there's in-depth tutorial showing you how this machine can do it and do it right. But this is the backbone, right? You got to get this part right so that the engine's going to do for you what you want it to do.
Well, and that brings me to the genesis of this whole deal. We sent the engine to Gary Stinnett. We ran it on his dyno. It made 603 horsepower with the old cast iron block, and we were pretty excited.
Yeah.
And then he takes it apart and finds all these cracks. Now, the cracks came from one, making 600 horsepower in a 3,300-pound car using factory location side motor mounts without a motor plate and a mid plate. All that flexing. But we didn't know what we didn't know back in the day. The problem is, now everybody is in on the deal. And what do? Do I go to a junkyard and find another old cast iron block? Don't get me wrong, we had the Nunzi billet main caps on it, and we had all that. Do we just build what we had before again? Well, we thought about it. And actually, that's the direction I was going to kind of go until Keith Jones from Total Seal is like, Joe, let us make some calls. And I was like, okay. So Keith called the folks at All Pontiac, which are located right around the corner from Total Seal in Arizona.
Right.
They had this block, and I was able to acquire it. So that was exciting. Called Gary Stinnett, Stinnett Automotive, 4-time world champ, by the way, Foggett on board, this Foggett all over this place. He was so happy. because now he could really do something with it. He's not using old factory OE parts that may be good or may not be good. And you can see in the all Pontiac block, they've really solved a lot of the problems.
Oh, this thing is a beautiful piece. I mean, it's really nice.
It has changed what are, and the word you said, Gary had said, the foundation of your engine. And that really enabled some others to come on board, like the folks at Edelbrock, Mark, who has been here at the Engine Performance Expo. In a conversation, he's like, we can get some Edelbrock cylinder heads for this thing. So now it's going to have aluminum cylinder heads, which is very interesting to see how it's all going on. The fact that so many people, John Gadosh, well, you got aluminum cylinder heads. John Gadosh ran Pro Stock for many years, but a lot of people don't know Pontiac is his area of expertise.
I didn't know that. How about that?
He had been developing ports and runners on Edelbrock aluminum cylinder heads for many years, and he had the CNC program. He's like, Joe, send me the heads, okay? Got the heads, sent him the heads got ported by John Gadosh, and he's like, John, I want to help you, Joe. I want to help you. It's so amazing, right? And just along the line, people, my friend Charlie Kababi at home, South Florida, local Pontiac guy, you guys at Total Seal, of course, Gary Sinnott and Steve Williams, everybody has been so helpful to try to keep this project going. And it's been amazing to see. Of course, Chris Stroud calling me up, hey, we want to machine the block here in Piney Flats at the Engine Performance Expo. And I feel like a race car driver at the top end of the racetrack that just won a race and is trying to think of every single person that has helped to this point.
Yeah.
It's been amazing.
Well, then you got one really special phone call out of this as well.
So I'm working on my streetcar in my driveway, my dad's driveway at home, and I've got the rotors off. I'm putting new rotors on the front of my car, and my phone rings. And everybody knows when you see a number that you don't know who it is,
you don't answer it.
Most of the time, you don't answer it because you know it's not who you. But this time, for whatever reason, I decided to answer it. And who is it but Mr. Pontiac John Kaase, who is not here this episode,
but he's
we
been
wish
here
you
for
the
all
best.
the previous ones.
I'm sure he's out there watching right now. And he's like, John Kaase, and I'm blown away. Hello, John, how are you? I hear you're building a Pontiac. I'm like, how'd you hear about that? Yes, we are. I would love to send you some lifters for this project. And I'm like, blown away again. I keep saying it over and over again, like just with emotions and happiness and stunned. And
you end up not just with an awesome Pontiac block, but you've got John Kaase providing a set of Morel lifters.
Morel lifters are going into Project Pontiac. And it's amazing how everything kind of just all ties together, Lake.
Yeah, so the great part is it's not just taking that factory block and factory heads and trying to upgrade it. We're starting with all the best stuff. And the neat thing is, here at the Engine Performance Expo, you never know who you might see next. As you can probably see in the background, there's tons of people here.
Yeah.
There's engine builders from all over the place. And that's the great part about the Engine Performance Expo is that it brings together people from different backgrounds, different experiences, from manufacturers to engine builders to machinists, and they all come together and they share ideas, and that's how things get really great, how the collaboration really kicks off. In fact, there's a king right there. You may catch him as you walk by, right? There's all these incredible people. They gotta close the door so they can keep on doing their work back there because they gotta machine Joe's block, because hopefully tomorrow morning that block is in the H85 so we can begin to hone it, so it can be finished, so we can send it to Gary Stinnett, so he can finish the engine, so that this man's products can actually go in the block.
Incredible. Hidden horsepower here at the Engine Performance Expo at Morel.
Hi, nice to meet you.
Nice to meet you.
Nice to meet you.
Same here, sir. This is so. Obviously, we were just talking about John Kaase, a mutual friend of all of us, and John's been here for all the years. John's a great guy.
Yes, he
and
is.
so y'all have been partners in this lifter thing for a while, right?
Yes, John got involved early on, and John really grew the business. You know, I'm an engineer, own a machine shop, pretty talented, I feel, at engineering and machining and design, but not a marketer by any means. And John, got involved, and the business just exploded. I mean, as soon as John got involved, I think I've been behind ever since with my orders.
There you go. Put you behind.
Yeah. Which is a great thing in manufacturing, because The company started, it's a gear shop. It's a pretty large gear shop, and we do stuff for Cummins, we do stuff for Massey Ferguson, Danfoss sour pumps, which go to Bobcat. They go, high tolerance, low quantity, very precise stuff. So when I got involved with John, we felt that there was a big opening in the performance market because the customers, the cam companies and the customers didn't really get treated like we have to treat a Cummins engine.
Right.
You have one part out of 100,000 that's bad, you got the red light and you're getting booted out if you get two.
Right.
You can't be late.
Yep.
The quality's got to be there. The support, you have to have decent pricing. So we felt there was kind of a market for a high quality lifter that we can use our engineering on. It's fun for me making industrial parts to somebody else's print was challenging and sort of fun. Making stuff to your own design is a blast.
Way more fun, right? Yeah.
Way more fun, especially when it works.
Oh, absolutely.
It's a plus when it works.
Oh yeah. Well, I know the Black Mamba lifters you guys make. You guys helped us out with my dad's engine, and that thing is incredible. That Valvetrain just sings with those, and we also have them in the Engine Performance Expo LS, and we've turned that thing way over 9,000 RPM. It just sings like a sewing machine. It's an amazing product.
That's good to hear because it's pressure lubricated, as you know, and it can handle a terrific load because it doesn't have they call Hertzian stress.
Right.
So it's got the oil wedge in it, basically like a crankshaft, and look what a crankshaft can do.
Well, that's the key point for people that maybe not understand. You think, well, that needle bearing, that's solid, that's got to be better. But like you just said, what happens is with that needle bearing, you have that point of contact, and that stress is extremely high. If you've been watching all day, you saw Billy Godbold and Mark Malburg at the whiteboard saying, where does the failure happen? It happens at that highest stress point. So needle bearings themselves create that stress point.
Correct.
So if you can eliminate that, you take that away, that fluid film bearing is better.
It's everything.
Yeah.
Right. The loads go way up, the longevity goes way up. I mean, it's definitely the way to go. It's not for everybody. Can't restrict oil to them.
No, yes. It has it like everything, right? There's a price to pay for everything.
Right.
There's a pro, there's a con to everything, but if you can make it work in your system,
Right.
works pretty great.
So I tell people, I said, you wouldn't put restrictors in your main bearings, would you?
Mm-mm.
So let's not do it
Not
to
for very
my
long.
lifter.
So Ed, let's do what we typically do on Hidden Horsepower, and we started with John Callies joining the company, but your earliest signs that this was going to be the field that you were going to go into.
Engineering, you mean?
Well, engineering, being mechanically inclined, designing, developing, thinking, I want to know how this works. Why does it work? How can I make it work better? When did you know that was the road you were going down?
That's pretty interesting because it started until I was about 9 years old. I wanted to be a garbage man.
Okay.
So
admirable. We need them.
Picking garbage out, finding motors and bike frames. That was fun. And I have a good friend that I've known since we were 5 years old, and his dad was an electrical engineer. And you remember, I don't know, you guys are kind of young, but they had the little Stingray bikes.
Oh, yes.
And
Schwinn made those, by the way.
Right, Schwinn made them. And Gary got one real cheap, and his dad welded the head on it. And not only could Mr. Wise weld, he built the welder.
Wow.
So I'm like, he was a double E, right?
Yeah.
So I'm like, I think I want to be an engineer because this guy is so cool.
Yeah.
So, it did the typical stuff that we did, and, John Kaase and I were talking,
You need to explain to everybody that doesn't understand how important it was to weld the headset on your Schwinn Stingray bike.
It was broke. They put rake in it, and it wasn't really up to snuff.
Only of us who had those old bikes knew what would happen with
You come down from a wheel stand. There was a little chopper. It looked like a little chopper with a 3-speed shifter on it. It was the bike to have. I mean, if you were a kid and you had one of those, and then you ended up with a Rupp mini bike, then you were a rich kid.
Oh yeah, Rupp,
basically.
That's out there.
So, it did the typical things that we do when, we grew up in the 50s and 60s, is slot cars and mini bikes. And, I'd go down to the Nike site, if you remember the old Nike sites, and they allowed us to run our mini bikes up and down. And then I go and I get blown into the weeds by a guy, so then I bring the thing downstairs and I take it apart and I'm reading some magazines and they're talking about relieving the head and doing all this. So I'm grabbing my dad's woodworking tools and screwing them all up. I got his drill, and I'm porting it and I'm doing all kinds of things. And my mom comes down and goes, oh, yeah, it'll never run, right? And I went there the next week and, then that guy was behind me. So it's just fun, and if you feel it's fun to go into it. And I went into engineering, mechanical. I started as a double E, and they're talking about, the pressure in the pipe, volts is like pressure in a pipe. And, how much water goes in, is watts. And I'm like, why don't I just do the water and the pressure in the pipe thing instead of the volts and amps and, So, went to engineering, started at Gear Company. The owner then told me, totally true, you really don't know anything just because you got an engineering degree. But what you proved by that, and I'll never forget this, is you have the ability to learn that type of thing. So right away, I became pretty good asset there. I built a whole screw machine department and did a lot of fancy attachments, and it's a gear shop, and we were doing that. Well, the previous owners always wanted their own product, but they never wanted to spend the money on it. You got to make it and hope it sells, right? It's like growing the corn and you better sell it. Well, when I got to ownership, which is like 35 years ago now, something like that. I mean, I've been there 45 years.
Which I hear is a story unto itself.
It sounds like it. Yeah.
Which one?
You'd be acquiring ownership.
Right. You start off as an employee, you end up as the owner. That doesn't happen every day.
Right.
We'll get to that. Continue.
Yeah. So, I said, this roller lifter thing is fun. It uses a lot of engineering. It uses the, bearing technology, all the bearings, materials, all stuff that I got real good at in a hurry. And what I love about our marriage in the Morel Gear Company venue is I'm exposed to the latest and greatest of a Sauer Danfoss, billion-dollar companies, a Caterpillar, what's on their prints, how they're checking it, why they're doing it. So a lot of that technology finishes. I mean, talk to the engineer over, at Cummins, why are you doing that? Well, the bearing area. Well, why? It runs in a bushing. I'm like, oh, Shazam. I said, it's the same thing, an idler, high pressure idler gear is the same thing as a roller lifter in reverse.
Okay.
So you're exposed, why you got this material. It does this and this. So that's where I feel like we really had the edge because you're exposed to so much other stuff. It's not just you and your group trying to come up with stuff. You have the
idea exchange
world.
Yeah.
And some, there's some sharp guys in some of these big companies, even though, I'm not a big company guy, I'm a little company guy.
Yeah. But that's like we were saying we were walking in here, is that's what makes the expo so special, is it's that exchange of ideas, because you got guys coming from drag racing, circle track racing, and NA, Boost, and people outside, like Mark Malburg, who comes from outside the racing industry, that came from Cummins, and you get all that.
I sat next to him last night.
Interplay, right? When everyone starts to get together, that's where we all get smarter together by sharing and exchanging. But the one common element is everyone has that passion and that drive to be better, not just to be, well, it runs. That's okay.
Oh, yeah.
This isn't what this is about, right? We don't do this because it works.
No.
We want to make it better.
Right. And the stuff's constantly changing. And usually what we've tried to do, when you come out with something, we kind of followed the the Corvette, how they do the Corvette, you know, the first year, the new body, it never has what horsepower they know they can make, right?
Right.
And they don't have a convertible.
Not yet.
So they have their 3 or 5 year plan to keep improving your stuff. So when we come up with something, we try to kind of think, because everything gets copied.
Yeah.
You know, the Chinese are always trying to copy our stuff. Other people are trying to copy it. So if you have some kind of an idea where you're going to go with it, you can kind of at least have a moving target. So when they come up and copy your stuff, it's obsolete.
Yeah, the next one's already in pipeline.
But that goes right in with, you know, and we, you know, we work with NASCAR. We've been a supplier for Hendrick Motorsports for a long time now. And the information you get from those folks is just invaluable because they really, you know, you send stuff to a fuel team. Mm-hmm. And this is truth. I mean, it'll come back, you know, a 5-gallon bucket sometime with pieces of pistons and everything and taped with racer's tape and say, can you go through these? And you get stuff from NASCAR and it comes back and you better not mix it up with your new product because you can't tell the difference. I mean, how they treat this stuff. I mean, it's like, whoa, don't move them, you know.
Yeah.
So the information you get, you know, those guys are some smart guys. I mean, you go and you watch TV and you see 9,200 RPM and then you see it's singing up there and you're going, yay. It's a lot of movement, right?
And they're like, that's nothing. You should have been around when you were turning flat tappets 11.
Yeah.
You know, it's like, oh, it's a piece of cake. Should have been run all day right there.
Right. So
Yeah, which I hear there's some stories about something running all day, all night, that in the early days of this lifter thing, you had some stuff going on with IndyCar. Like, where's the origin?
Oh, yeah. The IndyCar thing was started with John Reed, who I met through Norton, Rick Norton. We were cutting some gears, and he introduced us to Reed. And the Buick V6s were super hard on the exhaust because of the turbo. You know, turbo is kind of turbo's been around since the 40s, but in the cars, it was really kind of not that big like it is now.
Yeah.
And so it was interesting. So we made some prototypes, and they were basically a solid pin, cross-drilled, a bronze sleeve inside a bearing. So it was the easy roll lifter.
Okay.
That's all the rave here 10 years ago that
Yeah.
we came out with in the 90s, right? So
For the Buick V6.
Right, for the Buick V6 for the Indy program. So this is kind of a cool story. So I'm in my 40s maybe, you know, pretty early 40s. And we're going to McLaren. Like, I had McLaren slot cars. Like in my day, you know, the McLarens were the car, Can-Am was the thing. And I'm going, you know, and Rick and I walk up to McLaren, and it's like, you're like a kid in a candy store, right? And we tell the girl, we're going to see Bernard Santivi. And she goes, oh, you better take a seat, because he's never on time. So we sit down, and she says, he's pulling in the parking lot. She goes, you guys must be important. So Rick and I go through there, and they're running like 10 Bintrons, and they're missing shifts and doing all the Indy stuff. And, you know, they're cranking this thing. And, you know, you hear them, and it's like, is it going to hold up? You know, it was just a real like kind of weird experience. You know, you're in there where your idols, those are the companies that were your idols.
Right, absolutely.
You know, like John took me to see Bruce McLaren, or not Bruce McLaren, Bruce Crowder.
Yes.
At his house.
Yeah.
Who gets to go to Bruce Crowder's house?
Yeah.
You know, so that's John. You know, he knows all those guys out there. So that's interesting.
So there's a little more to that story, that developing that lifter for McLaren for that their test was had to run X amount of time.
Oh yeah, it has to run like 4 races or something. You know, it's a 500-mile race, and they got to run like 2,000 miles. You know, so it basically didn't wear out. I mean, they ran oil pressure to it, and it kind of felt like new. And that was basically a precursor to the Black Mamba.
Okay, that's where it all kind of originated there.
Right. But the Black Mamba, where it has the advantage over what that is, look at the pin size of it.
Bigger pin.
Bigger pin. So we left the needles out completely. Instead of going with the stock, it was a 3/16 diameter pin and a bushing and the bearing. We blew the ID up and made it out of the bronze, so it runs directly, and that's all cross drilled and everything, so it gets the flying wedge. So yeah, that's how that was developed.
And that was able to go from, hey, they could run like maybe a race, and the thing was...
They weren't even making a race when they were testing because of the boost. The exhaust
there was so much back pressure
was
getting
getting killed. So that was... And of course, do you guys remember what happened in that race?
If you're talking about Roberto Guerrero, well, okay, so Kenny Bernstein, drag racer, had gone into the world of IndyCar, and they were on the pole for the Indy 500. And so, like, as a drag racer fan, like, this was a huge moment, the cross-pollination in the other direction. And it's sad.
Do you remember what happened?
Yeah, no, I remember. That's why I'm sad.
Yeah.
On the pace
what
lap.
was the pace lap?
On the pace lap.
And they had everybody covered with probably 7 or 8 miles an hour. I mean, it was big, you know, in qualifying.
Wow.
And he's doing this, and I'm sitting in front of the TV there in Cleveland, and it goes, boom.
Yeah.
The race hadn't started. And I'm like, oh, no.
No, does that, like, we shouldn't talk about it anymore. Kenny could be watching. So we don't want to talk about it.
And did you hear the interview with Roberto afterwards?
Yes, but you can refresh my memory.
He says, what do you think? And he said, I thought I was in a dream and would wake up. So that, yeah. But it's interesting, you know, like, I don't know if very many industries where you can meet your idols.
Right.
You know, I'm here with Mike Valerio, and I remember being at Thompson, the dragway in Cleveland, you know, and being 10 years old with my buddy Gary and his dad, because he also took us to the drag strip. On the fence, here comes Canned Heat, and obviously those guys were kind of at a national level. They were match race Ronnie Sox, and so, you know, but they were obviously local heroes, and now we're buddies.
Right.
You know, I stay at his house, he stays at mine. You know, Hutter was a friend.
Yeah.
You know, and I don't think that's real common in industry. Our industry, it is.
Yeah, it is commonplace in our industry.
Yeah,
no doubt about it. I don't know about others, but yeah, that's one of the, I think, great things about our industry is how interwoven and tight knit that it is.
Right.
You know, a minute ago when Billy was talking about John Lingenfelter and his ability to get everyone to rally together to build a car that he's going to compete against you with.
Yeah.
But that's the way. I think that's part of the racer ethic is that no one wants to get that trophy if you didn't race against anybody.
Right.
It only means something if if the competition is there.
Is there, right.
You know, so you want your other guy to get in the track. Well, here's the clutch, here's whatever it is. Get your car on the track so we can go have a real competition.
Right.
Because then we want to know what we have.
Yeah, we don't want to buy.
No,
no one
wants
to back
buy.
through the door.
No.
Yeah.
No.
Well, and you can be in the industry for a long time, and you're here because you love it, so you're not going anywhere. Like executives have jobs, and then when they retire, they get out of there, or they get enough money, they're down the road, right? Because they don't love it. But you guys love it, and you want to be here, and you'd be working on something regardless. And so, of course, there would be some admiration to other people who love it.
Right.
And you recognize it. Like, man, this guy coming up, he wants it, loves it. He wants to be here. So did I. Let's help him. And I see that amongst racers, and I see it amongst the engine building community.
No doubt about it. So go back to that. How did you end up being the owner of the company? Because that's, again, not a normal story.
Yeah, and Mike told us to ask you, just so you know. He was pushing a broom, and then he owns the company.
Yeah, well, I wasn't exactly pushing a broom. You know, I got started there as an engineer, and it was interesting, too. I got hired as an engineer. 2 weeks later, the working maintenance foreman quits. And they tell me, wear your jeans and t-shirt, you're now the maintenance foreman. So I'm out fixing equipment that varies from 1940s to 1970s. And, you know, a lot of times you find out when you're the maintenance guy, it's not so much sometimes the machine, it might be the process, it might be the stuff in. So you learn, it's like a baptism by fire. And I became a pretty valuable asset, and the owners wanted to retire, and one bought the other one out, and I was in the process with him, and then he got sick and he passed away, and I bought his estate out, and here I am. So I mean, it's possible. I mean, I got some guys there now that, like Billy and I were talking about the passion, You have to let these guys, like I had 24 screw machines in there. That's what we made all our blanks on. That was after my maintenance thing, I built that department. We had 15 guys at there one time, and that was my baby. Well, you can't find anybody to run them anymore. It says on the paper, I'm gonna make 120 of those an hour, and at the end of the day, I got 200 in the basket. What happened to the rest 6 hours, right?
Yeah.
So you kind of go, all right, I got this new kid, he's 33 years old. And he's like, we need to try a CNC bar feeder. I go, that thing only will do 25 parts an hour. This screw machine will do 120. He goes, well, don't look like it's doing 120, Ed. And I'm like, okay, so you take the leap of faith for a couple $100,000 on a 33-year-old kid. And he gets the thing running, and he goes, I'm gonna try it tonight with leave it run. I'm old school. You better stand there in case something happens.
Right, yeah.
He says, that's pretty good. So he comes in, I come in the morning, and he's got 1,000, 1,200 parts, and he's checking them all, and they're all good, and he's putting them away, and I'm like, oh. So about 4 months goes by, and he tells me, he says, I go, how's it going? And he says, this is the closest you're gonna get to printing money. And I said, let's buy another one then. So now we got 2. But during I went to Europe for 16 days on a cruise, and I told Scott, my superintendent, I said, get rid of my babies now. I said, I don't want to be here when they're hauling them to the scrapyard. So I came back and then they're gone. It's kind of like, but motivating the younger guys, if you have somebody that's motivated, you better give them enough rope, or he's going to go somewhere else.
Yeah.
Right. And that, like you say, the job reward. Like maybe next year I'll bring one of them here.
Yeah.
Because it's kind of a cool deal. There isn't one person out here I haven't probably talked to, and I liked every one of them.
Oh yeah.
There's no strangers in here, and it's very unique. This is my first year here.
Right.
Callie's used to come and represent me. So, and I was trying to make stuff at the shop.
We appreciate that.
Yeah, hopefully not your last as well. You're already talking about coming back. And no, this is a yearly thing, and it starts the year, and everybody sees each other and exchanges ideas and has a great time. And this is also very hard work. Keep that in mind.
Well, you guys are working very hard. I mean, I see that.
Well, I think it's interesting that one of the things I've been thinking about last couple of days is going forward, be able to go to a shop like yours and talk to one of your guys and have a how it's made type segments. That's something we really haven't done here with the Engine Performance Expo. That maybe leave it in the comments if you want to see that as a viewer. Maybe that's something we could add is visiting some of the different companies that are involved in the expo and show us how you make things, because that's always interesting.
Sometimes
what you can show, what you can't show.
Well, some of my customers want, and I told the one at PRI, he wanted a shop tour, and I says, well, I don't give smart people shop tours.
Yeah, my boss doesn't like it when I give
too
shop
hard
tours
to learn.
Yeah, he doesn't like it when I do that.
It's like there's a lot of proprietary stuff that you do, and the way you press it. I mean, if I go through a shop, I usually learn a lot if a guy's giving me a good tour.
Right.
Because, I see what's going on, different ways to check things, how they're doing things, and it's like, that stuff's hard, and the competition's lightning good. They're all good. There's no back runners in this.
No, that's the other great thing is back in the day you didn't have availability of parts and you had to make things and be improvising on stuff. Now there's a lot of parts and the quality is very good.
Right. which is, it's fun.
Oh, it's great.
My job became a lot more fun when I got into this. You know, it's just, well, you know, working with Austin Coyle. There's another, you know, all right, Austin Coyle calls me on the phone, and I'm thinking it's my brother screwing with me, right? You know, and she says it's Austin Coyle.
This
I'm
is
like,
the first time Austin Coyle called you?
Yes, ever. I didn't know he was going to call. Steve Tansey gave him my number. He was with Urson. So, you know, I pick up the phone and I go, yeah, because I'm thinking it's my brother. And I hear his voice. And he's got that distinctive voice you see on TV, and I'm like, ooh, it's Austin Coyle. That's how we got into that top fuel lifter with the double roller.
Oh, yeah.
That was invented by one of the guys that works for me. I did not invent that. I mean, he says, why don't we do it like a tag wheel on a cement truck? I'm like, what do you mean, Rick? He goes, well, put a wheel above a wheel. You know, three-quarter wheel, because the technology there wasn't there at the time for the material. And that's another exhaust valve problem. You know, Austin told me at the time they were opening the exhaust valve 86 degrees after top dead center, and roughly there was 10,000 pounds on the lifter because of cylinder pressure.
So great still because how slow the nitro burns and how early they were trying to open it.
They tried to open it, yeah. So that's, you know, we made prototypes. I said, Austin, I don't even have bearings. I don't have a source. Sent me some crane stuff. I took it apart, used their stuff, but rearranged it different, sent it to him. And he calls me and he says, we got like 75 years of crew chiefs looking at this, sitting on the desk, and can't believe we didn't come up with this. You know, at the time it was him, Bernie, I think Jimmy and Medlin, you know, and they're looking at it going, this is stupid easy.
Yeah, why do we think about that? It's like we spend a lot of time driving down the road. We've seen this like a billion times. Why did that never come to our mind?
Right.
You know, but so Tansey, that's another great guy too.
Oh, Steve,
Yeah.
he's just, you know, first time, you know, I got my lifters now, and Tim and Chris worked for Nichols, and they were kind enough to let me in, so I'm standing in the booth, you know, and I have my pair of lifters, you know, and I'm like a kid in a candy store, you know, everybody's got these giant displays, and I have a pair of lifters. And Steve comes up, you know Steve?
I know Steve.
Oh my God. He comes up and he kneels on the ground and he goes, oh God of lifters, you know, Steve. And I'm like, he's big as a Hulk, you know, and I'm like, oh gosh, but he's a great guy.
Yeah. Well, it just shows how small this world is again, right? It's you have great people in this industry, and everyone's trying to help each other. And like your product was solving a problem he had, so yes, he's like, thank you for solving my problem because I need this problem solved.
Right.
You know.
All right, let's solve a problem for our industry in that we need to motivate a next generation of young people to get into it. And we were just speaking with Jolie out there, and she's fired up about it, but not everybody is. And so, you know, what would you say to those young folks? I know that they're out there who see this as interesting or inspired like you were when you got your Stingray welded. And what advice would you give to that next generation who we hopefully see them come up and get involved?
It's not a greasy, you know, it used to be you worked in a shop, it was like you got looked on like, oh, I can't do anything else. They kind of had a connotation, well, why didn't you go to college? Well, these machines are sophisticated. These people know math. It's not as dirty as it used to be.
Right.
You know, sliding around on a screw machine was not a lot of fun. But these are talented people that are running these things, and you can make some money now. You know, if you can find a guy who'll come, show up to work, and do a good job. Part of the reason I think you're lacking the pool for the industry is the hobbies of the younger generation aren't the hobbies of the older. You know, if you're playing on the screen, you're not listening to a motor thinking that's the coolest thing. So, you know, and I don't know how you change the hobbies, but the connotation that you can't do anything else because you're a CNC machinist is totally wrong. I mean, my most respected guy in my whole plant is my tool maker. I mean, you know, to me, that's the top of the game.
Yeah.
The guy who can make a one-off, right, whatever you say, you got a sketch and you go, I want it like this. And 2 days later goes, "Hey, boss," and you look and you go, "How did you do that?"
Yeah.
And it's talk about pride. I mean, if you can do something like that, how did you get here, you guys? We all drove a car. Heart surgeon didn't build a car.
Right.
You got here. Heart surgeon's got his place, but not everybody's a heart surgeon or an NBA player, right?
Right, exactly.
So.
Well, and it's good to see, and we hope that, and I think there is. Maybe it's not going to be the numbers, but it's not about quantity, it's about quality. The right people seem to find what their passion is, whatever it is, and it's our job to make it as cool as we can, so that the 10-year-old is motivated.
And the owners, like if you get a guy with the lights on, you have to recognize it.
Yeah.
If you try to pigeonhole him too much and he really is that guy you need, he's motivated enough, he'll go somewhere else.
And that's great advice for the people who are already machinists and shop owners about how to manage that next generation too, which is something we should probably talk about a little bit more, because there's got to be understanding both ways that things are a little bit different. Great episode of Hidden Horsepower. Ed, thank you so much.
Thank you, guys.
It.
We appreciate
it.
You calmed me down. I was pretty nervous here.
You did great, man.
Because I'm not a out front type guy. I'm like
you're an old pro at that. You're an old pro. You're good. Next year you'll be great.
You're a character, and that's what we love. We love people with character and people who are characters like this guy.
Me. So guess what? We are in the home stretch. The end of the day roundtable is coming up right now.
Let's do it.
So thank you, sir, for being with us here.
Thank you, Ed.
Thank you, guys.
Thanks for the lifters, Project Pontiac.
Thank you.
Amazing. Right.
And now look at this cast of characters over here. A couple familiar faces already today, and then some more familiar faces that are joining us for the first time today. So how are you guys doing?
All good.
John Kaase, Keith Dorton. Oh my goodness, big finish, just like that. Mm-hmm. So what do you guys think? You've been out there hanging out, conversations, all that. John, jump in. You've been monitoring. What is your take?
Well, I do well at talking to people that, some of the machinery people and just even the people that are just visiting, picked up a few things, and somebody else wouldn't mean anything, but what kind of lubricant you use on a copper beryllium seed, or just stuff that you never thought of. It's amazing what you can learn from people. You just listen.
What about you, Keith?
Same thing. I mean, it's very rare that I get to interact with the people of the caliber that's in this building now, and try to take advantage of every minute of it. My brain's not capable of absorbing it all and maintaining it, but do what I can. And I've not. The only negative part about it is I haven't been able to watch you guys as much.
You're not missing a lot. No, you're missing nothing.
John and all, everybody's sharing information, but boy, it's such a learning pool.
Well, we do have, and I don't know that everybody fully understands it, but we've got a live interaction central going on out there, and it is amazing that people have been able to come out and just watch the show up on a big screen, but also talk about whatever it is that you guys are working on. So Keith, what are you working on these days?
I don't think we have enough time. No, we're just finishing up a Duramax, turbocharged Duramax for a land speed car, going in a Lakester. Hopefully next year we can brag about being the world's fastest, or having the world's fastest diesel. No offense, Kaase.
That's what we really wanted. It's okay. If he beats you, it's okay. It's okay. Jump back in.
But of course, we're still doing a lot of the flatheads and some just pretty far out projects. And occasionally we get to work on a regular old small block. So.
Very cool, very cool. John, what about you? Latest project?
I would say it's not real exciting, but lately we bought a new Rattler head machine, and because we had to have something that did an absolutely perfect job on valve jobs on new cylinder heads, and we're learning how to get all that and all our ducks in a row to get that done. But we'll have pallets and pallets of cylinder heads that we have to do valve jobs on that are new heads, and but they have to be perfect. They can't be close to perfect. They have to be perfect when they leave the building, because if they're not, it'll be on the internet by the time we get home at night. You know what I'm saying?
Yeah, no.
It's got to be right, and so like I said, it's not real exciting, but sometimes that's what we have to do to pay the bills.
Your customers appreciate that, though.
Well, I hope so.
Yes.
You spend enough money to make it happen, and some of them might not know it, but the guys really, you get parts from us, the guys really inspect that stuff really good, and it's got to be right. And so we're taking steps to make sure it's right and we don't hear any backlash.
There's been some growth in the whole mountain motor pro stock thing on the NHRA side of the world. Are you involved in any? What are you?
Well, we, for one of the first times in forever, we're building a brand new engine, which we haven't done that in several years. And but they do last a long time. We keep working on them, but they'll go for 10 or 15 years. You might be working on the same engines. You keep making it better. But about the time, I think it's not. We won't order any more parts, so you don't want any more blocks or anything else. Here it goes. They started back up. All of a sudden, there's 20 cars in a 16-car field, and then the NHRA's got 6 races, and we've got some pretty good people to race against, and we're going to have to get after it pretty good.
Well, on that note, just I had always heard there was a bit of a gentleman's agreement at some point to hey, let's not go crazy with development and put each other out of business. And I also
heard that a couple times too, and I said, what world are they in?
Yeah. So what about now, development, knowing that there's a prize out there?
We're gonna, like I said, we're going to get after it pretty good because there's some pretty talented people out there. But we're a little bit like the NHRA engines where the gains are really small. It's not that we can't get them better, but there's those 50 horsepower gains in one day. Those days are gone. Your little tiny gains maybe.
Excellent. And Billy, when we were speaking a little bit earlier about the Engine Builder Hall of Fame, just off the air, we talked about you going out on your own, and you said that you called Ed Pink to see if it was the right thing to do, and you dropped a stat on us that I'm going to force you to tell everybody. You probably would never say it without being prompted, but the launch of Godbold Engineering Solutions has been pretty strong. What were those clients that you were able to bring in? What do they do?
Well, I had 2 professional engine builder clients. I know I can talk about the elite, so they won the Pro Stock Championship, and my good friends on the Cup side did an excellent job, brought home that trophy too. So, for a first year in business, that's that's almost embarrassingly rich.
Well, it's
been very blessed.
It's amazing.
Yeah.
That's just why we are so thankful that you guys would take your time to come be part of the Engine Performance Expo and share these things with everybody, because it is that information exchange. We've been talking about it over and over again all day, that we're better collectively than we are individually. Like when Mike was in the Hidden Horsepower episode saying, here they were just digging away in their little area, but then once they started working with the guys at GM and at Chrysler, they started learning other things. Same story over and over again. It's that cross-pollination. Keith, you have so many different things in your shop. That's not only is it probably challenging, but it probably also really helps keep the mind sharp, right? Because, last time I saw you, you were working on a Mini Cooper engine.
Yeah, it is. And Jeff and I had this conversation outside with some others that. One of the, because I've always been a gearhead and a hot rodder, and it wasn't about the money. And people would come in and bring me a vintage head of some type, or bring us and want it fixed, and I'd carry it over to Jeff, and if looks could kill, I wouldn't be here.
He's like, Dad,
but he
what are you
shared,
doing?
With the people we were talking with that, I'm just opposite. And we had people that were in NASCAR that they'd come in our shop, and I'd be working on a Silver Crown engine one day and a Cup engine the next day, and or late model dirt. Mm-hmm. And they come in, are you crazy? They said. And some of those people, they're good friends. Some of them aren't doing it anymore because they were one track, and some of them expanded into doing other things. Mm-hmm. I'm gonna, before I forget it, can I say one thing?
Yes.
John used a word that we very seldom use in this industry. What was it?
I don't remember.
Perfect.
Oh, perfect, yeah.
We were doing perfect valve jobs 40 years ago, we thought.
Yeah. Yeah.
So you're perfect now.
Yeah.
5 years or whatever may not be it's perfect then.
Yeah, perfect as a moving target.
It is. It really is. But that was, I've only had one time that I can remember that somebody called me and told me their engine was perfect. And I only wish I could have recorded it because later, when he got beat, it wasn't perfect no more. Sorry but I
No. That's why we have these. That's the beauty of this, is that this is the platform where you guys can share your thoughts.
And you two missed this because back, behind the door, when we're all sitting down back there during these sessions and talking, was it 2 years ago, Keith came up to me and was like, hey, I've got this friend that I really want to help out. It's just a small block Chevy, but, he wants to pull this, RV with up to Alaska and back. And he's doing missionary work. And, we talked about it. We're like, well, why don't we do this and do this and do this? And we're trying to take a 50-year-old engine and make it better. And just a few weeks ago, the guy comes back by the shop. He has, 30,000 miles on this deal. It got so cold that they had to redo the tune because they'd never seen 20-degree air before. So it was over there to see what winter weather was like. But, we get to play with this, and with all of the awesome stuff we get to work on, getting this variety of things and trying to do things better, taking something you've done 1,000 times and can I make it better? And that's just that really lights us up. That is true enjoyment. And so much of that shop talk is going on at the Engine Performance Expo that you guys never see, but it is absolutely awesome.
Well, that's part of this thing. Right? If you're watching outside on YouTube, then you get to see this part, but there is this whole other
organism back over there.
Right, which is, I think, valuable.
It's fun.
I remember when Scooter was here a couple years ago, he said he had this very first conversation ever with Warren Johnson because he was
forbidden. The word is forbidden. You had to choose. When you were Bob's friend, you could either be Bob's friend or Warren's friend. You could not be Bob and Warren's friend. So you just had to choose. Now what's funny is you could be Bob's friend and still be Glidden's friend and Grumpy's friend and everything like that. But those guys were at it, and you just had to pick. You
were Ford or Chevy, and there was no in between.
You were Auburn,
Alabama, right?
Right. You weren't both.
Yeah.
Kaase, jump in here. You've been, I think you've been at all the expos, and so, if not all, most.
Yeah.
What are your observations this year?
Oh man, it's always enjoyable. It's a wealth of information as these guys. It's surreal to be able to sit on a panel of legends that, in my mind, these guys are just a lot of fun they're a lot of fun to hang around. They're very educational, to say the least, to hang around, but they're just they're great guys to hang around because of the like-mindedness and the willingness to help, and just hardworking. They're very driven, very passionate about what they do, and so that's for there's a certain amount of kind of like the birds, that all the flock together. Yeah. It's very similar in that manner, and you don't, when you're in the shop and you're working, you're looking at what's ahead of you, and you don't get really a chance for the camaraderie and the to hang around those type of people. And it's fun, to come to the Engine Performance Expo to be able to get to catch up, see who's doing what, and how the year went for them. So it's always fun.
So what are you seeing in business right now? What are you feeling?
Well, we're in a constant state of growth. I don't want to get too much into this, but right now we're for about 40 employees in, and we've got a commitment to go to 100 employees in the next 4 years. So we have got a lot on our plate all the time. So there's been a lot of growth for us this year. We've been working really, really hard. We're talking about making things better. Engines are always one of the things that we're constantly talking about making better, but making a company better is something that's very real and very important. The development of that, for me, a focus has definitely been this last year. It's not something that you can take your eyes off of. There's constant development and growth. We talk about engines and torsional loads, and we talk about bending and twists and moment of inertia and all these other things that affect it. And though it seems like there's a ton of things that go on with an engine and all the different forces that are acting on it, business is the same way, because the forces that are acting on it are always people. and there's always some changing momentum that's going on there. So that's been a big part of what I've been up to. And then we're going after a land speed record for in all things, a Ford Excursion, pulling a trailer across Mirage or wherever we're going to wind up doing this at. So we've got a lot of work ahead
Right,
of
you're
us.
going to have to like break that down for a second,
Sorry,
a little
okay.
more in depth. A land speed record while pulling a trailer?
Yeah, so right now the current record is held by a guy in a Duramax. We're going to do it in a Ford just because we like hardship in our life. And but anyways, we're going to do this in a Ford Excursion. So we're actually doing it on the Diesel Masters. We announced that on the last episode. So we're going to be working on, we're trying to get Airstream involved in this. We'll see how that goes. But we'll be doing. The record is that the trailer. I think you have to. There's certain requirements for this trailer. It's basically a camper style trailer. So there's some ground rules that are set up.
What is the current record?
142 miles an hour.
Okay.
Pulling a trailer, which is it's a little.
What could go wrong?
Exactly. Yeah. What could possibly go wrong?
Now, an excursion. Now, don't they have? Right. Now, most of the land speed stuff, they put a limit to how much something can weigh, right?
Yeah.
Not a minimum weight, but a maximum weight.
Right.
Can you get an excursion under the maximum weight?
Well, this one here is what there was no limitation there for us.
Okay.
So that was pretty nice, and that was some of the problems that they had the last go round. We've become, we're friends with the guy that held the record. So going forward, he's lended a little bit of some help and aid there and some suggestions. And I said in the episode, the greatest ability is availability, and that's really kind of what we had. That was some of the things they were fighting, camper shells and different things like that. On the last one, it didn't have that, and some of the wind dynamics they were fighting off the trailer. They're going to do this, and it seemed like the Excursion for a production vehicle ended up being the We'll see.
What could go wrong?
Yeah.
John Kaase.
Yeah, but everybody that's here, all of us are thinking, what could we do to make that better?
Right.
Yeah. I mean, would it need a wing on the back of the trailer? Right. Will the thing lift off the ground after it's 100 miles an hour because it's rising up? There's all these thoughts that go through, but that's kind of like what we're stricken with here is everything you look at, you try and figure out.
The Excursion's big enough.
How you can improve it,
So all of us can load up and go when we get ready. So
Yeah.
I'll give you a call.
Are you going to drive?
Well, it's to be determined.
Okay.
Yeah.
I'll watch.
Since he flew stunt planes, he's safe to drive.
Yeah, no. Someone's got to document the whole thing.
If the trailer does something goofy, just don't lift.
Quick disconnect from the trailer.
We'll see about that. It's a rental.
So day one in the books, but we got a whole nother day tomorrow, and we're going to run through a lot more content. But some common themes through all Engine Performance Expos. But what we've seen, and the way I look at it, is we get further and further away from 2020 pandemic. That's when we had our first time here, and it was just so different to hear what the hitches were, what the choke points were. We can't get parts, we can't get anything, we got to make what we've got last. To everyone has said it's much better now, maybe not as good as it was, maybe better, who knows, but finding a way, that's what this group does. They find a way regardless. Speak on that a little bit, Billy.
Yeah, I mean, that's the whole passion of our industry, is built off of, you talked about over here, you're talking about like a virtual, kids who are in the virtual world versus being kind of in the real world. In the virtual world, you usually get kind of stuck that you can go path A, B, C, or D. Like we're talking about with his land speed. It's like, well, should I put lead in the frame? What tires, what are the rating of the tires? How much weight can they take? What do we do with the aerodynamics? How short can I make the tongue? There's all these things that run through our mind. And so that's the passion of this group, is trying to figure out creative ways when there are no real limitations to what you can do. How can we let this creativity, this tinkery way, just like John said, he's talking about 10 different ways. I was thinking about, all kinds of different stuff. How low can it be? There's all sorts of stuff. And, they've got like one of my dear friends, Kenny Detweiler, just loves the land speed stuff because there's not many rules. And of course, you're out there with him every year, and these guys. I mean, they'd have to build a new shop to hold all the trophies that they have from all the land speed stuff. He didn't mention it. This guy won his customer won the Mountain Motor Pro Stock Championship this year. So, these guys they're doing awesome stuff out there. They push each other, and they're contagious. Just like we talked about with the Engine Builder Hall of Fame. This guy's over here building he's not out there promoting his business. He's trying to get people to donate stuff for a high school, elementary school, get people excited about engine stuff. Mm-hmm. And I'm excited about, I know where an engine that's cut up that we could bring and let these kids play with it. It's a different deal, and it's so much fun to watch. How can we how can we share how cool this is? How can we give people this view? My wife and I do a lot of backpacking, and to take a couple that's never been out and show them a morning view over something awesome in the Smokies and let them see something and see what we love in their eyes is awesome. And that's what the Engine Performance Expo has been about. It's letting people see things from our eyes. I'm very proud to be part of it.
Oh, and it's neat. You can see it in the comments on the videos. So obviously, this is the 2-day live stream, but then over the course of the year, it gets broken up into little bite-sized pieces because this is a lot to take in all at once for anybody, even me. So when it gets broken up and becomes the mini-series, I see the comments and how appreciative people are, because some people, you could be in Australia or somewhere else and not being able to make it to PRI or other trade shows, but they get to come and they get to go in your shop. I mean, John, you do know that your tool video is still like the number one. Like people make comments of that every day. Like, oh my God, why didn't I think of that? It's pretty crazy. That very first one that we did, and that's the beauty of doing it this way, is that it keeps giving. You make the video once, you share that little nugget, and now it keeps on going back. You think about the conversations and the things that have happened at AETC back in the day. If you weren't in the building, it didn't exist. At least now, what we do here on the stage and with the videos, it exists. When we get to go to your shop tomorrow, right, we're going to be doing line boring on an R07. Well, how many people have actually seen an R07 block? And then, Jeff's going to be sitting there line boring it, and you guys are going to be talking about cam versus crank alignment and all those things. So it's going to be fantastic tomorrow, because it's not just here. All the video segments that are either when Owen's in your shop or at John Callie's place talking to Scooter at your shop tomorrow, all those things bring value. I mean, I think back to your place when you were making the connecting rods. All these little things we just keep giving back, because we were talking to Ed a little bit ago, right, about doing that shop tour. And he's like, I don't know about that. And it's like, I get it. That's the normal thing. And I get it from a business perspective. You don't really want to do that. But the reality is, we all will get better if we share more. It keeps pushing, because, you may show something to somebody. They may use it against you. But you'll learn from somebody else a way to use it back. We'll all get better as we keep sharing.
Yeah, Scooter used to say, Scooter Brothers comp cams always say, the more you tell, the more you sell. And because he'd let me go out and do these seminars, I'm like, okay, what's off limits? Like, well, okay, what are you contractually obligated not to talk about? Okay, everything else is on limits. I'm like, everything? Yeah, everything. It's like, because like you said, that, and honestly, sometimes what we're here is, we don't want people to take up golf. It's hard on your knees. It's no fun. You lose balls. Go into motorsports. It's a lot more fun. So let's tell people about what we do and why we do it and why it's cool. And, and we're liable, it's going to help our businesses more than it'll hurt them. I guarantee that.
Yeah. It's got me in trouble a couple times at Hartford. Having the scooter mentality, like, there's nothing off limits. Right?
What's contractually, what have you signed a contract saying you will not talk about?
I didn't show any of those pictures of those things. Right. I didn't talk about any of those people that we do business with.
What about the secret door? Did you go behind the secret door?
No, that's what I'm saying. I showed them everything but what was behind the secret door.
That's it. Then you're good.
So fine. We're all
No, it's interesting to see, and as I'm scanning through some of the comment sections about, just different parts and pieces and machines, and does Rottler have this fixture, and just it's sparking curiosity from everyone that's watching live. And of course, we appreciate you guys out there, and thank you for that, and adding to the show. And I'm trying to weave in some questions, of course, here and there, certainly topics for what people are interested in, because it's just it's inspirational. Like you get in a rut, you start thinking about something, you see a conversation like this, and it maybe inspires you to go out and do something different, get involved, do something a different way. Like Keith, you told me last night, you've got a goal that you've set for yourself. Speaking of land speed.
Yeah, I guess maybe that's why I was asking Kaase to get a drive. I'll be 80 next year, and on my bucket list, I want to try to get in the 200 mile hour club. So we've got a car, and going to let me use. Of course, we got to have an engine. No, we got an engine. But I'm looking forward to that. It was a challenge. Wife's not real happy about it, but
But that's planned for this year, weather permitting.
Weather permitting,
Salt permitting.
next August. Yeah. So hopefully next year you and I will have a lot to pat ourselves on the back about.
Yeah. Come back next year, you'll be wearing a red hat instead of.
Right.
Yeah. So you get that red hat, you gotta wear it.
Yeah.
You gotta
Don't
wear
worry.
it.
I'll be like Chris Rasky.
Exactly. Yeah.
He sleeps in that hat.
Yeah, Chris is awesome, man. Yeah, no doubt about it.
Can I say one thing? To follow up real quickly about what Billy was talking about on that one engine. One of the critical. This guy devoted his life to sharing the word. Went to Anchorage, Alaska, in this thing. It was more stress on myself and Jeff, that thing, because he only had a few hundred miles on it when he left to go to Alaska. Sent a 56 Chevrolet truck. That's how he attracts attention.
Okay.
But boy, I thought I worried about an engine going to a real prestigious race, Daytona, whatever.
Yeah.
I was sick worried about this thing.
Yeah, going to Alaska.
Yeah, and it's just a street engine. But we increased his mileage. It was good. He said the biggest problem he had was going up the hills in the mountains where these new high-dollar new trucks was pulling a trailer. Mm-hmm. He had to let off the gas to keep from running over them.
That's crazy. But if it blew up, it'd blow up exactly the worst distance from any place with civilization. When you're about 500 miles from Alaska or something.
Yeah. I wonder. That's an interesting subtopic in that, dealing with the stress of a job. Everybody has to deal with the stress of a job. And I think about, personal safety obviously is a big part of it. And you guys have that, right? People are getting in these cars and machines and it's got to stay together. And if you kick the rods out, there's much greater chance something terrible could happen. But just that example, every engine you build, every part you machine, somewhere in there, you've got to be thinking about the consequences of the failure and live with that. And that's got to be tough. Mm-hmm. If I misspeak, I'm going to be annoyed at myself for the next few days or weeks, but everyone's going to be okay. You guys have a different scenario out there as the engine builders, whether it be for racing or for helping a missionary. It's something that you can't just forget about it or blow it off.
Yeah, I dare say none of us, most all of us here haven't lost a close friend to motorsports. So it happens. Is it going to change anything? No, we're not going to quit what we're doing. But you got to remember that. But, you get butterflies before a race, don't you, when one of your engines are out there?
Sure.
Yeah, I do too. It might make you nauseous. Not so much worrying about everything. Safety, is it going to kick the rods out? Is it going to run okay? And it's much like I've had the conversation, much like entertainers before they go out on stage. They've mentioned maybe they're doing it for all their life and they're going to throw up or something.
I remember the first time I met Mark Cronquist when I was hired at Gibbs, and I went up to him and said, I'd never met him before, but I knew who he was obviously, and I said, obviously you're entrusting me to be in charge of this oil program and be in the middle of all this stuff. Just know that, I've never been an engine builder, but I can recognize the stress and the responsibility you carry. And I said, I remember J.E. Beard was my dad's engine builder when he won at Darlington. And I remember the last, 7 laps of that race. I mean, Dad's lapped up to 3rd place. So we're a mile in. I think he's like 19 seconds ahead of Quickie. I mean, we're gone, right? Just don't blow up, don't have a flat tire, you're going to win the race. And all the other pit guys are up on the pit wall, they're watching. J.E. is looking the other direction. He's ghost white, like that wall. Nerves. Mm-hmm. I told Mark that story, and it's like he handed me the keys to the kingdom. He's like, oh, you get it. You understand what I'm going through. And I'm like, I won't let you down. I'm never going to do anything that's going to put you in jeopardy, because I understand what's at stake. That there is a human holding that steering wheel. And either it's their safety, but it's also their livelihood. What happens in that race may or may not affect if they have a job next year, and what happens to their family and all that. At the end of the day, it is personal, and you got to treat it that way. But that's what makes it. But that's what's part of that alchemy that makes this so wonderful. It's competition, but there's also human drama in it as well.
When that checkered flag falls, it's like you breathe again. You didn't realize you've been holding your breath.
Stop breathing.
Yeah, when one goes, I mean, one year at Daytona, it was Rusty Wallace. He was leading the mid, and like you had to understand, Rusty Wallace never won restrictor plate races.
Nope.
And he's leading Daytona, and they do a last green flag pit stop. And he just shoves it down to whatever gear for whatever RPM, and he just going in the pits and drops the clutch. And had the in-car camera, and just saw the tack needle go over to the side, just peg over there. And the dread that came over me at that instant, and my phone immediately starts ringing, and it's different guys, and like, well, how many more laps you think it's going to stay? I was like, I don't think it's going to get out of the pits, It went like 3 or 4 more laps. It looked like it was fogging for mosquitoes down the back stretch. It had broken every intake spring in the whole thing. But you see things like that, and you're watching these things, and you're just right there on the edge of the street. And one of my good friends got fired from that. Was because he's the engine builder for that program. You see somebody, that's Mike Egge, really good guy, gets fired because of that. There's something to this deal, that it's real, and it can. You're watching these things, you're watching these races on the edge of your seat, and what you said, when the checkered flag comes and it goes through and the race is won, you're just like, it feels like you have not had a full breath in, the whole time.
But I think don't that kind of emphasize how much you really put into it yourself?
Yeah, you try to do everything. You never go to a race with exactly the package you want, because man, if I could do this row and this much, this could be this much better. But you go with the best you possibly can do, and you get out there and you hope for the best, and you know that if everybody in the whole organization is doing it at that level, then great things are going to happen. And it has to be every individual throughout an organization. Right. It's not just one person.
No,
it's the whole group.
Always a team. Mm-hmm. And we're thankful for you guys to be on our team. Joe, I think day one
in the books.
In
Checker
the books.
flag waving.
That's
you
right.
You may all breathe. You may all breathe.
Exactly.
Hey, Lake's tired.
Never gets tired. Never gets tired. No, but it's been an exciting
day. He's the Energizer bunny that's lost a step.
It's all good. We're just getting settled in for tomorrow. So this is day one. All done. We'll come back. We'll see you tomorrow morning, 10 a.m. Eastern Time, for the final day of the Engine Performance Expo.